Hello,
What's going on?
everyone, and welcome to AWS on Air featuring AWS Container Day. It's going to be a whirlwind 8 hours of sessions about containers and all things having to do with containers and Kubernetes. I'm joined by Aaron Hunter.
Hey everyone, my name is Aaron Hunter. I'm a technical trainer with AWS Training Certification. So happy to be here. Thanks for having me join with you today.
Thanks a lot, Aaron, and thanks to all of our guests coming on to the stream. If you're not familiar with containers, maybe we should chat about what containers are, why they're so important. Really, why are we talking about containers today, and kicking it off? I feel like containers have seen such an explosive growth in adoption just because of how easy they make developing applications.
Yeah, it really helps to reduce the DevOps burden. That's for sure.
Yeah, it seems like just a few short years ago, when we wanted to develop an application, it was a case of let me log into this this box, this EC2 or this VM using SSH. I'm going to get in there and I have to install my runtime on that. I'm going to have to make sure it's configured. And then containers come in, and I realized not too long ago that it's been probably 5-7 years before since I would log into a box with SSH and start installing Node.js on it or installing Python, because now my applications bring the runtime with them. I have a container image, just one concise package for wrapping up my application and its runtime and shipping it anywhere, my dev machine, the cloud, anywhere that I want to run it.
Exactly. A lot of dependencies that you no longer have to be dependent on because it's already packaged into the container, and then you can just kind of take that container and ship it wherever you need to.
And there's container orchestration today. So we're running this concurrently with KubeCon right now. A lot of folks are talking about Kubernetes right now at KubeCon, and container orchestration has been huge for container applications as well. We used to go from a world where capacity was a pet. You would launch an EC2 instance, maybe you gave it a name, and you named it after a Star Wars character or something like that, and then you said, this is my machine that's going to be running for years on end, and I'm going to load my application on there, and it's going to keep running on that particular machine for hours on end, or days,
you said name it after
years.
a Star Wars character. Who would you name it after?
Let's see. I always used to go with dark side characters. Just because it was more fun, it was more fun. It was more fun to have like an evil character for my boxes.
I worked at a place where they didn't name it after like a Star Wars character. They named it after fruits. So there was like there was strawberry and banana and plantain. I don't know why.
Anyway. I like that. But yeah. So I mean, everybody's done it. Everybody's done it. If you've been in the industry for long enough, you spin up a server, you give it a name, you start running your application on that server. But with container orchestration, we started to reach a point where the servers don't have names anymore. They have an auto-generated name. You don't really care about it anymore because it's just raw capacity that's going to be sitting there behind the scenes, and it can host any application you want. It can host multiple applications. Even throughout the course of the day, as applications scale up and down, that server may be running one application in the morning, a different application in the evening. Maybe it changes which application it's hosting every hour or every 10 minutes, depending on the needs of the system. So we have a much more flexibility now to think about scaling and think about deployments in terms of the application itself, rather than thinking about the application in terms of that capacity. My application isn't a server anymore. My application is separate from the server, and I have these two separate things to think about. Capacity versus I just want to run 100 copies of my application. I don't really care what type of server they're on or size, because the container orchestrator will figure out a good fit for my application and how to distribute it across that.
Exactly. I remember seeing a talk from Claire Ligori, one of the principal software engineers, a couple of years ago, and she talked about how containerization helps with scale. And then there's also different underlying mechanisms as well, or different launch types that can also help scale even faster.
Oh, yeah. So today, now with EKS, we have Kubernetes to orchestrate that. So we're going to actually bring up a keynote from Sam Cook, where he's going to talk about sort of the state of the union of containers and EKS as a container orchestrator. Run a transition.
We're trying to fix the live feed. Give me 1 second.
Yeah, sure. Well, this is where I should have like a good joke or something to go.
Testing, testing. Can we go? They're transitioning over to you now.
Awesome.
I'll give you a thumbs up when we're ready. You're ready.
All right. So I suspect if you're at KubeCon or you're at all interested in EKS or Kubernetes products, you probably know this, but quick refresher on why. I think the Kubernetes kind of took the world by storm with its declarative and self-reconciling. It's very flexible. It's very extensible. There's pros and cons to extensibility and flexibility, as we'll talk a little bit about later. But that really got people in the door looking at large-scale deployments. That's super useful. A lot of this is very handy for maintaining a consistent approach to things. The other aspect of consistency is really the fact that whether you're on-prem or in the cloud or in a hybrid style of environment, you can actually manage things the same way. So you have the same consistent API across things. So as people are on-prem looking to move into cloud deployments, it's really nice to be able to modernize things, to move into container-based microservices on-prem with Kubernetes, and then migrate yourself into the cloud as a two-step motion for large deployments. So that's been very, very handy for folks. From an ecosystem perspective, there's the big cloud map that the CNCF has. A lot of exciting things are going on in that ecosystem. There's a lot of different options for people to choose from. And so you get a really nice selection of things to choose from. Again, pros and cons. Pros of choice is you can be very selective. You can pick what works just for you. And the cons are it gets very complicated, right? And anybody who's ever looked at that cloud map recognizes that it exposes a certain amount of complexity that is very valuable when you get the choice on what you want to deploy and how you want to deploy it. And then the other thing that's really become, has taken off over time is the notion of community. There are a huge number of enterprises leading with Kubernetes, running all of their major production workloads in Kubernetes. So it has the backing of the enterprise in terms of being ready for use in real production environments across real scale. And that's kind of where we, as an organization, have come in. So when we started out, the first thing we wanted to look at was what is it that customers are asking for? So as most folks know, containers, services, teams inside of AWS existed pre-Kubernetes. And as we looked at the Kubernetes environment, we went and talked to customers. What is it you're interested in? Where are you trying to go? Most of these were fairly self-evident, even to the customers. Azure had the most important things, especially if you've been moving from sort of a legacy on-prem environment. You're really looking for ways to move faster, to meet your market needs faster, to be able to push changes into production faster, take advantage of some of the more modern development techniques. That was a very common ask. Dropping your total cost of ownership is the thing the cloud is all about. And so when you get into a container-based environment, you're able to pack things tighter, run things hotter. You can get better utilization of your resources. And if you're in the cloud, you're doing that only for what you're actually using. So you're not using CapEx on either oversubscribed than undersubscribed, and you're paying the balance of the difference. From a performance and scale perspective, you want to be able to burst up your workloads. You want to be able to shrink them back down, pay for what you use. And then you want security and isolation by design. And we're going to talk a little bit more about that one later. But one of the big premises from an AWS perspective is security is our most important factor. You have to trust where you're running or you don't get off the starting gates. And so that's a big piece of both from a customer ask perspective and from a build perspective from our side. So we set out with a set of principles on how we wanted to approach building Kubernetes products from AWS. And I think it's really important to capture the right-hand side of this slide first. One of the things that we wanted right out of the gates was to recognize that this is a community, it is an ecosystem of players outside of AWS. And so we wanted to stay native and upstream. We wanted to leverage Kubernetes, not fork it, not go change it, but actually leverage it, help it be a stronger community-based thing. We wanted to stay committed to open source. And as you've probably seen, and we'll talk about today, we've shifted a lot of our development activities to be in the open when it comes to Kubernetes-based solutions, things like Carpenter, which we'll talk about a little later as well. We are building more and more things in the open, in the community, with feedback from the community and contributions from the community. So that was a really important factor for us, was we're not trying to do that classic sort of embrace, extend, extinguish thing. We're actually trying to join an existing community because it already existed when we got here. The second piece for us was that security first and built for production. We strive to build highly reliable, highly secure infrastructure that people can leverage. And so we wanted to bring that strength of AWS into Kubernetes. That was one of our main goals. And in the middle here was this seamless integration idea, which is AWS has a lot of services. If you've ever looked at the list, it's pretty long. There's a ton of things you can choose from in that ecosystem, if you will, of services. And we wanted to be able to extend those services into Kubernetes users. So make it easy if you're running in a Kubernetes environment to take full advantage of the rest of the AWS services that you might choose to use to maximize your momentum, your speed to the market, whatever you're trying to optimize on your side, either technical or in terms of your business needs. And so that was the other premise. So that's kind of how we've split this as we started out. In terms of that open source commitment, we've been making contributions across quite a few different areas. Our contributions are more than just code. We certainly jumped in with quite a bit of code work, but we also have been emphasizing testing, especially this year.
Looks like we have some technical issues, folks. We're going to try to get the live stream back on as soon as possible.
That I'll talk about, we've emphasized more and more on which moves at about 4 releases a year, and we've got it back to 3 now, right? So you put these two next to each other and you've got some challenges, right? And Kubernetes is innovating quickly, which means you've got beta APIs, you've got testing things going on. You have a lot of change in that system. And so we've been working really hard to strike a better balance for the ecosystem, for people like yourselves who are trying to run Kubernetes in production, where you have real challenges in this balance, in trying to explain to people that I need to stay on the most current release change. we've taken the approach that we want Kubernetes to be available to customers regardless of where they are. So at the top level, we have EKS Anywhere and EKS as primary products at the bottom of the stack. This allows you to be able to go onto your infrastructure in your data center and run Kubernetes from AWS, all the way up through the classical, I guess now that I'm talking about history and past, classical AWS region-based EKS and everything in between. So this was an intentional goal to allow customers to have a consistent experience, the same support people, the same service team backing you regardless of where you're trying to run your Kubernetes workload. If we dig into that just a little bit, sorry if it's a little bit of an, but this is kind of how that breaks down. It's kind of important to understand the nuance if you're interested in this switchover. So the biggest change is kind of in the middle. So we have EKS in the cloud, our classical regions. We have local zones, so you can think of these as low latency metro area focused data center. Then we have wavelength, so very low latency, oftentimes used for applications that need to be at the edge, like a cell edge style. Outposts is where you have your first entree into on-prem your data center, but cloud connected. So outposts are connected back into an EKS region, but they can run disconnected. So these are great in sort of manufacturing style scenarios where you've got workloads that need to run at one of your dedicated facilities. And for whatever reason, this seems to happen a ton. Somebody with a backhoe cuts the fiber link just outside while they're working on some plumbing or something, and you lose connectivity to the cloud. These can survive that for up to 7 days. So they can go repair the fiber, you're still running, you don't suffer any kind of outage resyncs at the end of that. So that's been a really nice way to extend it into on-prem, but with a much more managed by AWS feel to it. And then Snow devices are launched now. That's EKSA on Snow. This is at the edge. These can run disconnected for very long periods of time. And then you get into EKS Anywhere. And EKS Anywhere, what you'll note is the control plane is on-prem. So this is intended for environments where you are truly firewalled out. You are not going to connect to the internet, let's say, at all. And so you want to run your own thing, but you still want to have support from AWS, consistent views, same service team backing you up. If this allows you to run in that fully disconnected mode all the time, so you're never connecting to the cloud. Comes with more management for you because now you're managing this in your environment versus us managing it on your behalf. But it gives you that flexibility and still gives you the consistent AWS experience. So a few areas where we've spent a lot of our time is security and availability. And one of the things you get in quotes for free, if you're running EKS, is we do automatically span you across availability zones. So that if there is any kind of issue in a particular AZ in your region, we are still live. We spread our control plane across AZs, 3 AZs, to ensure that we don't have outages due to single AZ issues. And that helps you with a robust sort of response in case of a large scale event, for example. We also do a lot of work around security patching, providing CVEs. There's various things that we have backported to earlier versions of Kubernetes releases in order for our customers to take full advantage of them, even on releases where they aren't supported upstream. There's a few examples of that we can talk about. And then we typically are supporting 4 Kubernetes versions at any given time. We've made exceptions and made it even more than that in certain scenarios. We try really hard to work with our customers, understand your needs, make things that are going to work for you in your environment. And so that's been very, very useful. We do automatic upgrades of worker nodes and control planes, should you choose to do that for your worker nodes. And we will do, I think Nate's going to talk about it. We're going to do a fair amount of work in this space because, as I said, in that balancing act, this is one of the most challenging areas that people are facing these days is these upgrades. And so we're pretty focused on that right now. And so this sort of setup is what allowed us to really keep things enterprise grade. And that was one of our key focuses. The other one I had mentioned earlier was we want people to be able to take full advantage of AWS and the huge array of services that AWS offers. So in the heart of this, you have EKS, but there's this set of higher level services, Amazon EMR, Guard Duty is another example. We want you to be able to take advantage of these higher level services through integrations with EKS. In fact, we'll talk more about Guard Duty today because we've just launched some exciting new stuff in the security space. Infrastructure services, obviously your nodes are going to be EC2 instances, but there's more infrastructure things around IAM, key management, other things that we want you to be able to take advantage of inside of AWS, but from within your Kubernetes cluster. And then of course, there's a host of supporting services queuing services, database services, et cetera, that people typically are going to use in any significant application that they might be building and trying to deploy in Kubernetes. So we spend time with a number of different ways to do these sorts of integrations. And we're certainly interested in feedback on how that journey has worked for people. We see people taking advantage of across all three of those areas today, and expect that to continue because there's a lot of strong supported services that people want to take advantage of. So let's take a look briefly. What have we been up to? What are some of the latest changes we've made in the upstream work? I thought I would just have a couple of things to talk about. The team sent me a list of 47 items, and I thought I'd better consolidate. So I went with three that I thought were really interesting. One, new gzip defaults for the Kube API server. This was an interesting change. It's something that we discovered as we were doing a bunch of testing internally and working with some of our clients. But if you're heavy on list calls, we were able to reduce list call latencies by about 80% on average, even higher in a lot of situations. So really nice performance win there. On EC2 utilization, we also saw up to 40% drop in CPU memory for list-heavy use cases. So really nice change, quick win, speeds a lot of stuff up, reduces your cost on the EC2 side by dropping that utilization. And so we've rolled that upstream. I forget which release that landed in now, but rolled that upstream not too long ago. In the etcd space, we spent a lot of time on etcd. It's on the critical path, obviously, in the control plane. Couple of areas here that we focused on were static IPs as well as static volume support and rolling that upstream. This really helps in sort of MTTR, which is the mean time to resolve situations where you have a system go down and the recovery time is much, much faster if there's a static IP because the reconnect time is a lot faster. You can reattach volumes instead of having to go and get a new volume. So saves a lot of time in these areas. It speeds up our cluster updates quite a bit as well. So a nice change from the etcd team. And then the biggest change most recently, which has, I think, been pretty loud in the Kubernetes ecosystem recently, is the registry.ks.io change. So last year here, we announced a $3 million funding effort for CNCF from AWS. This was what our goal was with that funding effort, was to ensure that this could happen, which was to split out the registry source to be vendor neutral. This is really valuable in the end. It's just finished rolling out, I think, pretty much everywhere at this point in just the last few weeks. It's valuable partly because for AWS customers, your source for these images will now likely be in the data center you're running in. So you're no longer going to reach out across the internet to pull sources, so that trust issue is gone. You're pulling from a local data center, which means it's going to be a lot faster when you're pulling images because they're actually going to be cached there locally. So nice performance win on that side for customers. The other thing that's frankly really nice about this is it saves the CNCF a ton of money they were spending on the data transfer fees. So as people are pulling things, CNCF was fitting the bill. And so they were having to pay for all of these transfers into AWS, and it's just easier for us to support our customers by having those things locally. So lots of work went into this. Huge shout out, honestly, to some of the Google folks who helped us with this because we're pulling things out of their space, and they were super great to work with on this. To make that change happen. And I think the general feedback and response has been really positive. If you have any feedback on that one or you see anything in that space, let us know. We've worked really hard to make that a seamless transition. There's lots of blogs and different publications to make sure people are aware of changes that you need to make on your side with this rolling out. Carpenter, I mentioned at the beginning, Carpenter was done as an open source project from the beginning. It's had a lot of uptake. The general theme here is the right node at the right place. This is, again, in that sort of theme of ease of use or changing the abstraction layer. How do we want to approach node selection? Bin packing. Some of these are tasks that typically people have been selecting their own EC2 instances, hoping they got it more or less right, or worse, no offense to developers, listening to the developer who says, I need a ton of cores and a ton of memory, and you're not quite sure how many they really need. So we've been working with Carpenter to both quickly right size based on what we're actually seeing going on. So we can also cost optimize with that selection. So as we pick out nodes, we will pick least cost nodes. In a lot of cases, we can save you money that way. And then the fact that it can go and do these adds and removes really fast in like 15 seconds means that you're able to actually take advantage of the flexibility that the cloud gives you by handling bursts and, more importantly, downsizing faster, right, which will reduce your overall costs. And so Carpenter's been super popular in this regard. We built it as scalable, production ready, it's intended for broad use across our EKS customer base. And we're continuing to evolve this. There's a lot of exciting work going on in the Carpenter space. Nate will probably talk briefly about that this afternoon as well. But we're pretty excited about where this is headed. You can imagine lots of interesting things that we would love to hear from customers about, would love to hear from the community about in terms of new abstractions, which would save time, save effort from an operator's perspective. And so that's an area that we're actively exploring. From a console perspective, it's kind of interesting. Consoles are both really exciting and really boring at the same time. They're boring because most people are actually using APIs and CLIs as their automation targets. If you're using GitOps, you're not using the console. All true in theory until you actually need to just go look at something live. Then the console comes in very, very handy, right? So the key thing here with the console that's interesting that a lot of people don't recognize is the EKS connector will let you visualize from any cluster, not just an EKS cluster, any Kubernetes conformant cluster. And so it'll let you get a quick view into your areas, any of those clusters you want to look at. We also do expose status and metrics in the console. So it's just a nice quick way for people to go and have a look at what's actually going on when you need to do that live. It's also really great for new people who are coming on board. Go through the console workflow, learn a little bit about things before you start trying to automate stuff in the back end. So it's been very good for that. I talked about EKS add-ons and I talked about managed add-ons. We've also been enhancing the configuration capabilities in this space. So for us, this was big ask from a lot of customers as the managed add-ons came out, which was, I'd really like to do the configuration as I'm deploying, not deploy it and then configure it because you're making it a multi-step process. And so that's the big change that's happened here is you can actually go ahead and do the configuration and push that with the add-on as you're deploying it. So it saves a couple of extra steps. It gives you that control. You can do modifications at any time. So it's a nice time saver for folks who are using add-ons and managed add-ons. This is a new one that just launched. So I talked a couple times now about GitOps and the fact that that model is something that's super attractive to people. Everything's in code. You've got nice controls over that. So we've just put out in preview this CloudFormation template 6. So if you're using Flux as your mechanism for GitOps, but you also use CFN, this project will help a lot in syncing that up. It'll get your CloudFormation stacks set up as you do changes on the GitOps side of the house. So it's definitely worth checking out if you're going down that path. It's a nice bit of work from the team. IAM Cluster Access Management. I'm getting slightly ahead of myself. This is in the coming soon category, very soon, like super soon category. And the idea here is back to that theme of how do we make things in the enterprise easier to do? How do we offload some of the workload that people have traditionally done? Access to the clusters has been challenging because you sort of have the Kubernetes model and you have the AWS model and you're bridging that gap between them. So we're simplifying access management to manage the authentication and authorization for IAM identities. So this will reduce the number of steps necessary to go make those connections. Traditionally, it's been a kind of a heavy lift on a per cluster basis for a number of folks. This is going to let you do this much, much easier and much, much faster, as well as giving access to AWS services into the Kubernetes cluster, which is another important step that people have to do. Another exciting area that we've made launch announcement on just in the last few weeks is VPC Lattice. So if you ever read, and some of you probably write, on the Reddit forums around EKS, one of the common things that people, especially people who are new to the EKS world, will typically say is, oh my God, that networking stuff is super complicated. Like the rest of it was not that bad, but I had to understand way more than I thought I needed to know in order to get things going from a networking perspective. So VPC Lattice is setting out to solve that problem. It does allow you to connect services at scale. This is a fully managed service inside of AWS. It is going to connect services across VPCs, across your account. So if you have a large estate, that tends to be one of the biggest challenges is you've got lots of accounts potentially, a lot of different VPCs. Getting those connections set up is super complicated. Lattice is going to make that much, much easier. There we go. There are granular access controls, so you can control who's allowed to talk to whom. So it's a nice way to set up controls for service-to-service connections. We have application traffic control. So this is load balancing. If you're trying to do blue-green changes, it fully supports those modes of operation as well. And then service-to-service interactions can be streamlined, and there's great observability built in. So it will log and track connection information, who's talked to whom, so that you have a good view for debugging and understanding what your services are saying to one another. Lattice is a really nice setup for that. In addition to that, because Kubernetes is an important facet of how people want to run things, we're launched the AWS API controller. This is an alpha, so we would love feedback on it from anyone out there. It is open source as well. So if you would like to help us make it better, feel free to do that as well. The goal here with the Gateway API controller is have you control Lattice through the Kubernetes APIs, right? So come in through the EKS front door using the Gateway controller, and you can set up your Lattice service network, the Lattice service, which is setting up the HTTP routes, and then the various target groups of services. So this should be a nice way to streamline and have a Kubernetes native style of leveraging Lattice. So we introduce a new service, we wrap it in a Kubernetes approach, and hopefully that makes it an easier to implement setup for most customers. I said I would mention GuardDuty as well. For those not familiar with GuardDuty, it's one of these layered services at the top. It's been very popular. GuardDuty is a security service, been around for 5 years or so. I think more than 5 years at this point. Couple of things that GuardDuty does well. One is org-wide single-click deployment. And we've worked with GuardDuty to make that consistent inside of Kubernetes so you can get it installed across Kubernetes through that same mechanism. Continuous monitoring, looking for security threats. As you can imagine, one of the things that AWS has had a fair amount of experience with, it's bad actors. We have a lot of people who work on security intelligence, threat analysis. This takes full advantage of that background and our experiences in managing lots of data centers globally and the kinds of things that we've seen there, to build out both ML-based algorithms as well as our own threat intelligence. And we also partner with a number of providers in the industry to pull in their threat intelligence. So you have one location that you can do a lot to protect your workloads and protect your environment. So what we've added to this just recently as well, this also launched within the last month, is called EKS runtime monitoring. So in this case, in addition to the classical things that GuardDuty is already protected, you're looking at VPC flow logs, DNS, things like that. We're now also going to have container runtime activities like file access, process execution, network connections. This allows GuardDuty to actually go into and nail down a pod that has suspicious behavior, as opposed to, I can see an EKS node that might have these behaviors. Now we're looking at inside the pod. We're looking at pod level activities. It gives us a much deeper inspection on what's actually going on. There's a couple of dozen different threats that have been added to the list with this. One of the nice things about this approach is it's this sort of defense in depth style. So if you have a bad actor, if you have someone who has cracked in, they can go and turn off things like the GuardDuty agent or modify it, attempt to modify the agent. Because we're looking at VPC flow logs and DNS data, we can still observe that activity and we can still come through and say, someone on this node is modifying things and the agent's been changed. So it gives you a really deep layered set of security policies and security warning that is definitely worth looking into if you haven't looked into it before. Adds a huge amount of value, and it's something that's been super popular. Is everybody's got lots of concerns about things. I was laughing when I went through some of this with the team. Like their first thing was going and looking at Bitcoin miners, because it's still like what every kid decides to do if they crack somebody is to go run a Bitcoin miner. But there's lots of other stuff besides that that's in the more serious sense on defense threats, as opposed to people trying to use you to go mine. But it's a great thing to go dig into and certainly worth looking at. So that's a quick view of where we were, how we started, what we're working on, what our principles are. A few of the things that have just launched. Nate will cover off some more stuff this afternoon. Quick look at the schedule we have laid out for today. A whole bunch of interesting stuff. We're going to talk a little bit about jams here in a minute and kind of how that works. It's sort of an exciting new idea. I think it'll be a lot of fun. And then we have a whole list of different topics for the morning session. I've mentioned Nate a few times, Nathan Tabor. He runs product and advocacy. So he's going to come in the afternoon. He'll go into some more of those future looking ones, talk a little bit more about some of the specific areas that we're focused on next. And then a whole set of other exciting activities for the afternoon. So thank you again for the quick tour this morning. Hopefully that kind of sets the stage a little bit. Happy to answer questions from folks as the day progresses. I'll be around all day for those who are here in Amsterdam. Thanks.
All right. We're back from the keynote. Sorry for the slight technical difficulties we had, folks. I heard, according to Chris, that we had a little charger problem.
One of the US to EU converters kind of just popped all of a sudden. So
it popped. Was there smoke?
I don't know. It just died, right? So
typical.
It happens.
All right. Well, if you were with us and saw that interruption of the stream, now you know the backstory. We carry on. We persist.
That's right.
So next up, we're going to introduce the Jam with Aaron Hunter. And we'll transition over and bring him up to carry on with the next part of our live stream.
What's going on, everyone? Nathan, thank you so much for having me. And it's not just Nathan, it's also Sam. And Nathan is now gone. What's going on, everyone? My name is Aaron Hunter. I'm a technical trainer on the AWS training and certification team. And today we're here to talk to you about AWS Jam with my good friend, Sam.
Hey, everybody. Sam Biggins. I'm a principal solutions architect with the Jam team. Big fan of doing cool stuff on AWS, and excited to share with everybody the hands-on lab challenges we have to show you today, that you'll get to experience some of the cutting-edge stuff going on at KubeCon here. So you'll get to hear the talk, and then with a few of these, you're going to have the opportunity to then jump in and try this out for yourselves. And then once all the talks have concluded, we're going to have challenges going all week so that you can get even more experience trying stuff out on Jam.
They're going to go on all week. So what does that mean? Until 5 p.m. CEST on Friday, right? Friday the 21st?
That is correct, sir. I believe, till the conference concludes.
And you know what I noticed? When I said AWS Jam with my good friend Sam, that rhymed like perfectly.
This is true. I'm not saying they hired me because like Sam the Jam man like fits, but it's one of those things like when the shoe fits, you wear it, right?
Exactly. All right, so let's go ahead and talk real quick about what AWS Jam is and why it's important to the container community and how they can get started. So AWS Jam is more like an escape room style virtual event, right?
That's correct. Yeah. So, as someone who's both built and participated in a lot of hands-on lab training over the years, this is the kind of thing I wish I always had, right? When I go into a typical lab and I open up my lab guide, it says, step 1, log into AWS, and step 2, pull up EKS and click here and do that. A lot of times I just go on autopilot and I kind of forget what's going on, and I get down and I'm like, what did I just learn? But with this, we give you a challenge. So we're going to ask you to sort of think about the problem, give you some documentation. We're going to give you the opportunity to try it for yourself, right? And as we'll show you here in a little bit, there are things to help you out. So we do have things like clues and the ability to get help. But we just want to give you the chance to kind of think through it and see where you end up.
Awesome. And for everyone who's watching live right now, go ahead and post your questions in the chat, and we'll make sure that we can try to do our best to answer them for you. And let us know where you're from. I see one person's from Alexandria, Egypt. Sam, where are you joining from? I'm based out of Frisco, just north of Dallas, Texas. So I'm based out of the U.S., not the EU.
I'm east of Seattle, Washington, on the opposite end of the coast here, or the country, on the West Coast.
Opposite end of the world. All right, cool. So let's go ahead and jump into what you have going on. And if you want, let's share your screen.
That would be great. If we can get my screen pulled up here. So what you're going to see,
Speaking of the world.
That's right. So here we've got mostly locked challenges right now, and we're going to get some links out to everybody. You'll be able to register for AWS Jam via these links. Once you do, we're going to actually spin up lab pods on your behalf. And so hopefully, as people get logged in and registered, as soon as you see these come up in the talks that are coming up later today, you're going to be able to jump right in and do it. But even if you can't, don't worry. We're always spinning up new pods. People will be able to log in, and again, they'll be available all week. So we'll kind of dive in here. So from the map, I'm going to take us down into the list, and this is going to show us all of the challenges that are going to be available. through this, and they're going to start to unlock. And I think just because of the schedule, it looks like we're probably we have one unlocked a little early. That's going to be this next talk. So this accelerate application deployment on GitOps, which is coming up. And you'll be able to look through all of these different ones, and you'll see here when they're going to unlock based on the time. So I'll go ahead and jump into another one. So this is on the public demo that we have. And if you look around, especially if you follow Mr. Hunter here, he likes to drop clues how to find our public demo links in order to try a few more jam challenges, just in case you don't get enough out of this KubeCon set. And this is always available, and you can tell your friends, tell your family, tell your babysitter. And so what you're going to
tell everyone.
Here it is. Exactly. So we got the first link up here that Aaron put there. And with this, you're going to see, so in this case, we have a challenge called knocking items off the S3 bucket list. And it has a couple of tasks. And the first task is unlocked, and it's giving us the background on what we need to do. But we see that the second task is locked. And so what's nice is it's not going to let us move on until we finish one task. Because I don't know if you've ever had this happen, Aaron, either as a teacher or a student. When you get into that chapter 3 phase and people start to realize they missed something in chapter 2, that can be a really painful experience to try to figure out which part you missed.
That's what happens when you speed read. Just gonna say.
Right. So is in this case, I've already got my lab pod spun up for me. So it's giving the option to go directly into the AWS console. When you first open up a challenge, it's going to ask you to start this. So make sure you click the button up here when you first get in. That way it'll start to spin this up for you. And then as you're going through, then you can read through. In this case, this is asking us to download a zip file that we're going to upload to an S3 bucket. Now, again, the idea is we want you to try to think about this for yourselves. If you do get stuck, or if this is your first time even logging into AWS, don't be afraid. There are clues here to help you. And so at a minimum, there's always one clue, and that is the full walkthrough. And so if you're ever stuck, this is the first place to come. Now, in some cases, when we're doing live events and it's for score and there's a competition going on, these clues do cost points. So a lot of times we'll tell people when they're working as a team, which you'll have the option to do, maybe ask your team before you just spend points on clues. But, we're mostly here to have fun and learn. So whatever helps you get where you want to go with that, enjoy it. And then what's going to happen is, in this case, it says the task validation will occur once the files are uploaded to the bucket. So there's a Lambda function running behind the scenes that's looking at that bucket. And when it sees players upload the files, it's going to give them the thumbs up. They'll get their score for the challenge task, and then the next task is going to unlock. And so that way they can continue to play through these different challenges throughout the day. And then as they finish the different challenges, they'll be checked off. And then going back to our other list here, we'll be able to see, you'll see that you'll get your points assigned as you do these different challenges. So really encourage you to get in here and play around. This is a great chance to get hands-on, great chance to learn, maybe even a great chance to make a few new friends if you decide to join a team.
And win some points and hopefully win some friends. Now, Sam, we have this link here that you're sharing on the screen. Can we share that in the chat? Is it safe?
Absolutely.
I'm going to wait for your blessing.
Yes. So it's the Jam event with the registration code. Is that correct? That you had?
Got it. Yeah, I just put that in the chat. So there it is, everyone. It's up on the screen now. Go ahead and check it out. Sign up, register for AWS Jam. But Sam, I think we have just a few minutes left. Should we maybe walk through the registration process for those who are new here?
Absolutely. Yeah. Let me shift over here. And so there we go. Almost had it there. Okay, 1 second. All right. Get my windows here. There we go. All right. So we'll get a new window going.
And while we're doing that, you mentioned that you're based out of the other side of the country from me. So what time is it for you? I think it's 12:53 in the morning.
It is. Yes, you are a master with time.
2:53 for me, and I see all of our friends here joining live from Poland, Norway, Amsterdam, the Netherlands, Groningen. I think I got that one. Let me know if I got that one in the chat. And also let us know what time it is where you're at while Sam walks us through the registration process for those who are watching live.
Excellent. Yeah, hopefully everybody can, you see my screen still. So now what we've got is when you click that link, It's going to bring you here to log in, and I wanted to back up just so I don't go too fast. So if you already have an account, or if you've been using Skill Builder, this is a great opportunity. You can then just log directly in with that. If you don't already have an account, we'll click the registration link down in the bottom there. And from there, we'll be able to go in. We would put in our email, preferred language, display name, country, and so on. And then once we've done that, it'll actually let us create our account there. And from there, once we've created the account, it's going to drop us straight into the jam. So just the screen that I've been sharing here that's showing this is what you should expect to see once you get going. And we look forward to seeing everybody in there. One other thing I do want to call out real quick. Again, there are clues. Be sure to use the clues if you get stuck. But if you think you have a technical issue with the lab and truly something is broken, there is a chat with facilitator button here. So you can come down and ask for help on the different challenges. And there are people who will be able to assist you via chat in support of that. And so, hopefully everybody's able to have a good experience and get something out of this. And we look forward to hearing your feedback. Please let us know what works, what's great, what do you wish you could see more of, and we hope to keep bringing these to you at more events like KubeCon or Container Day.
They do feedback. Can they do feedback directly from the page that you're showing right now? Is there an option there?
They can, yeah. That's a great call out. So as they finish challenges, each time they finish a challenge, they're going to be asked to give the feedback on the challenge. We're really curious. We're always looking to get that feedback and make sure we're dialing these in to give the best experience. And then as this progresses, there will be a feedback option that'll appear up here that they'll be able to use and give feedback later in the event as we get closer to close. And I think actually for the participants, it may be there the whole time. I think it just, with my view here, I don't see it.
Perfect. Sam, thanks for walking us through that. And I dropped links in the chat for our LinkedIn as well. Our aliases, I believe, are the same. Mine's the same everywhere. So if you want to follow me connect with me on LinkedIn and follow me on Twitter and connect with me there. And Sam, yours is Magical Mr. Biggs.
Yes, I went for Magical Mr. Biggins, but Twitter said that was one letter too many. So we're keeping it just short enough to squeak through.
All right, perfect. Thanks. Thanks a lot for shortening it down for us. And also one last thing, there's a YouTube link in the chat as well. Maybe we can get that on the screen here. So if you want to watch the registration process, go ahead and check out that YouTube link, connect with us on LinkedIn and Twitter, and then let us know if you have any questions. Go ahead and get out there and happy jamming and enjoy the rest of AWS Container Day today and KubeCon throughout the week. Thanks so much for having us. And Sam has his glasses. All right, everyone, take care. Enjoy the rest of your day.
Absolutely. Take care, everybody.
Well, that was a great intro to the concept of the jam. I don't know if you've ever done a jam, Chris, but I think
I have not, but we've put a lot of effort into making these, and I feel like they're going to be a good experience for folks. So they're kind of newish, and we'll try it out. And
I think the first one I did was it was like a race. It was the idea of like you could capture events off of like SQS and like SNS and a couple different AWS services, and it was like your job was to capture as many events as fast as possible, and there was a scoreboard.
Wow.
And I had so much fun because everybody was trying to compete and process these events as fast as possible to make it high up on the scoreboard.
Yeah,
so that was a blast.
Score. Yeah, you need a high score, I feel like.
But
for these jams, I don't know if we're necessarily doing scoring, but
these seem like to be different one. They're all focused on containers. They're all focused on Kubernetes.
Yes, and in full honesty, right? Like we had to help get some EKS clusters spun up for jams, and trying to help them figure the way out. Once we got them on the right path, off they went. It was great. So it's been a great working with the jam team. Sam has been awesome. He joined us from the West Coast at whatever o'clock in the morning, like our producer Tabitha here. Thank you so much. And these jams are here for folks all week, right? Like the resources will be available, and if there's a need for more, it auto scales. Like everything in the cloud here. So we're pretty excited by that.
We have a question in the chat about missed links for the jam. Can someone kindly reshare? We're going to be resharing them throughout the day as the different jams come up. So if you're just joining us, this is AWS on Air featuring AWS Container Day. So concurrently with KubeCon in Europe, we're running a Container Day where folks can get in there and try out some of these Kubernetes services, learn from folks who are professionals at using EKS and setting up different things on Kubernetes. And what we're going to be doing is sharing these jams out throughout the day with different presenters talking about the jam. And you'll be able to learn a little bit about the concepts of what you can do with Kubernetes. And that's going to transition to our next jam coming up, which is, I understand, it's going to be about GitOps. Very popular topic these days.
This is a super powerhouse team of folks, and I can't wait. I will hand it off to them to intro themselves. And some of these people are my good friends. So awesome. Take it away.
Hi.
All right. Well, we got you.
Okay, cool. Hi, everyone. Thank you for joining for our session. We're covering today infrastructure as code and GitOps for accelerated deployment and multi-cluster management. My name is Tzachi Duek. I'm a principal solutions architect for containers. Alongside with me, I have Carlos Santana, who is a senior specialist solutions architect for containers, working in the same team, and Dima Breda, who's a principal solutions architect working with startups. And on today's agenda, we're going to start, we have three major building blocks. The first one is challenges you might face when running multi-cluster Kubernetes. And then we'll cover the two building blocks of our proposed solution, which is infrastructure as code components and compositions and using GitOps for accelerated deployment. And then we'll wrap it up with a solution. We have a demo for you, as well as a gem to try out. So we start with the first one. And our challenge usually starts when we choose Kubernetes as our container orchestrator. And that usually leads to the questions of, now what? What tooling, what configuration should I use to run a production workload on my cluster? In the next couple of slides, I'm going to walk you through some of the challenges you might face when on your journey towards onboarding application to Kubernetes. And as always, and I hope you do, and this is taken from the kubernetes.io documentation website, you get very into the details of the documentation. You understand every component in the system, you get the benefits, the flexibility, and its features. But soon after, you realize it also involves a complexity for provisioning, upgrading, securing, and scaling the cluster itself. And this is where, and like Barry mentioned earlier, this is where managed services such as Amazon EKS provide a significant value for you. Amazon EKS provides secured, managed, and scalable solution for running Kubernetes cluster, specifically on AWS and on premises. The next step, of course, is to have a data plane, a compute capacity for our workloads. As you can see on the screen, no one really run single instances. And this is where other features such as EKS managed node groups help us easily manage the compute capacity for the cluster. Node provisioning and lifecycle management are completely automated by this capability, which also includes a spot support and interruption handling built into this feature, multiple instance type support, automatically labeling the nodes with the needed labels for cluster autoscaler, support for incremental or batch upgrades, and more. On the other hand, we have, as we announced, a new open source project called Carpenter, which is a just-in-time node autoscaler that manages the data plane for your cluster. Instead of managing node groups, with Carpenter, we calculate the needed capacity just in time for those pending pods and provision the right capacity for them. As you can see at the diagram in the illustration, it supports multiple instance type as a standalone instances just for your cluster. It simplifies leveraging spot instances without specifying node types and sizes on the on the node group, as we mentioned earlier. But it's not end up there. The next step, we need to decide which cluster-wide add-on we should use. The Kubernetes ecosystem has so many tooling to offer that it can become challenging to decide which add-ons we should use. But even when we choose which add-on we want to deploy, we still need to make sure we have a consistent lifecycle management for those add-ons as well. As you can see here, a partial list of those add-ons can be somewhere along basic operation services such as Core DNS or service discovery, Amazon VPC CNI for pod networking. For observability, we have CloudWorld Container Insights, Fluentbit for log shipping, Prometheus Agent for metrics, load balancing using AWS Load Balancer Controller, Nginx Ingress Controller, and maybe the combination of them. And the last thing I just mentioned is GitOps. We use Argo CD in our solution, and Dima will cover this later on. But this is not the end of the journey. Our next step is to onboard multiple teams into the cluster. And usually we see those three major teams as I'll describe in this slide. The first one are the application developer, and they focus on improving and building business features, services, or products. They usually require pipelines and automation that focus on taking their code and deploy it to the right environment with the right configuration. The next team is the DevOps, and they're focusing on enabling those application developers. They work to define standards, development stacks, build and delivery pipeline, and the tooling that will be used by the developers. The last team, called the platform team, they focus on enabling both DevOps and application team. They focus on building platform that has all the company standards. They will build the automation pipeline that will provision and manage the cluster end to end. And this is what we'll demonstrate in a couple of slides. The next step, following up on that, like this is where multi-team consideration should be baked into our solution. We achieve this by providing standards for identity and access management for different type of roles, different type of team inside the cluster. We should also provide isolated logical separation in the form of namespaces for our application and the team that manages all those components of our application. And as a final step, we want to automate the creation of the clusters with all of the configuration across multiple environments in a single pipeline with everything we discussed until now. We would also like to use infrastructure as code tooling to programmatically describe this configuration. And as summarization, some of the challenges are enforcing best practices across multiple clusters, having a consistent management and lifecycle management for all of those clusters across multiple environments, creating boundaries between application team and applications that are deployed into those clusters, and having the right set of configuration throughout those clusters and environment. And the last one is how do we easily onboard new application and ensuring the right application with the right configuration being deployed to the cluster that we want this. In the next part of the session, Carlos will be covering how we can achieve all of that using infrastructure as code and GitOps. Carlos.
Welcome, folks. So we're going to talk, we already talked about the challenges. Right now, let's see what we talk about the infrastructure code compositions. And later we'll see how we combine that with GitOps. Starting with the part of platform engineering, teams focusing on creating self-serving infrastructure as code compositions to enable other organizations in the company. And one example of that composition is EKS Blueprints. It's a project that we've been working for some time. And EKS Blueprint is an open source framework allowing you to configure and deploy complete EKS-based environments using infrastructure as code, such as Terraform or CDK. You can choose which one you want to use. You will follow the same best practices. We built in best practices, like I mentioned, and integrating with other Kubernetes tooling on add-ons, like Sahi mentioned, and it's fully customizable. You can extend it based on your needs. So let's take a look on how EKS Blueprints work. So the first part when you start using EKS Blueprints is working with the basic components from the bottom up is the cluster, the EKS cluster configuration. So in this case, you would choose like what version you're going to choose, which 1.26 just came out and is available for you folks, enabling the control plane logs, for example, the Kube API, and also encryption, how you want to handle the encryption for etcd. For the data plane, there's multiple options, and like Barry mentioned some of them. Manage node groups, Carpenter, which is our new open source project for enabling that you configure node templates, and then you choose with what are the configurations for those nodes that you want. And also we have a serverless options with Fargate, and you can configure your Fargate profile. So that layer, you can configure the control plane and the nodes at that layer, and you can combine different combinations depending on the workloads that you're going to run on the EKS cluster. You can combine, for example, Carpenter and Fargate. The next layer is add-ons deployments and configuration. At that time of this session, we have EKS Blueprints provides around 25 add-ons. It includes AWS specific add-ons such as AWS Load Balancer Controller, which is, I think, is one of the most popular one. Amazon VPC CNI, and others. As well, we have community-based add-ons such as Core DNS, NGINX, and Argo CD, which actually we're going to see in the demo. And also, last, partners and third parties can create their own add-ons. And it is in case of partners, now there's some of them already making their way into the AWS marketplace, such as KubeCon and Dynatrace, so you can add them as managed add-ons. Next is the EKS Blueprints includes cluster access, meaning permission management for users, roles, or groups. This is being abstracted to the platform team or to the developers in the form of a construct called Teams, or it's a module called Teams. And it's available, like I mentioned, CDK or Terraform. A team definition is designed to provide a set of isolated boundaries between the users and applications configured in the cluster, meaning like they're going to share the cluster and you create those boundaries. So let's take a look at how these compositions will look like. The compositions allows the platform team, like I mentioned, we're talking about this time platform engineering, incorporating the organization standards, and it's demonstrated in this application team construct in EKS Blueprints. When you use to create the application team using the construct or the module, it first creates a namespace. And this namespace can be customized with labels and annotations. For those of you that use Kubernetes, that's a common thing to do with resources. It also creates resource quotas or limit ranges and network policies for the applications deployed in this namespace. And then it creates an AIM role with specific Kubernetes RBACs permissions for that namespace. So usually you create a role-based permissions. So these roles can be assumed by a user that is in that account, or it can be assumed by another role, which is typical way of handling management in AWS. And last, it creates a IAM role for service account, short for IRSA. I know some of you are already using this. And this can be used by applications to access AWS resources from the pods. For example, they can access Amazon S3 for object storage or databases like Amazon RDS. So that's basically the platform and platform engineering team, right? Creating this organizational best practices across the organization so everybody can self-serve with these constructs and compositions. But let's talk about GitOps. Until now, we have talked, like I mentioned, the platform. But what about our DevOps engineers and app developers? This is where we use GitOps. So for DevOps teams, it provides a consistent app onboarding process or mechanism with consistent deployment standards, matching the right configuration to the right environment. Like Sahi mentioned, usually you have multiple clusters, each one used for a different environment, a production, test, staging. So you want to have that matching correctly and make it super easy for the developers. And this is where the developers come in, that it provides to them an independent way of owning and deployment or rollback using a well-familiar developer tools like Git, for example. And it helps them match and correlate what is the latest deployment in each environment to the desired state that is stored in Git. So with that, let's take a look at what it takes to do GitOps. So there's a lot of definitions out there. And one of the things that we'll be looking at is at the principles established by the CNCF GitOps working group, which actually Grace and myself, we started that and other companies. And we decided to make it very easy to people to understand what is GitOps at very high level and what are the principles around it. So when we talk about GitOps, we're talking about the same thing, right? Not their own definition. So we'll start with being declarative, whether it's a Helm chart, using customized or just plain YAML files. It's easy to find the source of truth for any environment. So like I mentioned, we do have different environments and people can put them in different Git repositories or different folders, but you can actually find what is the source of truth. And with that, Git is used a lot for keeping track. So Git is a source version control. It keeps track of the add-ons, and that's something, a pattern that is evolving, using this Git for the add-ons that we mentioned and also for the application. If you can keep the history of like why it was changed, who's changed that, and then you can also duplicate environments using that same source of truth. The other aspect is, as we do pull requests or typical changes to the environment, automatically, as soon as some testing, automation testing is done or passes, or someone reviews their pull request, it's accepted into Git, automatically gets deployed. And this is where the software agents we mentioned that it could be running in these are like controllers installed in the cluster or in a cluster managing other clusters that can perform that sync or reconciliation from Kubernetes, doing that operation between the desired state that is stored in Git or that database, and then matching the current state to the Kubernetes. So that way you can reconcile, and everything that is Git, automatically these agents will deploy them. So next, let's take a deeper look into GitOps. But before talking about it, how we will use infrastructure as code, let's see how we can see the tooling of GitOps, how we do manage it. So with the GitOps topologies. So this one is a centralized topology having one single GitOps instance, for example, Argo or Flux, to manage all the environments. Some of the benefits of having one Argo instance for all these environments, typically your 3 environments, is management of one single instance of GitOps. And also centralizing the user access, consistency configuration of add-ons across the environments, because you want to have the same add-ons in the different environments as you roll the application. Few drawbacks of this one is challenges to configure at scale. So if you have hundreds of clusters, typically you will need more GitOps instances, and also cluster creation. So as you create more clusters, they have to register with this central one. So that's kind of some of the drawbacks. So let's see the other topologies. So this one is called standalone or distributed, which I've seen both named. In this scenario, each cluster has its own copy of a GitOps controller or instance, which points to a central repository where like all the configuration for the add-ons are configured. Some of the benefits of this one is every GitOps controller is contained in the cluster, so no need to register with a central one. Also, isolation and authentication. So if you simplify the authentication of users using that GitOps instance, they don't want to have access to the other ones, the other environments. A few drawbacks from this one is the user access. In the other one, it was easy to manage access in a central way. This one, then you have to like configure every cluster, every GitOps instance for their permissions. And the other one is managing the add-ons on these clusters, you spin them up. You also have to make sure to install the GitOps, manage that GitOps instance on each of the clusters. So what about solutions? So I think Dima was going to mention that. So let me go over what we're going to see today. In the last part of this session, Dima is going to demonstrate the solution. You will learn how EKS Blueprints helps you create with a single configuration using CDK or Terraform, like I mentioned, that creates a fully configured EKS cluster that is deployed across environments. How teams are consistently defined in each environment. How to manage clusters in a self-updated pipeline, meaning like if you change something about the environments, something like in Git, that gets reflected into the different environments, even across accounts. And last is If you want to add that extra environment, either could be test, some people call them pre-prod, they can add them directly in Git, and then you will see that in the demo. So that's what's the platform engineering aspect of it. So now let's move on the DevOps and the application developers. So in this demo, we'll describe the app onboarding. Like if we want to add a new app to these 3 environments, in this process, the DevOps engineer will make sure that the new application are onboarded in a consistent and secure way, following that tenancy model or leveraging Argo CD. We're going to be using Argo CD projects and Argo CD applications. These are custom resources in Kubernetes. Argo CD projects allow us to create boundaries for the Argo CD application. So meaning you can, when you define a project, you can constrain the Argo CD applications to exactly which cluster you want to allow to deploy, which namespace in that cluster, and also which Git repositories is allowed to pull source code or the manifest files from to deploy the application. And this ensures that to deploy the right application to the correct environment. As you move the application, from example, from dev to test to production, you have to have the right configuration and the right settings across the configuration, also security settings. So with that, I'm going to pass it to Dima so he can show you a live demo now.
Thank you, Carlos. So we will now start with the demo. And just 1 second. So there is an initial state of the demo that we have already set up, where we have 2 environments, development and production, each of them having its own Kubernetes cluster. So just 1 second. Okay. So initially we have 2 environments, development and production. Each of them, as I said, has its own Kubernetes cluster. And there are 2 application development teams. Each of them has its own microservice that it develops. And then I will show how this setup was created, how it's being managed. I will add additional environment, additional Kubernetes cluster into the system. I will also onboard a new application team and a new application for this team. So there are 5 repositories here that I cloned from GitHub. So the first one, this is the CDK EKS Blueprints Patterns repository, which includes all the infrastructure that we are going to show in a second. Then there are 3 application repositories. So these are the 3 applications that we have. One of them is called Node.js, another one is frontend, and the third one is Crystal. So 2 of them are already deployed, and the third one I will deploy as part of this demo. And then there is the EKS Blueprint Workloads repository. So this is the GitOps repository, or the app of apps of Argo CD, and it points to the 3 application repositories. So now let's see the blueprints part. So the whole logic happens here within this class. So as Carlos mentioned, EKS Blueprints comes in 2 flavors, for CDK and for Terraform. So this demo is using the CDK version, but there is also the Terraform equivalent. So the way it works with CDK is that it all starts from this import line, where we import the EKS Blueprints module, which contains all the constructs that are used here throughout the demo. And so the first thing I want to show is the creation of the blueprint. So this happens here. And in order to create a blueprint, the first thing is to create something that is called Managed Cluster Provider. And we specify here instance types. We specify the version, the Kubernetes version of the cluster, and some additional parameters. And with this provider, the next step is to create the blueprint. Blueprint is not yet an environment. It's just a blueprint that will allow us to create multiple environments from it. So this happens here. So we provide, we specify here this provider that I was just showing. And we also list, we specify here a list of add-ons. So as Carlos said, there is a long list of add-ons that are supported. So these are the add-ons that we decided to put here as part of this demo. And with this, we create a blueprint. Now, the next step is to take this blueprint and to create environments from this blueprint. And this happens within something that is called a pipeline with here. So we have multiple stages. Each stage is actually a Kubernetes a separate Kubernetes cluster. So we have a stage here for dev. We have a stage for test. It's currently commented out, and I will remove this comment in order to add a new EKS cluster. I will push this change in a second. Then we have this manual approval step. And then we also have additional production EKS cluster. Before I push the change, I just want to also show you the teams. So the teams are defined here, and we have two types of teams. So we have platform team and we have application team. So platform team, we specify here a list of users or roles, and there will be a new role created for them that those users will be allowed to assume, and it will get administrative permissions on the cluster for the platform team. And the application teams, we also specify here a list of users, but we also specify a namespace. So this namespace will be created for this application team, and they will only be allowed to access resources within this namespace. So right now, there are two teams here, two application teams, the front-end team and the Node.js team. And this is, the crystal is not here because I took this file out from this directory. So let me bring this back here. Okay, it's very similar to the one that I was just showing to you. So there is a namespace here. And let me push this change. So we did add test environment and add crystal team. Okay, so now let's see what was created from this code. So the EKS blueprints for CDK is using a service that is called AWS Code Pipeline. So there is a pipeline here that was created from the code that I was just showing to you. And here we can see that this step, the first step of the pipeline, this is the source step. So it's configured with a webhook to the GitHub repository that I was just pushing the change to. And we can see that it's already running. Another important step that I want to show is the self-mutate step. So this is a self-mutating pipeline. And what it means is that in addition to this pipeline managing EKS clusters, it is also able to update its own structure. So whenever there is a new cluster that is being added or a cluster that is removed, so like in this case where we added a new cluster, this step will identify this change and it will rebuild the pipeline in the new structure and will restart the run with the new structure. And here we can see the environments themselves. So here, this is the creation of the dev cluster. Then there is this manual approval step. And then there is the production. And as part of this run, in several minutes, there will be additional environment here for the test in parallel to the dev and before the production. Now let's see what happened, what was created, how those environments were created. So I will navigate to the EKS console, and we can see that there were two clusters that are created, that are already here, the dev and the prod. So let me open one of them, for example, the dev. And so we can see here under compute, this is the managed node group that we created. If I will go here to resources, so we can see here all the pods, and these are the pods, these are the add-ons that were deployed with this blueprint. And we can also, for example, see the namespaces here. So we have a namespace for Node.js, we have a namespace for frontend, we don't yet have a namespace for Crystal, and it will be added in probably 5 minutes. Okay, so now let's see what happens from the application perspective. I will go back to the code. And here, one of the add-ons that we were creating was the Argo CD add-on. And as part of the creation of the Argo CD add-on, we were passing some configuration here. And one of the parameters is the Bootstrap repository. So this Bootstrap repository, this is the app of app repository. So it points to this repository. And within this repository, so there is a path and there is some branch here. So under this repository, here we have Helm charts for each of our environments. And within this Helm chart, so what we have is custom resource of type application. So this is custom resource of Argo CD. And we have one such resource for each of the applications. So we specify a source and a destination. So the source is the application repository. So in this case, I'm showing the front end, and front end points to the front end repository. And there is some branch, and there is a path. And under this path, within the front end repository, there are Kubernetes manifests that deploy this application. And I have two of them, front-end and Node.js. I don't have Crystal because I took this file out. So let me bring this back here and push. So onboard Crystal up. And I will push this change. And I expect the additional application to be deployed on all of the clusters. So now let's see the UI of the Argo CD. So I have it here. So we can see that there is the bootstrap, the app of apps, that was pointing initially to two applications, the Node.js and the front end. And now, as part of this push that I just did, it's already started to sync a new application. By the way, it will fail because the namespace is not yet created. So it will take probably several more minutes until the namespace will be there. And once the namespace will be there, this deployment will succeed. But you can see already that the Argo CD is actually showing all the three applications. So that's everything that we wanted to show here as part of this demo. Okay, so we covered how platform team manage consistent Kubernetes clusters across environments. We've also showed how to maximize clusters efficiency using multi-tenancy. And we showed how application teams can deploy more rapidly by using infrastructure as code and GitOps. So this solution is covered in a blog post with explanation of the design considerations that we took when building it. And you can find with those QR codes the walkthrough on how to deploy it. So that's everything for the session. And now let's move to the Jam Challenge. So as was mentioned earlier in the previous explanation, there is a link in the chat that you can open and access the Jam Challenge. So we created a Jam Challenge for you to be able to get hands-on with GitOps. And now let's move to the browser, and let me open this Jam Challenge, and we'll try to solve it here as part of this session. So I'm opening the challenge that is called Accelerate Application Deployment Using GitOps. Open challenge. Okay, and we have, so there are three tasks here. So the first task, so there was an environment that was already pre-provisioned here. Let me open this environment. We'll just log out from the other account. Let me do it again. So here we should have a Cloud9 environment, which is an AWS ID in the cloud. And I will open this environment. So here under shared with me, let me open it. So it will probably take 30 seconds. So while this happens, let's read the task. Okay, so this environment is already initialized, and the first step, I need to, once logged into Cloud9 ID, use the terminal and execute the following script. So there is some init script that will bootstrap Argo CD. I'll go here. where am I? So looks like someone is already using this this environment.
It keeps it going. So it's set up.
Yeah, okay, so this environment, this environment is already set up, so I don't need to run this. I'm not sure why actually, but anyway, it doesn't matter. So let's understand what was the first task. So the first task, is to try to find the URL of the load balancer in order to log into the Argo CD UI. Okay, so let's find the URL of the load balancer. So let me do maybe.
There's different ways.
Yeah, there are different ways to do it. So let's see what are the. So I can see that there is some service that the Argo CD server exposes a load balancer here under this URL. Let me try to access it here. Oh, okay. There is no domain here, but let's proceed. Okay, so now I need to find the password. So the password, I think it's stored as part of some secret here. Minus.
The init script doesn't give you that. I thought there was an init script.
Yeah, but somehow the init script was running already, so I'm not sure. But anyway, I'll find it. Let's see which secrets do we have here.
It's under Argo CD.
Yeah, it is this one. So this is the secret, right? Argo CD initial admin secret.
So if you work with Argo CD, that's the initial boot one.
Yes. So get secret. So JSON. Okay, so we can see that the secret is under data.password. Okay, so let's do this. Data.password. And we can also see that it's base 64, so we need to decode it. Base 64 minus D. Okay, so this is the password. And I think do you know what's the initial admin? It's admin. Okay, so let's try to access admin at this.
There you go.
Okay, great. So we can see something here. Let's see what was actually the task. So I will go back to the Jam challenge. And what was actually the task here? Once you're able to log in, check the name of the app to enter. And so it's actually asking me to enter this name. So we saw these apps. Okay, so this is probably the answer here to the. Okay, great job. This task was completed. So great. So we were able to answer the first task. Now let's proceed to the second task. So the second task asks me to deploy an application. Let me just read it quickly. So this is the path where I can find an manifest of a UI application. So let's see if I have such a path. Guess workshop v2. So it's here. Jam EKS cluster, GitOps, environment, workspaces, environment, workspaces, manifests. And here it is. So this is the application of the UI. So let me. It's like someone is using this environment in parallel. I'm not sure how it is. What's the reason for that? Okay, so maybe I need a different gem environment. I'm not
maybe it was a team base. So multiple, you created a team blueprint.
Right. So maybe someone joined this team and is working on it right now, actually. So maybe this is the situation. So maybe I will not do the steps, but I will just
somebody's doing it already.
Yeah, someone is doing this already.
For us, for the team.
Whoever you are, you joined the right team.
So anyway, the idea here is that there is this application of this UI application, and in order to deploy it, so there is a GitOps folder here. So this is the apps here, and we need. I think I will not do changes in parallel while someone is working on it, but the idea here is to copy this UI application into these apps. Okay, and also the idea is to work with customization, and so initially there will be a customization file, but in this case UI only, and Argo CD will automatically reconcile these apps, and as part of this, we'll also deploy this application. So I think this gem is going to be open through the entire week, right?
Yeah.
So
give it a try. It has 3 tasks, so you have to. We follow the first challenge, but the second one is deploy the application through Argo, which is moving the YAML file into a folder. Argo will see it. The UI will come up, and then the third one is kind of like a monkey, kind of a challenge of like scaling up. Like if you want to scale up the number of replicas of that deployment, you can do it with kubectl, but that's like bad way of doing it. It's better to do it in Git and go into Git and then change the manifest file to say how many replicas you have, and then configure it like that. And then if you want to do more advanced things, you can do it with HPA.
Actually, you're instructed to use kubectl, but no matter how much you try, you see that because of GitOps, when you scale the replicas of the same deployment, it will be the GitOps software agent that is deployed on the cluster will automatically reconcile the state and scale down the deployment again. So give it a try. You can mix and match. You can try to deploy more components. Like here it's just UI. But
yeah, our team member is doing it right now.
Basically that's it.
Yeah, thanks a lot for showing us this demo today. We're going to have to move on to the next GM session at this point, but this was fantastic, and I think people are really going to benefit from trying out Argo CD, and thanks for showing us this.
Yep.
Thank you.
Thank you. And if you're here, pass through AWS booth. Yeah, we'll be there. We'll have a GitOps session there.
Booth D5.
All right. It's time to move on to the next jam session now. Next up is build your data pipeline in Amazon EKS using Argo Workflows and Events. So big data, data pipeline, very hot topics today. Everybody has data they want to work with, and we're going to find out how to do that in Amazon EKS. I will let my guests introduce themselves. Maybe Victor, you want to kick things off?
Hi, Nathan. Probably I'll kick off. My name is Vara. Hi, everyone. Thank you for joining the session today. My name is Vara Buntu. I'm a principal SA in open source working with strategic accounts, and I'm also a technical lead for Data on EKS initiative. So today, I also joined with my colleague, Victor Gu. He's a containers and serverless solution architect. And we are very excited to present one of the most popular data on EKS pattern among our customers. So that is building event-driven data pipelines on EKS with Argo Workflows and Argo Events. So next slide. Before my colleague Victor delve into the actual pattern, let's talk about why customers choose to run their data workloads on EKS. Right. Well, Kubernetes has become increasingly popular for running data workloads with its ability to provide scalable, resilient, and portable infrastructure for containerized applications. So more and more users are thinking about running data workloads on Kubernetes, such as data processing and machine learning. So let's get into why customers choose to run data workloads on Kubernetes, right? So some of the key features. Um, Kubernetes provides a number of a feature that makes it well suited for running data workloads. One of them is auto scaling. So it can automatically scale up and down on the resources based on the demand using tools like Carpenter or a cluster autoscaler. This makes it easier for data teams to handle large scale data or ML processing tasks without worrying about infrastructure constraints. So, and the second one is the efficient resource utilization is another key feature where Kubernetes is designed to provide optimizing workloads across a cluster of machines, and data and ML teams can define resource requests and limits for each job, which allows you to optimize resource utilization without compromising the performance. So with Kubernetes, you also have the flexibility to select from wide range of compute and storage option, I think, which is a great feature that comes with, and that helps the data and ML workloads quite a lot by selecting from x86, Graviton, GPU instances. And now with AWS, you have Trainium, Inferentia, the compute which you can choose. And also the storages are like, there's plenty of options for the storages like EBS, EFS, FSX for Lustre are available as well. And most importantly, the Kubernetes offers a robust security model to ensure data workloads, in isolation with features like role-based access control and network policies. And with the help of IRSA, data teams can now have greater control over AWS services and how they interact with some of these AWS services with their data workloads. And finally, Kubernetes enables this cost-efficient data processing by optimizing resource usage and automating workload management, leading to a better resource utilization and efficient scaling and reduce infrastructure costs. So the next slide. So far we discussed the benefits of running data workloads on Kubernetes, right? So how to build and run these scalable data solutions on EKS? What are the best practices? So to answer these queries at AWS, we have launched a Data on EKS tool. And Data on EKS is an open source initiative that provides a set of blueprints created using Terraform that are ready to deploy for building and running scalable data solutions on EKS. What's even more exciting is the blueprints cover a wide range of popular data frameworks such as Spark, Flink, Ray, Kafka, Airflow, and many more. To make it even easier for customers, we have provided a documentation site that offers the best practices, performance benchmark reports, and various examples to quickly run some of these data frameworks like Spark and Ray with the right configurations using the right storage and compute. Everything is part of these examples that we built within the Data on EKS blueprint. So by using these data on EKS blueprints, customers can build their data workloads in a matter of hours instead of spending weeks or months, which allows them to focus on actual business needs rather than worrying about building the whole infrastructure. Next slide. Let's dive deeper into some of the focus areas of data on EKS. As you see on the diagram on the right-hand side, that like you have the blue background pretty much within the EKS. There's quite a lot of open source components, and the orange one below is AWS managed services. And the right-hand side, you have a storage and table format. So what we did is we kind of segregated all the data solutions that runs on Kubernetes today with a few focus areas. And some of those focus areas are like data processing and analytics, which is the main focus area where we are using Spark. And we are also building frameworks like Dask, Pandas, and Beams to show the examples how customers can run a scalable solutions on EKS using data processing and analytics. And the second focus area is AI, artificial intelligence and machine learning workloads. So we offer the machine learning frameworks such as Ray today and Qflow, as well as we are also working towards building the Jupyter Hub, which is like more popular among data scientists who wants to use it for data processing and also ML workloads. And the next one is streaming platforms. As you know, the data processing and streaming go together in a way in terms of processing. Like one is processing within the batch workloads, another one is streaming workloads, such as maybe like a social media feeds and so on. So within this space, we have Flink. Apache Flink is the most popular streaming framework. So we built a blueprint where customers can actually run Flink on EKS today. And we also have a Kafka within the same space where you can run a self-managed Kafka on Kubernetes. And that's what the streaming platforms that covers. And the next focus area is distributed databases and query engines. So with the distributed databases and query engines, we're covering like Cassandra, PostgreSQL, and for the query engines, Apache Trino and Presto. And finally, for the job schedulers, so we offer today the tools such as Airflow, MWA, Argo Workflows, and many more. So that's pretty much me today, but Victor is going to dive deep into Argo Workflows and Argo Events architecture, and also the customer use cases, and that follows the demo as well. Thank you. Victor, with you.
Yeah, thanks, Vera. Morning, everyone. Nice to meet you all. My name is Victor Gu. I'm a containers and serverless architect in AWS. So today I would like to go through some customer scenario and the challenges. So you can see workflow scheduling is an essential component of many organizations' infrastructure, helping to automate and manage complex workflows. AWS clients can use Apache Airflow or Amazon managed workflows for Apache Airflow to manage and schedule jobs. They can also deploy Airflow on Kubernetes for high availability and scalability. But during the engagement with our clients, we find some new requirements and challenges for running job schedulers on Kubernetes. So the first one is Kubernetes native. The clients want to not only deploy schedulers on Kubernetes, but also want to maximize the powerful feature of Kubernetes, like customer resourcing, scalability, and fault tolerance. They preferred a tool which is built specifically for Kubernetes, which can seamlessly integrate with Kubernetes ecosystem and do a more efficient resource management. Another perspective of Kubernetes native means that the tool allows defining workflows by using YAML manifest, which is easier to read, write, and do version control compared with the Python-based DAG definitions in Airflow. The second thing is event-driven. So our customer wants to trigger workflows in Kubernetes on demand by subscribing to different types of events. They want to define a series of tasks and dependencies that can be executed automatically when certain events happen. So this can reduce the need for manual intervention, increase efficiency, and also reduce the risk of errors. The third one, scalability and parallelism. The scheduler can easily scale horizontally as they run on Kubernetes, efficiently utilizing cluster resources and handling a large number of concurrent workflows. As the tool can use containers for each step in the workflow, promoting containerization and microservices best practice. This enables better isolation, versioning, and the reproducibility of tasks. The fourth one and the fifth one are talking about the integration with the Kubernetes ecosystem. The scheduler should be able to use GitOps for continuous deployment and use Prometheus, Grafana, and Fluentbeat, those popular open source solutions on Kubernetes for monitoring and logging workflows. The last one, extensibility. So our customer wants to not only use the tool on Kubernetes to run job processing, data processing jobs, but also to use this tool to control data ingestion and monitoring data processing tasks out of the Kubernetes. Okay, so after the investigation and work with our customer, we came to this high-level design to meet the new requirements. So first, we install Argo Workflows on Kubernetes as our job scheduler. Argo Workflow is built to run natively on Kubernetes and can leverage all the benefits of the Kubernetes ecosystem, such as scaling, container orchestration, and service discovery. Argo Workflows also support complex workflows with multiple steps and parallel processing. Secondly, to better support running Spark jobs, we pick up Kubernetes native Spark operator to run and manage Spark jobs in a declarative way. Thirdly, we choose Argo Events, a Kubernetes native event-based automation tool to make the whole architecture event-driven. Argo Events can be used to monitor and react to a wide range of events, such as message insert events in Kafka, SQS, or SNS, or customer events emitted by applications or code check-in events from GitHub. So you can see Argo Workflows events. So they can be easily integrated with Argo CD for GitOps, FluentBit for logging, and Prometheus and Grafana for monitoring. Here's one use case we implemented by following the high-level design. In this solution, we create an Amazon EKS cluster with managed node groups and install Argo Workflows and Argo Events in their own dedicated namespaces. The data team A has its own namespace for deploying Spark jobs. The platform is also equipped with FluentBit for logging, Prometheus for metric monitoring, and Apache Unicore for batch scheduling. Amazon SQS queue is created to receive requests from users, and a SQS event source object in the Argo Events namespace is set up to fetch messages from this queue. So when a new message arrives, the event pod triggers a sensor pod and then executes the specified workflow. This workflow creates a Spark application in the data team A namespace by using Spark operator. The Spark application consists of a Spark driver pod and multiple executor pods. So we will demo you how to implement this whole workflow at the end of the presentation. Here's another use case from our customer showing how we extend the design for integrating with external tooling. So the customer has data in Oracle and they use source connector to move data from Oracle into their Confluent Cloud data topics. The data topics are connected with Databricks directly for streaming processing. So they want to build a central data control plane on Amazon EKS in a repeatable way utilizing GitOps and the continuous delivery. So the platform in EKS can monitor the data ingestion from topics in Confluent and also trigger data processing jobs in Databricks in AWS. The platform will also be used to gather and store logs from Confluent and Databricks. During the implementation, we first install Argo Workflows and Argo Events, create an Argo event source to monitor the control topic in Confluent Cloud. When a new message comes in, the sensor will be triggered to run the workflow in Argo Workflows. The workflow then calls and manages the Spark tasks in Databricks through HTTP call with token secured. The HTTP template in Argo Workflows supports executing HTTP requests. You can also set retry policy to retry the requests if failed, back off certain steps, and log the error if the failure persists. Argo CD is used for GitOps, to deploy Kubernetes add-ons and also data applications. All the source code are saved in GitHub, and the Docker images are saved in Amazon ECR. Application load balancer is created based on Ingress to expose internal services, allowing DevOps to access Grafana, Argo CD, Argo Workflows UI through browser. All the sensitive data are saved in AWS Secrets Manager. External secrets operator installed by Argo CD will sync secrets from Secrets Manager into internal secret objects, which will be consumed by the pods internally. Databricks are configured to ship all their logs to CloudWatch. Prometheus will fetch metrics data from EKS as well as from Confluent Cloud through their built-in endpoint. Grafana is used as central dashboard, which will load metrics and the logs from Loki, Prometheus, and CloudWatch. Okay, so at the end, I will provide you. I would like to provide you some resources during this presentation. The first one is data on Amazon EKS. This is an open source project. You can visit this website to get more information. You can get tool for building AWS managed and self-managed data platforms on EKS. You can get the source code, documents, best practice, benchmark testing results. And also the next one is the job schedulers module inside the data on EKS website. You can get more source code not only for Airflow's Argo Workflows, but Airflow MWAA. The third one is AWS blog we just published. It summarized this event-driven data workflow pattern, so you can get more information and detail to set up the steps. The last one is a program in AWS called Data Lab. So it offers accelerated and joint engineering engagement between our customer and also AWS technical resources to create tangible deliverables that accelerate your data platform modernization. It's a complementary program. So if you have a clear business goal and think this pattern we present can help you, but don't know how to get started, please join the program and we can help you to sort it out. Okay, so let's move on to the demo. I'm going to demo the workflow setup and also the whole workflow from Cloud9 instance. Let me first show you my Cloud9
just wanted
instance.
to add that we couldn't set up the Jam session in time, so that we're doing a demo, but in future, maybe another sessions, we'll try to set something up for you guys.
Yeah, thanks, Lara. Okay, so you can actually follow me to to set up everything by using the AWS blog I showing in the previous slide, or go to data on EKS Argo Workflow session. We have all the source code and the setup steps over there. So basically, in this Cloud9 instance, what I did is I go inside and clone the data on EKS repo and go to the Argo Workflow module. To save some time, I have already run the Terraform code before the demo. Here, I want to quickly show you is, let me try Terraform plan. Okay.
Victor, do you think you can maximize the browser, just the text? Yeah, a little bit more. That's good. Thanks.
So yeah, while it's running, I can quickly go over the file structure. So underneath, we use Terraform to provision the underlying resources, like EKS cluster is under main.tf file. So once you run Terraform init and then Terraform apply, the Terraform code will be run and create the EKS cluster with all the node security group and also the managed node group for running your Spark job. And also under add-ons.tf, you'll see we actually use this file to create all the EKS managed add-ons like VPC CNI, Core DNS, and the CSI driver, and also install like Spark operator, Unicorn, Argo workflows. So by running, and also it will create cluster roles and cluster role banding to allow you run the Spark jobs inside the cluster. So by using Terraform, you can remove all the tedious manual steps and get this cluster ready. So let me go here. Yeah, so because I created this cluster just a couple of days ago, so when I run the plan again, you see no change. The whole procedure will take from like 15 to 20 minutes. That's why I ran the script before the demo. Okay, so once you have the cluster, then you can use the AWS EKS command to access your cluster. The first thing I would like to show you is to show you all the pods inside. So what we have installed so far. Let's go over from the top. So first thing first, for sure, is Argo event. So you can see it's installed. This one, event source, as we explained in the presentation, event source is used to monitor the external event and then trigger the internal pods in the next step. You will also get the controller and also event bus in Argo events. That's one is for communicating between different components inside Argo events, and a webhook. So that allow you to access Argo events UI from browser. And also the Argo workflows, you see the Argo workflows server allow you access Argo workflow, and also the controller. It will create workflows based on your definition. And the Fluent Beats, that's for logging. And that's the team data team A. That's the dedicated namespaces we create for the data team. You see some complicated paths. That's because before the demo, I do some tests on my side. So every time I create a new workflow and I run the Spark job, when the job is done, the driver pod will be marked as complicated. So all your logs will be saved inside. But once the pod is done, it will not consume any computing resources. You can create some trigger or some workflow to clean up those complicated pods. Kube system, so all the managed add-ons will be installed under Kube system, and the Prometheus, that's for monitoring. Spark operator, that's for manage your Spark workloads, and the Unicorn, that's for batch scheduling. Okay, so it looks like we have all the pods we need. One thing is I want to double check is the event source. So remember, event source is for monitoring the external event. So here, I just want to show you how did I set up that event source. So basically, that one you see here is I create that event source and let it monitor one SQ is called test one in region US East 1. So here, one thing, another benefit I want to mention is Argo events actually support cross-region monitoring. So right now for this cluster, actually it's under US East 2, but I intentionally create the queue in US East 1. So Argo events should be able to monitor this queue in another region. And whenever a message comes in, the event source will be triggered. Okay, yeah, so then we can go ahead to deploy our workflow. To do that, we actually just need to deploy this one single file. Let's quickly go over the content inside the file. So basically, it's to deploy this customer resource called sensor. So the sensor will be triggered when a new message comes into that test one queue. And what's under the sensor, you can see is actually just Argo workflow template. And inside template, for demo purpose, I create these parallel jobs. Actually, there are 3 jobs. The hello world one, this one will be executed first based on the template, this template. And then after this one, the first job get done, the other 2 jobs will be executed at the same time. One is for Spark operator, another is hello world 2. So they all need to run based on the template. So after that, you will see we define a template one by one. For the Spark job, the template is actually based on the Spark application. This one will be used by Spark operator. Actually define, deploy your Python script based on this base image, and then here is your starting point. You can also define the restart policy, your driver and executor. So here just give 1 driver and 2 executors. And you can also assign the resource limit for your driver and executor.
It's basically the Spark operator YAML you can embed within this Argo workflows, right? So, and helps you to design your workflow to have a sequential type of jobs and also the parallel jobs within the workflow, similar to what you do with any other workflow engines like Airflow.
Yeah, exactly. For another tool is based on this template. It's just for demo purpose, do nothing, but just take the input and print out. It's like the hello world job. Okay, so let's go back. This YAML file is saved under Argo events folder, so I can just use kubectl apply to deploy the sensor. Okay, so it's created. Yeah, then we should be ready to go and do some quick test. Let me go to the SQS.
Can we also log into Argo Workflows Web UI to take a look?
Oh yeah, for sure. Let me do the SQS first. So this SQS queue is under US East 1. It's named as test 1. Another thing as well I want to mention is, so remember in the Terraform, we set up this secret account and gave that secret account the access to access this SQS, but the authentication is 2-way. So also, if you run this demo on your own by following the steps, you'll also see, actually, we ask you to run a script to modify the access policy. The reason is that we also need to allow EKS cluster have access to read data from this queue. So by running that script, actually, is to allow the secret account row, this one, to have the read-write permission for this queue. Okay, let me copy the message, and then we can send the message.
So that's like triggering our Argo workflows by sending a mock message into SQS queue.
Mm-hmm.
Right. So maybe now we can log into Argo
that's what I'm
workflows.
going to do. Yeah, so you can see once I hit the insert a new message and then go back to the command line, use kubectl get workflow, you will see a new workflow just created like 10 seconds ago. Now let's go to you can actually get more information from the command line, but I want to demo you to see how to get those information from the UI. One thing is, let me get token first. Okay, that's the token, and in order to access the UI, I need to do the path forwarding. Copy. And then in Cloud9, that's the preview feature in Cloud9. You can actually web page from Cloud9. Okay. Copying. Okay, cool. So same information you can actually get from Argo Workflow UI. So you see this one is just created 20 seconds ago. If you go inside, you'll see the details of your workflow. For this one is starting from the entry point and then run the first Hello World job, and then 2 parallel jobs. One is Hello World 2 and another is your Spark job. You can hit every single node to get more information. You can also get logs from there. Another thing is, let me see, event. You can also access the event information from this UI. Okay, yeah. So you see, for this for this demo, we have one event is actually monitored as QS. You can get all the information from here, and also event flow is actually monitored as SQS and then go to the sensor and eventually go to the Spark workflow.
I think it's a great way of dynamically creating the workflows with a simple YAML file with Argo Workflows and Argo Events, and build that event-driven architecture for your Spark jobs, which is really cool. So in this case, as you see, the Argo Workflows Web UI, Victor used port forward from the service, but you can actually build it using NLB and any ingress controllers like Nginx to use your internal domain name to expose that specific service to make it, easy to log in and work with this UI.
Mm-hmm. Yeah. Okay, that's pretty much everything for the demo. Let me bring back the slide deck.
Yep, I think we're done with the demo as well. So thank you, everyone. Thanks, Nathan. So tomorrow we have a KubeCon booth where we are presenting Spark Operator, Flink on EKS, and AML on EKS. So please come around so we can go through more details. Anything you want to know about data on EKS.
Thank you, everyone.
Great demo. Thank you very much for joining us today, and looking forward to seeing what kind of data pipelines people are able to build with this newfound knowledge. Thank you. All right. Next up, we have another session. This one about how to build scalable connectivity for modern applications on AWS. And we have 2 fantastic guests.
Hey, everyone.
Hello.
I will allow y'all to introduce yourselves and kick it off.
Awesome. Thank you. Thank you, Nathan. Thank you, Chris. I'm Alex. I'm a principal networking specialist solutions architect with AWS, working with our customers on all things networking. And I'm joined today by Federica.
Hi, I'm Federica Ciuffo. I'm a specialist solutions architect for containers. And yes, I work with customers on container technologies and help them achieve their architectures within their systems.
That's awesome. And we are here today because both networking and containers come together to help you as customers build secure and scalable connectivity on AWS. We're going to be talking a lot today about how you can make use of Amazon VPC Lattice. We know everyone is extremely excited about the recent launch. We're going to see some very cool deployment patterns, and we're going to dive a bit deeper in how it works and how it can help you with modernizing your applications. Before we dive right in, let's go through some housekeeping items. First one, we'll let you know when the build-outs are complete so that you don't have to sort of follow them through and say, well, how many animations are there left? And the second one is that we're going to have QR codes. Also, our moderators in the chat are there to help you. They will be also providing the links in chat. Also, if you have any questions, any comments, any thoughts about what we're going to be talking today, let us know in the chat, right? Interact with us. We're extremely curious to see how you are looking at containers, modernization applications, VPC lattice, service meshes, and all things related to containers networking. That being said, we are going to start on our journey today from monolith applications, right? And we're not going to dive super deep in what monolith applications are, but the very foundational network aspect of monolith application deployments is that their access patterns are extremely simple and straightforward. There are two types, right? Internal calls, which are usually within the application itself, and client traffic, which is dealt with by proxies or elastic load balancers. Now, these access patterns, because they're straightforward, right? They don't require too much networking knowledge. Also, from the networking perspective, they don't require too much visibility into what the application is actually doing. But with modernization, right, because that's what we're talking about, these monolith applications start to be broken down into multiple components, right? With the help of Kubernetes, probably the most famous and most used containers deployment platform, these components of a monolith application that has been broken down into start now having to have or to meet the same deployment patterns, right? And the idea is that those access patterns that used to be internal to the application now become service-to-service communication patterns. These are usually dealt with within the CNI, kube proxy, core DNS, all the containers components that go within the cluster. And ingress traffic is, again, dealt with by load balancers or ingress controllers. The challenge here, and usually when we talk about this, we see heads nodding. Hopefully you're nodding as well now, is that all of this requires a lot of network knowledge, requires the understanding of, okay, what should we be accommodating from the network connectivity perspective to meet these service-to-service communication patterns and client traffic patterns. So that means that when we're deploying microservices at scale and we are on this path of modernizing applications, right? Requirements start to evolve, right? Application owners or service owners need to offer consistent communication management patterns, which means that they need to be aware of those communication patterns, right? And here's where the service dependency matrices come into play, service discovery, and everything that comes with managing microservices at scale. End-to-end visibility and observability is probably one of the key requirements when deploying these microservices at scale because of the need to understand how components interact with each other. The added need for failure isolation and protection comes with the fact that containers at scale or microservices at scale have these individual components that can fail independently, which adds to the resiliency of the application deployment, but also needs or has an additional requirement of managing it. And finally, last but not least, fine-grained deployment controls. And here we're talking about blue-green deployments. We're talking about canary-style deployments, migration from existing clusters to new clusters, and so on. All of these, from the application perspective, are requirements that translate usually with application modernization into network complexity. Because from the networking perspective, network engineers, right, and admin teams don't really have the visibility into what the actual applications are doing. Don't have the visibility into what Kubernetes deployments look like or why they should have connectivity across clusters, right? That being said, there was a trend in the industry, right? Service meshes. Federica, do you want to tell us how or if service meshes can help?
Yes, absolutely. In fact, service meshes actually help to deal with the increasing network complexity of your applications in your distributed system. And to do so, they rely on the cycle proxy pattern. So to speak, we take a proxy, we containerize it, and we put it cycle, that means next to our application container. And we let the cycle proxy handle all the incoming and outgoing traffic that comes in and goes from my application container. We do that not only for one container, but obviously for all of my systems. So to speak, service meshes help you with dealing of this new layer that is the cycle proxies layer, and so that you don't have to deploy them manually or update the routing configurations. This would be very bothersome. This is done centrally by the control plane of the service mesh. And service meshes help you to deal with a lot of network complexity. For that, it is widely adopted, and there is a wide ecosystem of implementations. You can tell us in chat if you already have adopted a service mesh and which one you have adopted. And well, service meshes help you with a lot of things, but which are those things? Which is the real benefit of service meshes? Basically, the real benefit is that you are decoupling the business layer of your application from not only the networking, but also to some extent to the security and observability. You mentioned the observability of your application, because this is really important in a distributed system. So let's review the most common use cases. We talked about networking, and obviously service meshes offer you an advanced routing and traffic controls. Could be traffic shifting, but also specifying prefix and query parameters, HTTP headers, etc. We also talked about security. So a common use case for service mesh adoption is that you want to allow or block traffic among your microservices or third-party API. You can do so with a service mesh, as well as you can enforce encryption with TLS, neutral TLS, etc. Another thing that you can do is to connect together different environments. And this is really powerful, because if you have a distributed systems, you might have your clusters which are located in different areas of the cloud. And so you want to connect them together. And I'm talking about service-to-service communication. So the service mesh implements a shared service dictionary that enables you to do this kind of discovery across clusters. And last but not least, observability. Yeah. So pushing the networking and to some extent also the security to the proxy layer gives you an uniformity that helps you to understand better upstream and downstream dependencies for your applications, as well as to understand where you have bottlenecks for your applications as well. So a lot of benefits for service meshes in containers, but still there are some limitations. Alex, you talked about ingress and introduced it. And basically, ingress is the very first attempt to standardize the external access to Kubernetes services. It added a lot on top of the services, like, for example, node port or load balancer. But still, for the ingress model, there are some limitations. If you want to take or to leverage the full extent that ingress can give you, you need to rely on custom proprietary annotations or custom resource definition. I mentioned those are proprietary because they depend actually on the implementations that you choose for your ingress. That is the ingress controller that you choose for your ingress. For service meshes, well, you guessed it, the cycle proxy management is centrally managed, okay, by the service mesh, but still at scale can be quite challenging to deploy all this proxy and to maintain this proxy fleet. So if I have to summarize these two parts, there is some common challenges to both of them. The first one is that neither for the ingress, neither for service meshes, we are relying on the Kubernetes native API. For the ingress, we have annotations, CRDs, and for service meshes, well, we have a different application altogether to manage our traffic. We also have this limitation. If you have a distributed system, you might want to adopt, and you can also confirm with your customers as well. Sure. This is something that I'm seeing, different compute layers, like compute choices, not only containers, I'm also talk about serverless, EC2.
For sure.
And so if you are using, for example, service meshes, you are only targeting one part of the problem, that is the advanced routing configurations for containers. Another thing is network connectivity. We talked about how you still need to rely on networking services, like, for example, peering connections, transit gateway to connect different environments together.
Exactly.
So taking into account all of these limitations, the Kubernetes network has created a new project, which is the Kubernetes Gateway API, which aims to standardize the Kubernetes networking and to add a lot of features on top of the normal networking, like, for example, that we could see with ingress and ingress controllers. So that all the features that before were added on top with annotations, custom resource definitions, now are embedded into the Kubernetes API. So this is the very first cool thing about the Kubernetes Gateway API.
This is how I actually got to understand Kubernetes networking. So very cool.
Very cool. But there is another cool thing about the Kubernetes Gateway API. It's model that is role-oriented. That means that you will actually have, well, different roles within your organization, but each role will be directly responsible for specific objects within the Kubernetes Gateway API. For example, the first step that you would need to take is the infrastructure provider needs to define a gateway class. The gateway class formalizes the type of load balancing implementations which are possible within the infrastructure. Could be load balancers, could be proxy. Works much like, for example, the storage classes were needed and formalize the storage implementations for a Kubernetes cluster. After that, a cluster operator will create a gateway. The gateway basically is a point where the traffic that comes from outside the cluster is translated to in-cluster traffic. And from this point, the traffic will flow according to some rules. Those rules are defined by the application developer within the HTTP root object. And then the traffic will be distributed to some endpoints, to some backends. Those are the services. And well, you guessed, services can be Kubernetes services, but it's not limited to that. The cool thing is that this can be extensible, and you can also reference external endpoints to your clusters. And while the Kubernetes Gateway API is pretty new, we already have a wide range of implementations. And again, the Kubernetes Gateway API is so widely adopted because it is so powerful, it's so extensible, and it has a lot and relies on the Kubernetes API itself without needing for these CRDs, annotations, etc. And we also have our own implementation, which is based on Amazon VPC Lattice. You might have guessed it. But before diving deeper into how we build an integration within the Kubernetes world with the Kubernetes Gateway API and Amazon Web Services with Amazon VPC Lattice, Alexandra, back it to you. Can you introduce us to Amazon VPC Lattice?
Absolutely, for sure. So before, as Federica mentioned, we dive very deep into the Kubernetes Gateway API integration with VPC Lattice. Let's start by reviewing a bit of what VPC Lattice does and what it brings to the table. And one of the things that Federica mentioned is that the deployment compute options for modern applications on AWS do not simply are restricted to EKS or containers, right? We have Amazon EC2 based applications, Lambda, and all these applications and services that are deployed by customers on AWS have to be mapped or inserted into two types of boundaries. The first one is the Amazon VPC, which is the network layer boundary that you have on AWS. It's your virtual private cloud that you deploy on AWS. And the second one is your AWS account or set of accounts, right? This is the security boundary that you have on AWS to control the access rules and permissions for your workloads, principals, and so on. Now, the challenge with these two boundaries is that they don't oftentimes match the service level boundaries, right? So we may have a service that lives within an Amazon VPC. We may have components of services that live across different accounts for security reasons. So because of these unmatched between the network layer boundary, the account layer boundary, and the application layer boundary, networking becomes complex, right? And this is one of the main reasons why it becomes complex, right? And as Federica mentioned earlier, you still need to have that network path between the different components. In short, often implemented by admin teams who don't really understand your application access patterns, right? We put a transit gateway in there, connect thousands of VPCs to it, but that doesn't give us more visibility into what the actual service-to-service communication patterns are. So here's where Amazon VPC Lattice comes and is very powerful, right? And that's why we're both here together, right? Networking and containers, because Amazon VPC Lattice is meant to bring these two personas together, right? To bridge this so far disjointed experience between admin teams and service owners. And how it does that? First, it does not require sidecar proxies, right? It is a fully managed application layer proxy that also brings connectivity into the picture, right? So it's not just the proxy layer, it is with added connectivity and data plane connectivity. The second works across all compute options, right? That is one of the biggest wins of VPC Lattice. Does not restrict you in your application modernization journey to use one single compute option. And we all know that in large scale environments is virtually impossible. The third one is that, yes, it provides you with those traffic and access controls. This is where the security-focused persona also comes into Lattice. And from the security perspective, it's a very important thing that within VPC Lattice, you have a single pane of glass into the application of the security policies, right? So we will see the components, we'll see how that plays out. And last but not least, no networking expertise required. From the perspective of service owners do have control over their side of the application deployment. Admins, which is the other persona from the networking perspective, has control and manages the network infrastructure components. And both of these come together, right, in VPC Lattice to meet the needs of modern applications. Let's see what are the components of VPC Lattice. You will see these components referenced in what Federica is going to talk about specifically for the Gateway API controller and implementation. So let's make sure that we clarify them. First is the service network. We talked about the two initial boundaries, right, that we have on AWS. Amazon VPC, which is your network boundary, and the AWS account, which is your security boundary. The service network is a new logical boundary that allows you to group together your applications based on their access patterns needs. The second component is a service. A service, which is a customer-owned application unit, and it can extend across all compute options that VPC Lattice supports. It is made up of listeners, rules, and target groups, very similar to how application load balancer services look like today on AWS. The third component is the service directory. Service discovery within VPC Lattice is DNS-based. So whenever you create a service in your AWS account, or you share a service that you've already created with another AWS account, we'll see how that works in a second, these service names get populated in your account level service directory. And last but not least, security policies. In VPC Lattice, security policies are called auth policies. So they do take care of both authentication and authorization. And they make use of AWS IAM resource policies that you are familiar with already. Very important, they do support additional conditions based on Lattice specifically, but it is a construct that you already know. It provides reliable authentication and authorization. Now, let's see how it works. I'm sure everyone is very excited to go through this part here. The first persona is the admin persona, and its role is to create the service network, to share the service network with multiple accounts within the organization, because again, as mentioned, account level boundaries are not enough to define service level boundaries. The third is associate VPCs to the service network. This actually opens the data path from clients within the VPC to access services that will be later associated with the service network. Define auth policies at the service network level. We'll see that in addition to the service network level authentication auth policies, you will have service level auth policies. So you have two places where you can control the granularity of your policies. And last but not least, enable monitoring. So you have full access to access logs at the service network level, and you can export them to either CloudWatch log groups or S3 buckets or Kinesis data stream. And you also have access to X-ray logs, access logs. So very important from the visibility and observability perspective, you have the central point where you can see your application access patterns. Second persona, right, is the service owner. And service owners have the responsibility of defining their services, right? These services you see, they can span across multiple VPCs, they can span across multiple accounts, and they can span across multiple compute options, right? You can have a service with multiple target groups that accommodate for different compute options. The second responsibility piece is to define the routing policies for the particular services that a service owner has created. You can do path-based routing. You can do blue-green deployments, and we're going to see more on that in a second. The third step is to define service level auth policies. So this comes as an addition to the service network auth policies. And one of my favorite examples from the network perspective, because I am not the actual owner of security at the organization level, right, is the fact that at the service network level, you can enforce, for example, only authenticated traffic from within your organization to flow through the service network. And that in itself is an extremely strong security control, right? And then service owners can take the control of their service level auth policies and make them as granular as they need. The fourth step is to associate services that service owners have created with a service network, and thus making them available to be accessed by clients within the VPCs that were associated with the service network. So we have the full data path. We have all the components in VPC Lattice. Please do scan the QR code if you're interested in finding out more about the steps of deployment and about how to reason with VPC Lattice. And now we get to the good part, right, of our presentation, Federica. We get to the part where we dive deeper into the integration of VPC Lattice with Kubernetes. So take us through the journey.
A little bit more of Kubernetes here. So yes, we actually thank you for introducing us to VPC Lattice. We now know the services, service network, Lattice service, etc. Let's try to map this to the Kubernetes Gateway API and to Kubernetes in general, Amazon EKS. So the real integration is done through a controller. Much like we used an ingress controller for ingress objects, then also for Kubernetes Gateway API objects, we are using a controller. And we built a controller, AWS built a controller, which is the AWS Gateway API controller for, well, Amazon VPC Lattice. And how it works. Basically, the controller is an application running your cluster. We have in this example an EKS cluster. And you can see all the objects from the Kubernetes Gateway API, gateway class, gateway, HTTP routes, etc. So let's try to map those. So when the cluster operator creates gateway resources, the AWS Gateway API controller is able to automatically pick up these changes and create VPC Lattice service network. When an application developer, on the other hand, creates an HTTP route, VPC Lattice services will be created. And well, services, those are the targets of the VPC or the HTTP routes. So those will be the VPC Lattice target groups as well. So again, gateway are mapped to service networks, HTTP routes, to Lattice services, and services are the target groups. But let's see this with an example. In this example, we aim to provide cross-cluster communication between two different clusters. In particular, we have two Amazon VPCs, two clusters, one in each VPC. And in this cluster, we have already created all the resources that we need to operate with the Kubernetes Gateway API. Those are custom resource definitions, which are needed, and also the Kubernetes Gateway API controller that we built, the AWS Gateway API controller. We have those elements, but what we want to get cross-cluster communication to. So we have two APIs that we have built, a green API in the first cluster and a red API in the second cluster. And we aim to split the traffic between these two APIs. So the very first step would be, again, this persona, the cluster operator that creates the gateway. By creating the gateway, the controllers will work to create a service network and then to associate the two VPCs to this service network. So that now we have a network that connects together the two different VPCs. Now that we have this kind of connectivity, we need also to define the discoverability between the two services, because the controller is automatically able to pick up the Kubernetes services within the same cluster as targets. But I mentioned before that we can also have external endpoints. This being, in this example, an external Kubernetes service. We need first, for example, for the red API, to make this available at the VPC Lattice level first. So then the controller, being the liaison between Kubernetes and VPC Lattice, will be able to see this resource. So we need to export the red API at the Lattice level. And then the step after that would be to import it into first cluster so that we have as a referenceable resource into cluster one. Once that's done, we can actually reference both the green service and the red service as targets. In fact, the next step from the service owner would be to define an HTTP route. And the HTTP route, if you remember, it's the routing configurations that goes from a point, the gateway, to some targets. So in the HTTP route, we will define from where the traffic flows to where the traffic flows and how it does. So the targets where the traffic flows would be the imported red service and the green service. From where the gateway that we created, that is the service network. And how it flows, well, in here we decided to do a 50-50 split between the green API and the red API. And this is really powerful, actually, because we talked about before how it is difficult to connect environments together and all the knowledge that you need to build on to do so without even configuring cross-cluster communication. But in here, in 4 simple steps, we connected together 2 different clusters in 2 different Amazon VPCs. And well, that's all. We have cross-cluster communications thanks to this controller that we built, Kubernetes Gateway API and Amazon VPC Lattice. This is not the only feature of the AWS Gateway API controller. If you want to know more, please scan the QR code and let us know also in the chat if you already use the Kubernetes Gateway API controller.
Okay.
But again, I wanted to show the same example that we just saw in the console and also in the terminal just to see how it actually works. This might be the first time that you are seeing that, so I thought it was interesting to do so. So first of all, we are going to the VPC section, and if you scroll down, there is the VPC Lattice section. If we go and see the service networks, there isn't anything available, and neither there is for the services. So let's now create resources. First of all, let me show you in here, we have the terminal split in two. On the left, I will be doing the commands. On the right, we have this famous controller for the cluster Lattice 1. And you can see them, those logs will be running as I create things. In the namespace 1, we have the application that I just showed, which is, a front end, which basically calls the Green API as backend. Then doing a port forward, we can actually see how the application looks like. And let me just go to the local host. And it's simply a hello from the Lattice demo. And this is the Green API service. This is the only backend that we have right now. We have also another cluster, Lattice 2, in which there is the red API. We wish now to connect them together as we just showed. Let's review what we actually have. We have some custom resource definitions created, like, for example, gateway classes, gateway, HTTP routes, service exports, service imports. Those resources are the ones that we just saw in our presentation. And they are the resources that we need to actually create all these objects. We also have the controller, which is the one whose logs are on the right. And this is deployed, we are in the Lattice 1 cluster. You can see them in green on the screen. But we also have deployed these resources in the second cluster, obviously, because we need to create resources also in cluster 2 for Amazon VPC Lattice. That being said, let's try now to connect together as backends, the green backend and the red backend. The first thing that we will do is to create a demo. You can see on demo gateway. You can see on the right, the controller is working on the backend to create Lattice, VPC Lattice resources. And it's still reconciling. So let me maybe just switch to the second cluster so that I can create the gateway also in cluster 2. Now you're not seeing logs because actually, those logs are only from the first cluster.
This seems like I can understand it too.
Okay. And if we refresh, we should be able to see the Lattice gateway on. This is the gateway that has been created by creating the gateway resource, and it is a Lattice service network. We have 2 VPC associations because we created this gateway into different VPCs into different clusters. Okay, so no, we still need to use the context. We are still in Lattice 2. We are not in Lattice 1 because actually the second step that I showed you before was to export the service, and we need to export the red service from cluster 2 and make it available at VPC Lattice level. So now we have this available at the VPC Lattice level. We are not seeing logs on the side because these logs are from the controller in the first cluster. And now we need to import this resource so that it is referenceable in a HTTP route that we are gonna create. In fact, now the controller is picking up changes. And we have it reconciled. Okay. Next step is to create the HTTP route because we have all the elements. So this route is named caller route. You can see on the right is controller is working on the backend. And let me wait that this is reconciling, still creating progress. We can see, but it will take just a few seconds to be there. In the meanwhile, let me just show what we actually created. The caller route actually spreads the traffic between the green API service and the red API service 50-50. So that we have the traffic splitted. Okay, deploy succeeded. So we actually have this. Let's review the resource that we actually created right now with the HTTP routes. And we created this in the namespace 1, and the name is caller route. I'm gonna actually print with a YAML flag so that we can see the DNS name, because this is actually what we need to, this is the endpoint. If we talk, we've created by the Amazon VPC Lattice. If we ping this endpoint or we redirect the traffic to this endpoint, the traffic will be equally split between the green service and the red service. And we have created this associated service, VPC Lattice service resource. Next, and this is the last step that we need to do, is to change the value of the backend from the standard one, the green API service .service cluster.local, to the new DNS name, and apply this file. It's not in this folder. I think it's in the Kubernetes folder. Yep. So.
Oh, nice. So you just updated the DNS name and now you can access the service.
Yes, actually, before we had the endpoint only for the green service. Now we have the endpoint for both of them. So
Nice.
let me just show you that this is actually working. So we are forwarding the front-end service and we are on the same link from before. We have the green. If we refresh a couple of times, we should be seeing also the red service available. Okay, yes. So we have seen actually what we just explained in the slides. We have traffic which is equally split now from the green service and the red service from the front end. And so what we have just seen, we have seen something that is really powerful, this cross-cluster communications. This can also be done cross accounts you mentioned before, but this is not the only thing that actually this connection between Amazon VPC Lattice, Kubernetes Gateway API simplifies. There are a lot of use cases that we are seeing adopting from our customers. First of all, well, advanced routing, that doesn't rely anymore on custom proprietary annotations. CRDs, neither you need to deal with the fleet of sidecar that was needed for the service meshes. Traffic and access controls, these are inherited from the traffic access and controls that you just explained. And this is integrated also within the controller. No networking expertise required. We didn't lie. We didn't lie.
Correct,
because I just show you how easy it was to connect different classes together.
Sure.
These were two different VPCs. So actually pretty powerful.
You didn't have to do any transit gateway peering, any VPC peering, any private link, so everything works.
You just need a knowledge of the primitives of VPC Lattice and the objects of Kubernetes Gateway API, how this works to do that. And well, it works across all compute options we mentioned. Now, this is, well, coherent answer to distributed systems which do not only rely on, let's say, Kubernetes, containers, like also be serverless, could also be Amazon EC2, etc.
I think one of the probably the most common use cases that I'm hearing from customers whom I'm working with in the container space is cluster migration. So I think this is probably, from my perspective as the networking person, just trying to upgrade your cluster to a newer version in Kubernetes. I think that's super powerful because you can just migrate your services from one cluster to another natively without having to worry about that.
And it doesn't conflict with the endpoints that you have already existing in cluster, because those are simply other endpoints, as I showed, that you can change into your application, and that's all.
Yeah. The other thing is you mentioned, you showed in the demo that DNS name that every service gets when it's created in Lattice. That DNS name actually resolves to a link local IPv4 address and IPv6 as well, which means that we can also use VPC Lattice for overlapping IP space, right?
Yes, actually, this is one of the most common use cases that I'm seeing from my customers. And, you know, as Kubernetes users, also in AWS, we use a CNI that basically assigns to each pod a new address. And so you can run out of IPs pretty quickly if you don't manage your address space correctly, thinking about the IPs that are assigned to your pods, but also the load balancers that you need IP, all these resources.
Everything.
So this is pretty powerful, pretty
Awesome.
amazing, yes.
Well, thank you, Federica. Thank you all for watching us today. Please make sure to fill in the survey and give us a 5.
Yes, please.
And let us know in the chat if you have any questions. Reach out to us on LinkedIn if you want to talk more about VPC Lattice, if you want to dive deeper into the service. And yeah, go try it. Go try it out. I'm super excited. I'm going to learn more about containers for sure.
Definitely.
Thank you.
Lattice is one of those products that I think will change a lot of people's lives in a positive way. So yeah. Up next, we have a partner panel. And following that will be a panel with our heroes. These are pre-recorded due to logistical problems, and we will be playing them shortly. So the partner panel is going to talk about whose Kubernetes is it? And then the heroes panel features Liz Rice and a few other heroes from across the globe that are doing big things with Kubernetes right now. So looking forward to both of these. Stick around and we will have them up shortly.
I'm Corey Quinn, Chief Cloud Economist at the Duckbill Group and the author of Last Week in AWS. And this is going to be a panel with people who actually know what they're talking about. This is being presented to you by AWS, who I am told that if I stay on script, I will in fact be released unharmed. Now, let's talk to the people who are actually good at things. Let's begin with you, Anna. Please introduce yourself.
To be determined if I'm good at anything. I'm Anna Doherty. I am the Director of Product Marketing at Armory. Armory is the continuous deployment solution for developers at any size and any scale. Happy to be here.
Wonderful. Armory, sort of Spinnaker as a service, if I remember correctly?
One of many of our product offerings. We also have continuous...
I'm sorry. That's how it started, and then things evolve continuously, as one might say.
One might.
Hari, please introduce yourself.
Hello, I'm Hari, and I work for Selai. We are a company based out of California, and we focus on building autonomous solutions for mainly cloud-native modern application platforms like Kubernetes, Lambda, and ECS. So we particularly focus on cost optimization, application performance, and availability.
I always like when people talk about what they're doing in a cloud-native context, and it doesn't just start and stop with Kubernetes, the end. Like, yes, you do serverless things as well. And yes, there's more than one way to skin that particular cat. I like the approach to effectively deciding that there's more to the world than just a bunch of virtual machines or containers orchestrated in a particular way, and that's it.
Absolutely. Yeah, we have got customers who are very much interested in Kubernetes. At the same time, they like to actually move into this more managed container workflows as well. So there are interest everywhere. Kubernetes is super popular as well.
It does seem to be everywhere whenever you turn around, whether one's expecting it to be there or not. It's a bit of a jump scare like that. Mohan, please introduce yourself.
Yeah, hey, so I lead products and solutions at Raphael Systems. Been messing around with Kubernetes for about 5 years now, and it feels like it's still day one. Learning every day, discovering things every day. The learning never stops.
Yeah, we've been using it for 5 years, and I've almost got it working is sort of how I tend to mentally complete that sentence.
Yeah, that's actually one of the things that I guess people have to be ready for when we talk to people who are just jumping into Kubernetes. We usually give them a smile and say, "Oh man, I'm 5 years in. I feel like I scratched the surface. At least it feels like it."
I suspect we'll be coming back to that particular theme a little later on. But first, Ritesh, please introduce yourself.
Yeah, thanks, Corey. Hey, folks, I'm Ritesh Patel. I am a co-founder at Nirmata and also lead products. I've been in the Kubernetes space, and in fact, before that, in the Docker ecosystem. Interestingly, I actually presented at one of the first Docker meetups out in Palo Alto in like 2013, 2014 timeframe, just when .cloud, the company behind Docker, renamed itself to Docker. So I've seen the whole journey from pre-Kubernetes all the way through now. And so as far as Nirmata is concerned, we are a Kubernetes platform for Kubernetes governance and compliance. We built our solution around an open source project called Kyverno, which focuses on policy as code for Kubernetes. So that's kind of our kind of contribution to the Kubernetes community.
So effectively, it's possible to think of it like SE Linux only for Kubernetes in this case?
For now, yes, to start with.
Great. Everyone claims to be using it, but also puts it into learning only mode or permissive mode, depending upon what side of the fence it is, and then lying about it, which is sort of a best practice. We get on stage and we talk about what we aspirationally wish we were doing rather than the grim reality that we somehow find ourselves working with instead, like darkest timeline, whether we want it to be or not. Let's dive in and have a conversation about some of these things. The Kubernetes ecosystem as a whole is, well, a lot can be said about it. Most of it's even polite, but it's definitely known for its community involvement. And that does extend in ways that aren't in other communities to vendors in this space. How do you folks find that you're balancing community and open source contributions and that aspect of it with paid service offerings? Anna, let's start with you.
I would love to answer this question right off the bat. You mentioned at the beginning Spinnaker, right? Spinnaker is a huge continuous deployment Kubernetes-based open source project. We've been contributing to Spinnaker since the beginning, and it's a conversation we have all the time internally. Is we have people who are passionate about open source at Armory, and so we nurture that passion and we invest in that passion because we know that that's going to help the community as a whole. We're of the mind, a rising tide rises all boats. And so it's very much about investing in the passionate and expert people at Armory, because when they know what they're doing and when they care about the projects they're working on, it attracts others who maybe don't have that expertise at that organization. So by investing internally on people who are good at open source, we can attract paying customers who need that expertise from us. So it works for us to develop that ecosystem, both internally and externally.
Yeah, I can jump in as well. I think similar to what Anna mentioned, we actually did not start out as an open source based company. We actually, built a platform, a SaaS platform, for Kubernetes. But then as we started building different components, we realized some of these components, would have to work inside Kubernetes, and making them open source just would help drive not just the adoption, but also give us that real-time feedback, that is invaluable and that we don't otherwise get, right? And so, with that, we made a conscious investment in the community. We built the community over the last couple of years, went through the different phases of, CNCF, from sandbox to incubating, and it's and really now we have an open core model, right? And invest. So half the team or half the company, I should say, works on on community aspects of things, whether it's documentation, whether it's supporting on Slack channels, whether it's contributing code, and the other half works on products that are built around the open source project.
Yeah, Corey, we guys took a slightly different approach with open source in the community. I mean, most of our customers and our primary focus is on delivering an outcome. So it's a SaaS-based platform that people literally log in and use. It happens to be built on a lot of CNCF projects and things that we have built ourselves around it. Now, what we decided was we're gonna, of course, we don't want to be just taking. We want to give back as well. So we contribute back, and what we've implemented in our model is effectively separation of church and state. What I mean by that is, what we saw in the market was a lot of companies started with the best of intentions, and they said they would have an open source project, and then lines get blurry, and then you have the situation where you take a new feature and say, where am I going to put it? Am I going to put it in the open source thing? Am I going to put it in the premium version? And usually that lands up getting driven by marketing or sales, sometimes outside the control of the engineers, right? And we didn't want that. We never want to even get tempted by that, right? So our open source projects, that is not a freemium model. You have an open source project, we maintain it, and people can use it if they want it. There is no support. We'll not charge you for support. We'll not come and tell you, we caught you, you got to pay support. That we kind of want to stay away from that, right? So you either get the commercial product or you can use the open source product. There's nothing in between, no freemium strategy, nothing like that. So we try to keep it very pure. Otherwise, we feel like we get tempted, maybe over a year or 2 years. It happens. And we didn't want to, because we've been on the other side of the fence, like we got dinged by things we used. So we decided never to go there again. We'll see how that goes out and works out, but clear separation between open source and commercial. That's kind of the model we've taken. Now, the other side is this has also allowed us to kind of be participants in the largest CNCF community. Like, for example, we've been very involved in the rise of platform teams. The platform engineering has become a very big thing in the last year or so. There's a CNCF project that's taken on a pretty large, it's got a momentum behind it called CNCF Backstage. We are contributors, we are participants, we get the word out and drive momentum behind this concept of platform engineering. One little spoke in that flywheel, attempting to get the word out.
Plus, let's not forget about KubeCon, which is part of the reason we're all here today, right? We all love to attend these CDCon and KubeCon events. So thanks for having us.
Yeah, it's always nice to have these co-located events with the larger community stuff as well. I think it's one of the areas where AWS really tends to shine from the perspective of community. It's always strange. We have these vendors that tend to be perceived in certain ways as starting and stopping with a purely commercial offering. It's starting to really express that perception is no longer quite true about AWS in the same way that it once was. A lot's changed even the last few years. And what I'm curious to get your take on collectively is, where do you see Kubernetes growing or evolving in the next 2 to 3 years? It feels like that's both a very long time, but also a very short time frame to wind up thinking about.
Yeah, so can take that. So we have got a lot of customers who are in Kubernetes, and we've got a lot of customers who are in serverless as well. So we see like two end of spectrum. One, people like who really don't want to manage infrastructure at all, or we have people. Since our solution is mostly focused on cloud native, we don't see people who work on bare metal. Our solution doesn't work. We see people having interest in both Kubernetes and serverless. I think there is one area where Kubernetes might actually evolve, where, because of the interest in the managed containers. Right now, Kubernetes do have solutions, like, for example, Fargate, where you really don't want to manage the infrastructure, you can choose Fargate. And Kubernetes also has this excellent cloud control manager,
Cool. Would anyone else like to chime in on that particular topic?
Yeah, maybe I can. Looks like his thing is frozen there. Let me continue. So yeah, what we see is a slightly different trend. Our customers are pretty much in every environment we can think about, right? Like starting with all the cloud distributions, EKS, AKS, GKE, OKE, and like on every cloud, on premises, on VMware, even on edge. We have customers in all of these. And what we are getting pushed by our customers is the following. They tell us, look, Kubernetes is a subset of my larger infrastructure. So the problems you're solving, it cannot be limited and relegated to just Kubernetes. Kubernetes will never eat up everything. It'll always be a subset of something bigger, right? So they are pushing us to look bigger and look wider and say the problems you solve, can you also bring that to the other things around it? And as more and more things get absorbed in Kubernetes, they also want to go wider. We also are getting asked about like I wouldn't call it a replacement for Kubernetes, but Kubernetes is new, right? But it is not going to be the only thing. We all who've been around in the industry for long, we know that things come in waves and everything has a sunrise and sunset. There are things emerging which you don't know how these will pan out. Like a lot of people asking us about WASM and asking us, what does that mean? What does that mean to Kubernetes? Will that go into Kubernetes? Will that go elsewhere? Well, we don't know for sure, but we're kind of participating, watching, trying, learning. Serverless is another thing. How does that intersect with Kubernetes? Is it orthogonal to it? A lot of interesting questions. And the other one is we get asked a lot about edge. And edge is this fuzzy thing where it means so many things to different people. And we are doing really fun projects with pushing the edges of Kubernetes into things we couldn't even imagine before. We'll talk more about that if there's interest, but yeah. So Kubernetes is growing. In summary, Kubernetes is growing, definitely, but is also always going to be a subset of something bigger.
Another way we see is that the maturity of Kubernetes has to increase. Like you said, it's kind of new, and with new things comes security concerns, governance concerns. That's one way that Kubernetes is going to change. It has to mature because it's a little bit out in the open right now. It's a little bit vulnerable. So we all have to rally together and help it mature.
I agree wholeheartedly. The worst present that I've ever received came from my business partner, and it's the reason that I cut his brake cables. He wound up giving me a 1,000-piece jigsaw puzzle of the CNCF landscape diagram. And it is just overwhelmingly vast and complicated. And the problem, of course, with the complexity is that it shows up in a lot of places, but most often in a governance and compliance sense. What are the top issues that you see in that arena coming from your customers?
Yeah, so as it comes to, security, compliance, governance for Kubernetes, I think there's obviously a lot of challenges. Kubernetes is super complex. And we still see, some of the panelists mentioned, it's Kubernetes new. There's a lot of kind of, I would say churn in terms of some of these capabilities within Kubernetes itself, right? Something basic like pod security policies, there's been different versions being, deprecated and new versions come out. So it's still evolving. And I think that's where it becomes a challenge for enterprises who prefer stability in the long run, right? So, some of the challenges that we see and we try to address through our open source project as well as our enterprise solutions is to simplify that area, leverage technologies or techniques like policy as code, give that control to the Kubernetes admins and operators, make it flexible for them. But yes, it continues to be evolving, and there's more work to be done. So there's definitely, more things to come. But that's where, things have to start, like the basics, right? Like you mentioned, SE Linux for Linux. It's basics like pod security for Kubernetes.
Yeah. So just add to that, Corey. So here's an interesting pattern we've seen over the last 3 years. 3 years ago, as a company, a lot of our involvement were with small teams that I would say were the early adopters of Kubernetes at many of these large companies, right? Global 2000, Global 5000 companies. So, and the team we worked with, of course, they were Kubernetes experts. They had done their PhDs in that to the extent possible. These days, we don't see that. You see Kubernetes all over. Most of the developers don't really care when they work on the containers and they say, look, I want my stuff showing up, right? They don't want to run complex commands and learn the complex ecosystem. They just don't want to deal with it. They have no time, right? So what the trend and the pattern we're seeing is people want to drive the car. They want to press a button and they want the automatic transmission. They don't want them stick shift. They don't want to open the engine and replace the engine. And right now, if you want to, you can deal with Kubernetes that way, but it's a hard way. It's maybe the wrong way, right? Looking ahead. So we've been, our customers have challenged us to basically build that car with the automatic transmission, with the button to press, and everything should be like turnkey, so they can get anybody, train them up on this, and not have to hire the rock star Kubernetes expert. This is impossible to find them or keep them. So that's kind of what we've been seeing in the market. So what does that mean? Why is that important from a governance and compliance? Because people don't have one cluster anymore. I mean, an average customer of ours has hundreds of clusters, right? And instead of having snowflake clusters where everything looks different, and then when a security vulnerability is discovered, now they got to ask the fleet, am I vulnerable? They have no idea how to do that, right? So they are challenging the market to provide solutions to kind of deal with this scale, right? And that's kind of the problems we have been attempting to solve using our platform, because we look at this, and we also had a deer in the headlights look 3 years ago, right? And we've solved parts of it, but there's still so much more to be done, which is fantastic for a market like this.
Just like Mohan, we've had the same example is we want declarative deployment. We don't want to have to go through all the individual steps. We want to be able to commit our code and make sure it's there where it needs to be, right? So that's what we've been focusing on as well, and integrating policy engines into that deployment pipeline so that it's automated, it's secure, it's reliable, it's consistent, just like you said. No more snowflake environments. Everything needs to be consistent. So that's one way we really see Kubernetes maturing, is more declarative outcomes instead of individualized.
And then shifting security left, right? Like that's what
Yes.
you're mentioning more in the
Exactly.
CI/CD pipeline and so on.
Yeah,
absolutely.
Yeah, Ritesh, that actually is really, really important, because solving a problem, I think a very good point you made there. Solving the problem after the fact, after the horse has kind of left the barn, is kind of hard. It's such a wasteful exercise to undo mistakes. Shift left, such an important thing, and people they don't always pay attention to it. They're trying, but organizationally they find it very hard to slow down other teams.
So back when I was first coming up, we wound up deploying new code with hopes, prayers, wishes, and of course a shell script that lived in some random engineer's laptop. And 10 years in, we're operating at scales that were unimaginable back then. And instead of using those janky shell scripts, it's now a YAML file that invariably lives on some engineer's laptop that doesn't feel particularly tenable or durable. There's so many steps that need to happen in order for a deploy to work that I don't see how that's going to be sustainable over the longer term. What does a simpler deployment process look like in the fullness of time? So ideally, we don't need a very large team of very expensive people just to responsibly get an application off the ground.
I'd love to answer this first because, like I said at the beginning, we're the continuous deployment solution. So what we've identified are the 80% of those processes that are common across most people we've ever encountered. And we've packaged them into a service so that you or any of your teams don't have to worry about that. That's what we care about. Let's standardize those 80% and then customize what that 20% might be for your individual business needs. We want to take the deployment process out of the hands of that Jenkins guy who's just gonna, be a script runner, and put it into a more sustainable, like you said, more tenable deployment process that many people can access and fulfills 80% of your needs right out of the box.
So where do you, we see a lot of folks adopting GitOps, right? And I think GitOps, is kind of emerged as a term in just last few years. But the idea behind it is essentially Git is something developers know inside out, right? I mean, they are using Git, to check in code, they're familiar with Git, and that familiarity to deploy applications into whether it's Kubernetes or, any other container platform, that simplifies that process, right? And it not just simplifies the process of deployment, but also gives you things like change tracking, right? Approvals. And we see that from a compliance governance standpoint, that along with shifting already left, making, catching these kind of security issues early using things like GitHub Actions, that combination, it simplifies that process to an extent, right? It's no longer a script sitting on a developer's laptop. It's something that you've checked into your repo. And then there's, end-to-end audit of who did what and when and so on.
There sure are a lot of people shifting in their seats uncomfortably right now with the concept that, oh yeah, all developers are deeply familiar with Git. Yeah, who wouldn't understand how that thing works top to bottom? Oh, please continue.
No, I think the jokes aside, you kind of touch on a very important point there, Corey, which is a pattern that we see emerging now. So I agree with everything Ritesh and Anna said so far. Git is it's kind of, everyone uses it. Everyone either does declaratively or Git. That's kind of the gold standard. But we see an interesting pattern emerging now, and we've been kind of in the beginning, about a year ago, we were in denial, but we started embracing it, and we actually now support it in a very interesting manner. So as we started talking to larger and larger enterprises, they said, look, I'm not going to spend 3 months writing YAML or 3 months writing and maintaining complex Terraform code. And they kind of, and this is all before ChatGPT and all of that stuff, where stuff auto generates, right? And they said, look, we first experienced your product through ClickOps. Why can't you auto generate stuff? Like, why does a human being have to write YAML, right? Why does a human being have to write it to Git, right? So this is actually the hottest thing in our platform right now, which is fascinating because I did not see this coming, but we built it in the beginning just to kind of try this out because it's hard for me. I mean, I can't keep up with the YAML, right? I mean, I'm a product guy, I'm an engineer by training, but it's just impossible for me to keep up. So we call this ClickOps to GitOps. So enterprises kind of love it, right? Because it gets them off this 3-month writing and maintaining code, and it's just hard. So they live in ClickOps now, and our platform writes to Git automatically, right? It generates the YAML. I mean, it doesn't know everything, right? So this is a new pattern we are seeing. We think it might solve this problem with the burden of people having to write YAML. I mean, it's like writing assembly code. Who on earth wants to do that, right? And everything in the end on a computer is assembly, but it's generated from easier stuff that human beings write. And God knows what things like ChatGPT are going to do in the market.
It's really strange that ChatGPT, and yes, that's how I pronounce it, is effectively a YAML generator in many cases. And there are a suspicious number of engineers who also tend to be thinking, wait, YAML generator, that's my job. What's going to happen to me? These are exciting times, and we're seeing things evolve in curious ways. So I have to ask, because most of the stories we see around Kubernetes tend to be of a somewhat similar variety. What are the most ridiculous or out there uses of Kubernetes that you folks have seen customers do?
I'll start. I got 2 for you. And these are the most fascinating initiatives that we got forced into trying by some of our customers. We went to the extent of saying, we probably think it won't work. Will you pay us for it? Because we know it's not going to end well, right? But one of them actually worked out. So there was one customer who got fascinated by this concept of a global Kubernetes control plane with worker nodes, they call it a stretch cluster, right? So the worker nodes are in like different continents, and he told him, man, that's not going to work because the worker nodes and the control plane, they got to talk to each other. It's very chatty, and imagine doing that over a very complex network, which is not very reliable, and maybe bandwidth is a problem, but they wanted to do it. But that didn't really work well. It was not reliable at all for them. But we tried it out for them. It was very, very interesting to see it happen. It's just technically curious to see, will it actually work? Do you go down this concept of multiple clusters, or do you have one control plane, a ring that rules it all, right? Is that even possible on a global scale? So that was a very fun project, but I don't think the technology is here yet, at least with Kubernetes, to pull that off at scale. The second thing that we worked on, this actually became a successful rollout, was, so there was this locomotive company, and I won't go too deep because they think of this as serious IP that they have developed together with us. They wanted the locomotives, which are like 50-year-old locomotives, and they said, hey, I want to convert this into a Tesla kind of a thing, right? But there's no internet connectivity where these trains run except at the stations. So what they wanted was, and they have Kubernetes clusters running on these old locomotives, and these are running some advanced analytics and something like that, catching sensor data, etc. So every time the locomotive passes by a station, for about 10 seconds, it'll get it'll get network connectivity. It has to synchronize with the backend, and then it'll lose connectivity. Like it'll go like disconnected all the time, connected for like 10 seconds, disconnect again as it runs at 50 miles an hour or whatever, right?
It's off-prem, on-prem, now off-prem again, effectively, if you time it with a stopwatch. I love that.
So yeah, so the fascinating use case here was these remote Kubernetes-based clusters, which are converting these old locomotives into the modern Teslas, but they have connectivity at these stations for like 10 to 15 seconds, and that they have to connect, synchronize, dump the data, and then lose connectivity in 10 seconds or something like that as the train keeps running. They actually pulled it off, and that was a fun project to kind of make happen along with them. It was a very, I never thought something like that could be done, Kubernetes. But yeah, it's a really interesting use case of Kubernetes.
Yes, on my side, I'm not sure about kind of ridiculous use case, but an inspiring use case, and I think this is becoming kind of fairly common now, is in healthcare industry, especially leveraging local Kubernetes clusters or applications running in local Kubernetes clusters to kind of distribute things like medication for diabetes and things like that, right? Insulin and things like that. And we work with a healthcare company to be able to do that, especially in remote regions like India, Africa, places like those. And I think that is inspiring. It's if without that, it would be challenging for them to kind of manage or kind of distribute across various different Snowflake type environments. So Kubernetes certainly helped make that possible.
Okay, last question for you folks. What is your number one tip for running Kubernetes in production? Bonus points if the answer is not effectively selling the thing that your company does. Take it away.
Yeah, maybe I'll start. So I think the most important thing for running Kubernetes in production is actually the thesis of how the community kind of operates today, which is move fast. Everything is changing around you so fast, right? So it gets to be very hard for a larger team to kind of keep up with all these changes. People want some semblance of standardization. So don't when you have 50 moving parts, don't change things arbitrarily. Make sure you are testing stuff ahead of time, because believe it or not, you're playing with dominoes here, right? Like if one thing falls, everything else is going to fall apart. So try and avoid pain by being a little careful in production. Slow down a little bit. Don't have to be on the latest and the greatest version of everything.
I would say the tip we would want everyone to take away is that it's almost what Mohan is saying, but the opposite of that, which is don't be afraid of production. Production's where your code reaches its best value because it's where people can actually access it. So make sure you're enabling processes and people and DevOps practices that are solid, include testing and validation before you get to production. But enabling is such a huge component of that so that you're not afraid to commit to production at the end of the day.
Yeah, you pretty much told what I was going to say, but it's along the same lines, right? And we talked about this a little bit. Obviously you don't want to experiment in production, so you want to put processes in place to catch things early. Be kind of diligent about it, right? It's like you don't want to find out issues that too late in production. And obviously that becomes very costly and time consuming. So put those checks and balances in place early on in your development process.
Shift left, as you said earlier.
Mm-hmm. That's right.
I really want to thank all of you for taking the time to share the benefit of your experience with us here at the AWS Container Day that is co-located with KubeCon. Thank you so much for your time.
Thank you.
Well, thank you, Corey. Thank you, AWS, Anna, and Ritesh. Great talking to all of you.
Thanks, everybody. Thank you.
Hey, thank you all for listening. Next up, we have our Heroes panel. I apologize. I got the order out of sync. It happens. We're live streaming. But I really enjoyed producing this, and I think you will enjoy watching it. So please stick around and enjoy the next panel.
Hello, everyone, and welcome to our Hero Panel discussion at AWS Container Day featuring Kubernetes. I am joined by some very special guests. They are both cloud native industry experts and AWS heroes. And some of you might be wondering, what is an AWS hero? Well, for starters, they don't have secret identities because we want you to know exactly who they are. They're AWS experts. They have specialized domain knowledge in different areas in the AWS landscape, and they are committed to helping others in the community accelerate their learning path and journey by creating different forms of content. And so that being said, I want to kick off with some introductions. Liz, how about you go first?
Hi, thanks, Luke. Yeah, my name's Liz Rice. I am Chief Open Source Officer at Isovalent, which is the company that originally created the Cilium project, which many of you will know for networking and network security in Kubernetes. And I'm also on the board at the Cloud Native Computing Foundation, and I'm an O'Reilly author as well.
Fantastic. Alvaro.
Okay, so I'm Spanish, so my name is Alvaro, but everybody calls me Alvaro, and I'm more than fine with that. I am actually an Amazon data hero since 2019, specialized on data hero. And I actually am the founder and work at a company called Ongress, which is a short for On Postgres. So that should tell you pretty much everything that we do. We're all Postgres all the way down. Actually, you can barely see here, but there's the trunk of a blue elephant just right on top of me, which is the Postgres mascot. So I spend most of my time obviously working on Postgres, and since 2020, we launched an open source platform for running Postgres on Kubernetes called Stackgres. And we have since then applied a process of trying to transform an make an evolution of Postgres to make it more cloud native. So it's a very cloud native friendly way of running Postgres on Kubernetes. And that also brought us a lot of experience with running production workloads on Kubernetes, especially stateful workloads.
Excellent. All right, Jacopo.
Yes, thank you for inviting me. First of all, yes, my name is Jacopo Nardiello. I'm the founder and CEO of a company called SIGAP. We are a cloud-native Kubernetes verticalized company based in Italy. Actually, the team is pretty much spread across Southern Europe, but yeah, I mean, we are Italian-based. And I've been working on Kubernetes since 2015, late 2015. So, I double as an AWS Container hero and a CNCF ambassador. Been involved into the community for a pretty long time. SIGAP before you start wondering, the name is from Signal Hang Up. So we are actually named after a Linux kernel, Signal, and that says pretty much everything about the company.
All right, fantastic. So I want to start by maybe kicking off with a question that some folks wouldn't probably expect. Right now, there's a lot of excitement about Kubernetes, continued growth and acceleration in adoption, but let's put a spin on it and help people that may be wondering, when is the right time not to use Kubernetes?
I could start with, I don't think you should be using Kubernetes unless you have a good reason to use Kubernetes. I'm a massive fan of containerizing applications, but there are plenty of ways you can run containers that don't necessarily need full control over the whole orchestration that you get with Kubernetes. There are lots of applications, there are lots of companies for whom using a managed container service might be more appropriate, maybe even using serverless might be more appropriate. But if you are building, a microservice-based architecture with lots of moving parts and you want control over all the various different, bells and whistles that you get in Kubernetes, you're going to get a lot of power by using it. And, don't jump into that quite deep pool unless you've got a good reason to make that jump.
Actually, let me shed a slightly different light on the topic, if I may. Actually, I'm typically asking people the opposite question, like, tell me what's your reason not to go Kubernetes in the first place. But there's strong reasoning behind that. It's not just because the next, I hate trends, I use Kubernetes because the next big thing. No, that's obviously a wrong answer. But what I've seen, and this is actually one of the things that led us to our decision to jump into Kubernetes from some software like Postgres, which we can call a monolith and old legacy software. Actually evolves every year, but for someone this may sound quite strange. The reason why we jumped into Kubernetes is because we were really tired of trying to find a way to package a single deployment unit, which is Postgres plus all the components that it needs, across many different environments. And Kubernetes provides us not only, first place, a unified platform to deploy this into, but also the opportunity, because of the automation you can achieve via the API, to automate operations that right now humans need to run. Now they can run almost automated with a small assistance. Obviously, this requires complex and advanced operators to do all these tasks. But the level of automation and homogeneity you can achieve today with Kubernetes is very compelling. So I would say by default actually could be a very good option for most people. Obviously, you need to know what you're doing. But still, to answer your question, I would say that there's a strong reason not to use Kubernetes, which is when you need to cross the boundary very frequently. And the boundary, I mean, calling what Liz was saying, these external services, like, services hosted on a cloud computing platform like AWS, or your application is like 90% relying or 60% relying on these external services, crossing the boundary creates challenges because deployment and operating models are quite different. So there's, other than performance and security, which might also be concerns, crossing the boundary too frequently for me is a signal that maybe your application shouldn't be hosted on Kubernetes.
Excellent. I appreciate those insights. Yeah, Jacopo, please.
Yeah, if I may add one thing to everything that Liz and Alvaro already mentioned, it depends also on your team, how mature they are, how technical they are, how much they actually want to get deep into managing and working on Kubernetes. I've met plenty of people saying, no, our job is doing something different, right? So we want to run our own application. That's where we want to focus. We are just a couple of people, 3 people, 5 people, whatever, right? We have tons of services to run, and the infrastructure should be, we want just to spend as little time as possible on top of that. That could be a valid reason, right? The second thing I would say, which matches a lot with what Alvaro said, is the other side of the coin, meaning when it comes to technology. So your technology stack should be ready for that. Not everything is supposed to run on Kubernetes. So it's, it depends, right? So it depends on, also the kind of workloads, the kind of technical stack that you need to run, and, your specific domain. There are a ton of factors, I guess, that you need to consider.
Excellent. I'm actually going to cherry pick something that you pointed out. I love the fact that you brought up teams, and I want us to drill down a little bit further in that. There are still debates and discussions about who Kubernetes actually belongs to. So let's say we have to consider maturity, but what about the platform team or the DevOps team and the application developers? What does the responsibility model actually look like for these different teams when Kubernetes is being adopted?
I do think we're seeing some really interesting evolutions of this idea of the platform team or a platform engineering team. And I think it becomes particularly interesting and important, particularly in the kind of networking and security space, where people are looking at multi-cloud, multi-region, perhaps speaking a little to Alvaro's point about, having legacy workloads to communicate with. There are a lot of challenges there that are quite often networking related. And we've almost gone from the DevOps team being very much sort of organized around administering a Kubernetes cluster to this whole, no, you're going to have a team that have this broader remit, understand about not just how these different workloads are going to communicate, but how they're going to be kept secure and kept, if you're going to cross boundaries, as Alvaro said, from one cluster to a VM or a different cluster or some completely different environment, you have to make sure that your workloads can do that, but random people on the internet can't. So there's a lot of challenges in this multi-cloud, hybrid, evolving world that we are beginning to see a lot.
Yeah, I absolutely agree with that. And actually, I would also like to take this question more from the perspective of the different teams that are involved, right? Like this platform engineering teams. And oftentimes what I see is that maintainers of typically called platform teams, right, of Kubernetes infrastructure, they like to have things like very well structured, right? So they can be analyzed from a security perspective, networking perspective, as Liz was saying, etc. And I may be biased here, but this, in my opinion, should end up laying down on top of operators, because it's a way to, once you get to know them and you know how to operate them, you can establish very well good practices or good patterns, right? However, development teams want to be a little bit more agile. Sometimes they say, like, deploy this YAML, deploy this YAML, deploy this YAML, this container here and there. It's a little bit like Docker Compose style, except that on Kubernetes, right? And that's where the clash sometimes happens. But at the end of the day, it's just, it's a communication issue. And I think it can, get iterated over time to agree on which things are deployed by operators, which things are deployed more, custom style, if you want to call it that way.
Yeah, if I may add something, I'm really excited about all the IDPs, developer platform, internal developer platforms, this whole, platform movement that is shaping up and gaining traction. Building the right set of abstractions for your organization is probably the key, right? And it's where you should invest the most time, providing the correct abstractions to your developers so that they can go fast enough while retaining control and facing all the challenges, as Liz, as she was saying, like even the lowest level in the stack. So how you handle networking, how are your regions organized, how is your cloud or non-cloud adoption going, how are you running your own infra? So on one side, we are recognizing that we need vertical experts and we have vertical challenges, no way around it. On the other hand, we are also realizing that we need to build the right abstractions for the developer teams, and we cannot just throw the complexity on top of them and expect that everything will go well, because it doesn't work like that.
I totally agree with that. There's some really interesting things in that kind of developer experience space or developer platform space. So things like Backstage or Kratix, where, I've just been talking about that kind of low-level networking stack, but the same team also needs to have sort of the ability to get their developers on the same page with regard to documentation and how do they advertise their services to each other. So there's a huge, just as Jacopo was saying, that there's this huge range of different skills that we're really requiring from what we're calling a platform team.
Absolutely. And just another question on that particular topic. What do you think the things, the various things a team should work through when deciding whether to perhaps build their own developer experience platform or perhaps get an off-the-shelf product?
I think the answer is pretty much whatever fits your needs, right? If there's an existing product that already does what you need, I would definitely go for that because that's probably orthogonal to your business needs. But if it doesn't, probably you need to go that route, right? But the good thing is that, again, Kubernetes has really, really rich and powerful APIs, which allows you to achieve really high levels of automation. So as long as that process that you're defining is not that complex, it shouldn't be a big deal anyway. But if there's an existing tool to do the job, just go for it.
Yeah. I'm going to take a bit of a turn here. I was reading a Cloud Native report by Canonical, last year's edition, and it showed that a number of teams or people are actually running stateful workloads in their clusters in production. However, I find that there's still this perception that the maturity isn't there as yet, which may be a misconception. And I'd love to hear your thoughts on running stateful workloads and this narrative that still seems to be out there about being somewhat apprehensive when it comes to running stateful workloads in the clusters.
I'll jump in.
Perhaps you could kick off.
Yeah, sure. Conventional wisdom, once it is already established, it takes time to shift it away, right? And certainly stateful workloads several years ago were not really appropriate target for Kubernetes. But things are different today with stateful sets first, which are not the perfect solution, but they're not bad either. And the advent of operators, and really there's a lot of complex operators for stateful workloads as of today. There is efforts in which, for example, we participate, like data on Kubernetes, and a more recent effort for data on EKS that are related to show that it's certainly possible and even advisable to run stateful workloads on Kubernetes. Such as the initial concerns regarding performance, security, or stability of those systems are all ironed out years ago. There's no technical reasons not to run in any production quality stateful workloads on Kubernetes. Actually, I would argue that there's strong advantages in doing so. Speaking of Postgres, which is an example, it comes handy for me, but Postgres is a not batteries included software. It is something that it's kind of I call it like a Linux distribution. So where Postgres is a Linux kernel, you still need a lot of tools around it to run a production. Like a Linux distro, you need the shell, you need the init system, you need whatever, right? So you need a lot of tools around it. And to install, coordinate, configure, deploy all those tools by hand, it's a really complex thing to do, and especially to do it right production quality. Kubernetes, you can automate all this. On any infrastructure because of this homogeneous platform that it exposes. This is already a significant advantage over a non-Kubernetes way of running things. But then thanks to the capabilities of Kubernetes, you can create self-healing options that are even better than with VMs or bare metal, or at a really high cost. But even farther than that, operators, and sorry for the shameless plug, but Stagres, we have automated up to 9 DBA operations, day 2 operations, thanks to Kubernetes APIs. This is non-existing outside of Kubernetes. So the level of automation and correctness of deployment in Kubernetes could be much higher at a simple cost or small cost compared to other platforms that are non-Kubernetes. So from this perspective, I would say data on Kubernetes, stateful workloads on Kubernetes are very mature as of today. They will evolve even further. But should be, and I actually wrote a blog post about this at the News Stack saying that should be that primarily your default choice. There's reasons not to do that, but should be your default choice.
All right, excellent. I'll keep an eye out for that blog post. I'll definitely search for that. Any other thoughts on that particular topic? All right. Liz, firstly, congratulations on the release of your recent book, Learning eBPF. There's a lot of excitement and buzz around eBPF as a technology. I still recall being at KCD Amsterdam earlier in the year, and a lot of folks were talking about it, but there was also the same thing that kept coming up, and that was people saying that the learning curve is steep. What do you think is a good way for people to get started with eBPF?
You mean apart from buying my book?
Right.
Yeah. It's absolutely true. I mean, eBPF is essentially a way of programming the kernel. So it very quickly turns, thank you, Alvaro. It very quickly turns into kernel programming. You know, you may be accessing data structures within the kernel, so you kind of have to know what you're doing. But I don't think most people need to learn how to program eBPF. Most people will use eBPF through other tools. So that could be things like, I mean, we're talking about Kubernetes. There's a tool called Inspector Gadget, which gives you kind of the equivalent of some really nice command line observability tools, but with the Kubernetes information attached to it as well. So you could, for example, see whenever any of your applications are accessing files, for example, and you can get information about which pods and nodes and namespaces and so on are involved. Or Cilium, for example, we've got a lot of information about your network flows available to you that we're obtaining, and we're not just doing the networking using eBPF, but we're also providing observability of that networking using eBPF. So for a lot of people, their exposure to eBPF will be through these tools that already exist. That said, I think it's because it's such an interesting technology. For me, I really wanted to know, okay, how do I write hello world? How do I get into these kernel data structures? And that was what sort of set me on the journey of wanting to learn and then eventually write a book about essentially how to get started programming eBPF. It's really all about building up a mental model.
Excellent. And I imagine the curiosity also helps you persevere through the different areas that you'd be navigating in eBPF.
Definitely. I think that's, the thing that software engineering teaches you as a profession is approaching problems logically and, building hypotheses and proving or disproving your hypotheses. And a lot of what I do when I'm, creating talks or writing books is really around proving to myself whether my mental model is correct by writing some code to test that hypothesis, and then using that to sort of explain it to other people.
Yeah, excellent. All right.
And if I may
Jacopo. Oh, please, yeah.
I'll share 30 seconds personal experience about this. I because of my role as a founder, I don't have much time for tech work, but I love to do it. And on my part-time, I'm also a Java programmer. And some time ago, I decided also on the remaining of my free time to learn a little bit about eBPF. And yes, I had to change my mental model quite a while. It's been more than 20 years I don't do any C programming. This is not even C, well, kind of. But I enjoyed the journey a lot. Of course, now I just got to learn a little bit more. But it was really, really interesting, challenging, but at the same time rewarding.
Excellent. Thanks for that, Alvaro. Thanks a lot. Jacopo, what would you say are some critical considerations that teams should make when they're trying to decide between a managed Kubernetes solution or a self-managed solution?
Only easy questions today, Luke. It's so it's a big question. The very first thing I would say is, and this is actually our area of specialty, right? So the very first thing that anyone needs to realize is that running Kubernetes is not just running Kubernetes. So running Kubernetes, whenever we're talking about a managed Kubernetes service, whatever that might be, that's going to handle the cluster lifecycle. That's it, right? Running Kubernetes, you need a ton of other stuff. You need your observability, you need your logging, you need your networking with maybe special settings. You need to take care of a whole lot of problems, and and that's the real cost of running Kubernetes. It's not about how do I set up my cluster and how do I update my cluster. That's actually the part that has been solved over the years pretty well. So right now we have, with EKS, a very comprehensive set solution. It's getting mature. You can, it does really makes easier to run Kubernetes, but that's not where the complexity is, in my opinion, right? And so, yeah, it's, that's where you need to focus. You need to ask yourself, how I'm going to run my applications, how I'm going to run my environment around, to make my applications production grade.
That's excellent. I really appreciate what you just shared. And I think it actually goes back to something you mentioned earlier about considering your applications as well as part of the journey when you're going to adopt Kubernetes. Could we talk about that for a little bit? What are some of the main things that teams should be considering when it comes to application readiness and the kinds of applications that you should be running in your Kubernetes environments? Jacopo, perhaps you could pick up from where you left off.
Yeah, well, I could be talking about this stuff for like next day probably. I would say, so for sure, stack, that plays a big role, right? That's not a unique thing, but one thing is I'm running, I don't know, a Node.js application, which is already kind of small, and another thing is I'm running a COBOL application that used to be running on a mainframe. That's like, two different, let's say a two different thing, right? And that's the very first thing that you need to take care into. So, I mean, the size, the stack, how cloud native ready your application and your overall architecture actually is, right? And then you have the Kubernetes specific stuff like limits, requests. How do I schedule the stuff on my worker nodes? What kind of instances I'm going to use? Is this like, can my application be killed easily? Or do I need to take care of stuff? Or I'm going to break the state of the application itself and it's never going to get back up. So it's not really, these are the kind of things that, in my opinion, are going to be the big challenges when it comes to adopting Kubernetes. That's, for the application part. And then you have the infrastructural challenges. So.
Excellent. No, those are very valuable points. Liz, I think you were about to chime in on that.
Well, I was just really thinking that, a lot of engineering effort could be applied to converting monolithic applications into microservices. And, you should definitely think twice before embarking on such a journey. Things that you can do with microservices under Kubernetes, like scaling, right sizing different services to match the load. They're really, really powerful. I think that's, the modern way that applications should be written. I don't necessarily think you should have to, feel obliged to convert all of your pre-existing applications. It may, the cost may be well outweigh the benefits of doing so. But I definitely think, for new functionality, thinking about, well, how do you expect your application to scale? How do you expect it to be responsive? How do you expect it to be energy efficient even? All of these things can have some answers, or Kubernetes can help to provide the answers to some of those questions. So I would definitely be encouraging people to think about containerization and scaling as part of their planning when they're first thinking about new build.
Excellent. All right, just before we come to a close here, I do have to ask each of you one last question. What excites you the most about the future of Kubernetes?
Okay, let me get started with that. So there's a couple of things I would like to say. One is the multi-clustering effort. I know this is a complex topic. It's been discussed for years. I don't know if there's light at the end of the tunnel, but this is very important for many scenarios. Like cross-region failover, disaster recovery scenarios. This is quite important. So I'm quite excited about seeing the end of the tunnel for this particular one. But on the opposite side of the spectrum, I would like to see even leaner ways to run Kubernetes like anywhere on your developers' laptops, etc. There's K3s and similar efforts, micro-K8s, they all work well. But still, I see, even myself, find myself, my teams prototyping with Docker Compose before jumping into Kubernetes. And there's a bit of a friction there. It's not too big, but it's big enough that you use Docker Compose, and then once you prototype things, then you move down to Kubernetes. I would like to go Kubernetes directly, and I'm sure there's some small efforts left there to be done.
Great. Jacopo.
For me, I'm super excited. So I've been, the role of Kubernetes into, building an open ecosystem has been incredible. And I'm super excited about the continuous effort that the community is putting into defining new open standards. So for me, it's more of an organizational thing, right? So Kubernetes is enabling the community and everyone to build stuff because it's defining standards. And I think that this is the biggest role that it's been playing, and it will keep, that's where the biggest value is. Of course, then there are the technological challenges, which are still great. But
love it. Liz, and yourself?
Yeah, I'm extremely excited about the tooling that eBPF is enabling, and some of the really cool things that we're able to do with observability and with security as well. I think, we're going to see some really game-changing ways of using eBPF to observe security-relevant events and starting to treat runtime security as something that we handle in a preventative way, the same way that we currently expect firewalls to drop packets. We don't worry about whether or not, if a firewall drops a malicious packet, it's going to drop the packet. We don't inspect it later and sort of let it pass and then look at it. I think we'll do the same thing with runtime events. We'll start saying, there are a category of runtime events that we can observe with eBPF, and we know we do not want those to happen, and we're going to prevent them using eBPF. I think that's going to be really game-changing.
Fantastic. All right. Well, I'm sad to bring things to a close. I've certainly enjoyed that. Thank you for your time. I hope everyone tuning into this session can reach out to you individually on social media, and enjoy the rest of AWS Container Day.
Hi, all. Hope you enjoyed those panels. What'd you think, Nathan? You're on mute, buddy. Sorry.
That was pretty nice. It was nice to hear from some of the industry legends about where Kubernetes is going, what they're working on, and what they see as kind of things that are coming up around the corner, next for keeping an eye on. It's always nice to get an idea of what should I be studying next, whether that is Liz Rice talking about eBPF and everything else like that. And I like the fresh, honest takes on some aspects of Kubernetes. What could be better? What do we need to work on? And I don't know. What do you think?
It was great, right? Like the idea of thinking of Kubernetes first as opposed to like at the end of the list, I think is interesting. Alvaro did a great job kind of breaking that down for us. Yes, say what you want about state and its difficulties, but it is an interesting concept when you think, oh, we're going to use Kate's APIs first as opposed to something else.
Yeah, I saw some debate in the Twitch chat about, do you recommend Kubernetes first or last? I think there's trade-offs either way. I do think that designing your application in such a way that you can work within an API is a good constraint to at least consider, because it's all too easy if you're deploying stuff, for example, straight onto an EC2 instance, to do some really weird setups that aren't good practice, isn't going to scale very well, and isn't going to transition into success later on. And so I think there's a lot of benefit to be had from picking an API, whether it's Kubernetes API or they mentioned also Lambda or ECS API, some API, and saying this is the API that I'm going to live within the constraints of, and I'm going to pick that ahead of time and start implementing that. Maybe don't go too deep down the rabbit hole too early, but think ahead a little bit as well.
Yeah. All right, folks. So next up, we have the wonderful senior manager of product and advocacy for Kubernetes here at AWS, Nathan Tabor. Nathan, how are you? Hope you're well.
I'm doing really well. How are you?
Doing great. Go ahead, take it away, introduce yourself, have at it.
Perfect. Can you guys see my screen okay? Is that showing up well? Oh, Chris, you still there?
You are live. The screen is up and we can see your slides.
Okay, perfect. Thanks, Nathan. Appreciate it. Hey, everybody. My name is Nathan Tabor, and I lead the product and advocacy team here for Kubernetes at AWS. Really excited to be broadcasting live here from beautiful Amsterdam. And we're going to be talking a little bit about the future of Kubernetes at AWS. So a lot about the stuff that we're working on, the stuff that's coming up. I know that Barry Cooks joined you earlier today, talking about kind of what we've been doing on EKS and some of the big stuff that's happening. And I want to touch base on a few of those items and then also talk about what's coming and kind of what are the big things that we're working on. So let's start off with what are our goals? Why are we doing this? And what are the things that our customers really care about when they're using Kubernetes? So we see customers using Kubernetes for kind of 4 general big purposes, right? They want to standardize their IT operations to accelerate delivery and accelerate the changes that they can make. The more changes you can make, the faster you can innovate, right? If you can't make a change, if you can't deploy new code quickly, if you can't have multiple development teams working on a set of problems all together at the same time, then it's going to be really slow to introduce new features or to modernize systems. So standardizing those operations so that you can make more changes more quickly leads to better innovation, leads to competitiveness. This is a big reason why customers are moving to Kubernetes. The second reason is they reduce fixed expense. We see customers adopting Kubernetes. They're lowering their fixed costs by significant amounts, sometimes more than 10x, right? And they're eliminating complex contracts. They're eliminating management overhead of legacy systems. So big cost savings moving to Kubernetes. Also enabling entire organizations. So some organizations are incredibly siloed for many reasons. They have different dev teams that are using different stacks, different sets of tooling. They may have evolved at different times. And with Kubernetes, customers are driving consistency through the organization, eliminating those silos, allowing them to support multiple environments and different use cases, all from a single kind of best practice in the company. And then also planning for the future and reducing risk. Kubernetes is an open standard. We're here in Amsterdam at KubeCon, which is KubeCon and CloudNativeCon. Cloud Native Computing Foundation obviously owns and maintains the Kubernetes standard. And having that standard allows companies to really plan for the long term and reduce the long-term risk in their IT investments. So these are the goals. These are the things that our customers really care about and the reasons why they're adopting Kubernetes. And so how are we meeting those goals, right? Well, what's our report card and what are we doing about it? Barry talked a little bit about our report card and showed a really great slide this morning around the different levels of development that EKS has gone through over time, going from the control plane to the data plane with the nodes to cluster operations and cluster management. And these are the things that we're working on now. These are the things that are on my mind and my team's mind as we think about how do we innovate to help customers achieve those 4 goals. So first, centralized and simplified cluster management. How do we make it easier to launch and maintain lots of clusters from a centralized place? Building application-ready clusters. So how do I get to a point where I can launch a cluster and run my application and have to do less manual work and labor thinking about how that cluster is configured? The third is cost visibility and efficiency. Right now, cost visibility and efficiency are a huge topic with customers, looking at how do we squeeze every piece of efficiency out of our infrastructure. How do we make that infrastructure as efficient as possible? And so we're doing a few things with EKS to make that happen. Access to AWS capabilities is a big theme for us. You are with EKS, right? We're running Kubernetes on AWS. We're running Amazon EKS on AWS. And so we want customers to be able to take full advantage of AWS services if they want to use those. Obviously, there's a lot you can do inside of the cluster, but there's a lot of value from being able to use Kubernetes alongside AWS primitives. And then finally, being able to deploy in any environment. AWS is a primary environment for us. Obviously, a lot of customers are there, but if we're going to centralize and simplify cluster management, we also want to help customers who are deploying on premises or in other environments. And I'm going to show you a little bit about what we're doing there. So let's talk about making Kubernetes like a centralized hub for operations. This is our vision, is that Amazon EKS is a center for your Kubernetes operations. And there's a lot of things we've done, and there's a lot of things we're going to do here. So today, you can actually see everything in your cluster. You can navigate through every object. You can see complete configuration data. You have deep linked AWS resources. This is a really neat feature. I don't have a demo of it, but if you're running an image from, say, Amazon ECR, we actually give you a deep link into that image directly out of the cluster. We give you deep links directly into EC2. And the goal here is that you should be able to see everything in your cluster and across all your clusters at the touch of a button. We've started to integrate metrics from those clusters into the EKS dashboards. If you go and you look at nodes, if you look at other objects, you're going to see integrated metrics. Obviously, we're working to add even more data, more metrics into the console as well. And it also allows you to connect everywhere. So it's not very useful having a hub if I can only see a few things. And so with EKS, you can actually get this unified operational visibility across all your Kubernetes environments. So I have a little example that I put together here where we can actually look and you can actually see we have clusters in EKS, we have clusters in EKS Anywhere, we have clusters running in other clouds as well. And we can pull those clusters together and be able to quickly look through them and understand what's happening with them. So this kind of pulls Kubernetes together, makes it a hub for all your operations. So this is the first thing we're doing to simplify the management of Kubernetes. And we have a lot of other stuff coming as well. So along with managing your clusters and being able to visualize them together, you also want to be able to implement really strong security across all these clusters. So there's a feature that we're working on, VPC CNI network policy support. So we're bringing native network policies into the Amazon VPC CNI. And this allows you to basically get security for your network policy implementation on the cluster out of the box. Today, without this feature, you have to run multiple agents and other configuration on the cluster to enforce those network policies. And with this feature, it just comes alongside every single cluster. You have native network policy support. Really easy to go ahead and manage what's going on and what traffic can talk to what on side of the cluster. So in addition to network policy support, we're also adding what we call a feature called cluster access management. And so what this feature is going to do is it's going to move all of the AWS auth config RBAC controls out of the cluster. So today, if you want to control which people in your organization and which IAM roles have access into the EKS cluster, you have to actually go and configure this auth config map. It's a file inside of every single Kubernetes cluster. And this makes it really hard to manage lots of Kubernetes clusters at scale because you have to go ahead and actually set up and configure all of these different files. And you have to keep them up to date and you have to keep track of them and you have to modify them. And if you mess one up, you can lose access to the cluster. So we're taking all of that and we're moving that into the EKS APIs. So that's going to be available through Terraform, through CloudFormation, through the console, and through EKS Cuddle, right? And when you set your cluster up, you can say, these IAM entities have access to these parts of my cluster. So if you want to do, access to a single namespace or access to certain operations, you can configure all of that through Terraform, CloudFormation, or the console. And you can do that when you set the cluster up, or you can change it at any time. So you can't get locked out of the cluster. and you can easily configure permissions and settings across all of your clusters. So that's IAM access into the cluster, but also a lot of applications inside of the cluster use IAM in order to access AWS resources. So if your application needs to write data out to, say, an S3 bucket, then you need to give that application IAM permission so that it can access that S3 bucket securely. And so there's a feature today called IAM roles for service accounts. And what this feature lets you do is it lets you assign IAM roles not to the node where any application running on the Kubernetes cluster can access that permission set, but it allows you to assign these IAM permissions directly to a service account, which can be linked to a Kubernetes application. So you get application level security controls within the Kubernetes cluster that specifies which resources in your AWS accounts that application can access. Now, this is a really cool feature. It's been out for a little while. We're really proud of this feature, and it's incredibly useful, but it's difficult to set up. It's difficult to manage, right? And there's limitations to how many clusters you can use. There's complexities around mapping those IAM roles down to the clusters. And so what we're doing this year on the roadmap is we're actually simplifying this IAM roles for service accounts so that you can use it with all of your clusters and you can use it seamlessly. You can create fine-grained IAM permission policies based on attributes such as cluster name, namespace, or service account name, or your pod name. So previously, you may have had to create IAM roles with distinct policies for every cluster. And now with IAM roles for service accounts update, we have support for session tags. So you can author a single role and a policy with, say, cluster name as an attribute, and ensure that clusters can only access, like a cluster can only access its own resources that are tagged to it with the matching cluster name. So not only are we making this easier to administrate, but we're also making it more secure. It makes the permissions a lot more intuitive so that you can say, okay, this cluster can access these resources and this other cluster can access these other resources. And so this all simplifies the administrative experience of managing access both into your cluster and out of your cluster with IAM roles for service accounts. So those are some of the updates we're making to kind of making Kubernetes EKS a central hub for central operations and also secure centralized operations. Let's talk about production-ready clusters. It takes a lot of work to make a cluster production-ready. So you have to set up monitoring, networking, security, observability, storage, cost management. All of these capabilities, when you set up your Kubernetes cluster, there's various agents and plugins and add-ons and things you have to run. So we know that those add-ons come from a lot of places. They come from the open source. They also come from vendors. And so what we've launched recently is the ability to pull all of this into the Kubernetes cluster using what we call EKS add-ons. So EKS add-ons is a set of APIs that allows you to start, manage, and upgrade various operational tools that are installed onto the EKS cluster. And this lets you template out the cluster and all the tools that you need to run on it in a single place. So you can template that out in Terraform or CloudFormation. You can use the console to set this up if you want, though we find that as people go into production, they tend to move to infrastructure as code tools for this. And what we now have is we have a set of common open source tools that are built and vended by AWS that you can launch on your cluster. And we also have a set of vendor provided tools from AWS Marketplace that you can subscribe to and launch onto all of your clusters. So this lets you complete the ecosystem around the different things that you can bring onto that cluster natively out of the box with EKS. And we're looking at these two experiences, and we're also thinking about, in the long term, how do we bring even more software into the cluster? I can't speak too much about that today, but it's something that you should stay tuned for, and it's on our roadmap. So let's talk about cluster updates. Having that ready cluster that's ready to go is really important, and managing those updates takes, it can sometimes take a long time. So we're doing a lot of work to help customers keep their clusters up to date and running quickly. So something that we've recently released is faster updates. So previously, updating a cluster took around 40 minutes. It was the kind of thing where you would start the cluster update and you would go have lunch, maybe have a meeting, or come back in the morning and the cluster would be updated. And now it takes about 10 minutes or less than 10 minutes. So it's time to, grab a coffee or check some email and the cluster is ready and up to date. And this change has allowed us to roll out not just new version updates faster and get you onto the new version faster, but also allows us to roll out critical bug patches and fixes to EKS a lot faster than we used to be able to. So that's really good. The speed is really good, but the team is not stopping there by any means. We're looking at doing 3 additional things that are going to really help upgrades. So first is what we call single-click upgrades. So today, if you're going to move to a new Kubernetes version, you have to upgrade the control plane, you have to upgrade your nodes, and you have to upgrade those add-ons that we were just talking about to the latest versions. So those are 3 actions that you have to take across the cluster, sometimes multiple times, right? And if you're running, say, 5 clusters or 10 clusters, those 3 actions can become, 15 actions or 30 actions, or if you're running 100 clusters, 300 actions, right? Like it can take a long time to manage all of these things. And so with single command updates or single click updates, a single API call or a single button in the console will bring your cluster to the latest Kubernetes version. So we think this is going to bring the number of commands and the amount of coordination that customers have to do down significantly. And of course, this is all done in a very safe way, right? Like we wait for one operation to complete, we check that it's healthy, then we move to the next one, and it's fully managed by AWS. The second thing that we're working on is giving customers more confidence when you upgrade to a new Kubernetes version. So version updates can be a little bit scary. There's APIs that change. Sometimes there are breaking changes. Sometimes there are changes that can completely you need to change the code that's running. You need to change how you're calling Kubernetes APIs, and these are things that you have to carefully consider. And so having confidence that when I hit that upgrade button, this cluster is not going to break is really important to be able to move to new Kubernetes versions and to take advantages of the features and the bug fixes and all the enhancements coming out of the upstream community. And so what we're working on is a feature where we're going to actually do pre-flight checks. We're going to look ahead and say, what's going on the cluster? What could potentially break if you press that button to move to a new version today, and to be able to give you a report that tells you exactly what you need to go and address so that you can have confidence to move to the next version. And as part of that, you can imagine you can start to actually begin to automate and move towards upgrades in a more automated fashion. But in order to do that, you need to have information about what's available. So today, there is no way to programmatically understand what's available from EKS as far as versions and compatibilities. So our cluster metadata API will be designed to give you a programmatic way to check which Kubernetes versions are available and what are the compatibilities between those versions and various software, between the control plane and the nodes, the control plane and add-ons, and understanding what changes do I need to make as I move to a new Kubernetes version. Okay, so let's go ahead and talk about another one of our key topics, which is cost visibility and efficiency. So cost visibility, oh, sorry, I lost let's see, there we go. Oh no, sorry guys. I'm gonna go ahead and see if I can fix my screen sharing here. Okay. Okay, there we go. We're back up and running. Okay, so cost visibility and efficiency. So let's start with cost visibility. So when you're running a Kubernetes cluster, there's a lot of applications. There can be a lot of applications using the cluster. Sometimes people have setups where they're running different namespaces, different parts of the cluster are running different instances. Say you're running a software as a service application. You may have different customers using that software in different namespaces of the cluster. Or maybe you're providing a platform for your different development teams, and you are dividing the cluster up between 5 or 10 different applications for different teams. in all of these cases, you want to understand how much does it cost for me to run Kubernetes overall? And then how much does it cost for me to run each part of the cluster, each application within the cluster? What's the total cost of that application? So for the overall cost, customers had struggled previously to understand which EC2 instances were actually part of their EKS, different EKS clusters. So we introduced automatic EC2 tagging for both managed node groups and for any other instance that's attached to the Kubernetes cluster. And so whether you're using managed node groups or using self-managed nodes or you're using Fargate, you can get automatic full cluster cost visibility inside of Amazon cost and usage reporting. So no matter what compute is associated with that cluster, you can always understand this is the total cost of that EKS cluster. Now, that's the first part, but what about inside of the cluster? How do I break that up between applications? We've partnered with KubeCost to offer a complementary KubeCost cost visibility inside of every EKS cluster. Now, this is something that you have to install yourself through the EKS add-ons, but when you install it, it's free to use, and you get automatic cost visibility for every pod, deployment, namespace, and other objects within the cluster. So if I'm running a development team's application in a unique namespace on my cluster, using KubeCost and EKS, I can understand the cost of each application automatically. And this supports all EC2 purchase options. So if you have things like reserved instances or compute savings plan, you can actually see all of those options directly inside of KubeCost. And this is delivered natively to EKS clusters as part of our add-ons framework. So cost visibility helps customers understand what's going on in the cluster and how much is everything costing. And then the next thing that's super important is how do we actually reduce costs on the cluster? So we have a new open source project called Carpenter that we're extremely excited about. And what Carpenter does is it actually helps you select the most optimal nodes for your cluster based on requirements, availability, and custom preferences. And so Carpenter allows you to add or remove nodes on the cluster in as little as 30 seconds when demand changes, even in the largest Kubernetes clusters. And using Carpenter, we can automatically select the right fit nodes for your applications and change the node selection on the cluster as the needs of those applications change. Now on the roadmap today, Carpenter is a piece of open source software that you can install yourself on any EKS cluster. And on the roadmap, we're working on the ability for you to configure clusters with automatic no-touch compute from the start using the EKS console, EKS APIs, and EKS CTL. So that's what's coming for Carpenter, is we're making it even easier for you to achieve full automatic node provisioning and cost efficiency as part of every EKS cluster from the start. So that's cost efficiency. What about Kubernetes access to the AWS ecosystem? So we have Amazon EKS, and there's a lot of other things, and I think Barry talked a little bit about this morning. There's supporting services, there's infrastructure services, and higher level services. So infrastructure services are things like EC2 and EBS. They support a Kubernetes cluster. We have supporting services which you use alongside your applications. So things like S3, where you're going to use that as part of your application framework. And then we have higher level services like Barry discussed this morning, things like guard duty, which come over the top and actually enhance the Kubernetes cluster from above. So these are the three ways that we think about integrating with the AWS ecosystem. And I want to talk a little bit about supporting services, because one of the biggest investment areas for EKS right now is making sure that if you're running Kubernetes on AWS, you can take full advantage of all the other services within AWS to offload and to support your applications. So the project AWS Controllers for Kubernetes, or ACK, allows you to create and use AWS resources directly from within your Kubernetes cluster. And this helps your applications be more reliable and improves their uptime at any scale. It's fully cloud native, so it's fully done through Kubernetes. It allows you to do things like add S3 buckets or RDS databases or SQS queues alongside your Kubernetes applications without actually leaving Kubernetes. So you don't need to write CloudFormation and map things back. You can directly use Kubernetes to create and manage those resources. And the coolest thing about ACK is that it's always updated with the latest SDKs. So we use the AWS SDK to actually generate these controllers, and they're kept up to date all on a regular basis as soon as those SDKs change. So we have a lot of ACK services. So in the last year, we've launched, I think we've launched at least a dozen or more in the last year. We have a total of 16 that are generally available now. So we have a number that are in preview that you can go and use, including Elasticsearch, EventBridge, and Amazon MQ. And we've also been making a number of these generally available, things like CloudTrail and DynamoDB, EMR, IAM, KMS. These are all services that you can use today, generally available through ACK. So wrap up here and talk about applications in any environment. This is another place where EKS is investing, because we know that customers run a lot on the cloud, but a number of our customers still have quite large installations on premises where they're running Kubernetes. So we have EKS that's running in AWS, and we also have EKS Anywhere that can run on premises. And these are both supported by EKS Distro, which is our open source Kubernetes distribution that lets you create reliable and secure clusters on any, and to run those yourselves. So EKS and EKS Anywhere, both built on EKS Distro. EKS runs in AWS. EKS Anywhere is designed to help you run on premises. And the goal is that we allow customers to deploy, operate, and secure Kubernetes environments no matter where they need to. And so we have a full suite that we've been building from both EKS and EKS Anywhere to allow customers to deploy in the region in a managed edge with local zone wavelengths and outposts. Now at the edge with EKS Anywhere on Snow, and also using EKS Anywhere to deploy self-managed clusters in the data center. So the goal here is that all of this works together, and that you can move applications from any EKS deployment to any other one and create operational consistency across all of your environments. And so this is the summary. These are the things that we're doing: centralized and simplified cluster management, application-ready clusters, giving customers better cost visibility and efficiency, giving customers better access to AWS capabilities, and allowing customers to deploy in any environment, no matter where they need to run Kubernetes. Coming up this afternoon, we have a number of great sessions. Kicking off right now, the next session up, we're going to be talking about Kubernetes threat detection, investigation, and incident response automation. And we really hope that you'll stick with us for the rest of the day. We have a really awesome program to show you. Thank you very much.
Awesome. That was great. Thank you, Nate.
Yeah, thank you, Nate. That was good. I'm especially excited about the announcement that it's going to be easier than ever to upgrade an EKS cluster. I love the idea of one click. I love the idea of the previews and it telling me what's going to break before it actually breaks.
Yeah, that's a big deal.
Yeah, we're
all right.
About that.
So our next session is going to be about let's see, what was it? Threat detection.
Yes.
So keeping your Kubernetes cluster safe, detecting if someone is trying to attack your Kubernetes cluster or run malicious workloads in it. Let's bring in our guest for the next segment.
Yeah, hi everyone. I'm Chance Lee from AWS. Thanks for joining our session. Today I'm with my colleague Sujans, and we are going to talk about how to detect, investigate threats in Kubernetes environment, and how to set up an incident response plan with automated pipeline to properly respond to those events and take actions on them. I will first kick off the sessions with the recent security trends and key threats in Kubernetes environment, how we can prevent those threats, and how we can protect our environment. After the other agenda here, we will demonstrate to show you how you can actually detect threats on Amazon EKS. Based on 2023 Cloud Native Security and Usage Report, the two biggest risks were vulnerabilities and misconfigurations. And this report is based on the data gathered from the billions of containers across thousands of accounts operated over the last year. It indicates that 87% of container images have higher critical vulnerabilities. 15% of high-end critical vulnerabilities are in use at runtime. Because there are just so many vulnerabilities, we need to prioritize which one we are going to proactively monitor and remediate. And critical vulnerability at runtime should be prioritized because it can represent the actual risk to your environment. That's why runtime threat detection usage is increasing. But at the same time, attacks targeting the container supply chains are on the rise. And we should scan images in the CI/CD pipeline where the images are built and pushed prior to your deployment. Because if malicious images are deployed to your host environment, even you have the way to detect those threats, it may be already too late. And privilege escalation is the most often detected tactic. It doesn't mean all the privilege escalation is malicious. However, I wanted to emphasize the attempt to get the host level access is very common threat. Let's also see some of misconfigurations examples. Surprisingly, 90% of granted permissions are not used, and over 98% of permissions granted to non-human identities like Kubernetes service account have not been used for over 90 days. So if you have a lot of clusters, if you have a lot of workloads, it's very hard to track and audit all the identities. And 83% of containers run as root, and 56% of images are pulled from public repositories. We should not assume any images you are pulling from public repositories are safe. We need to make sure scanning them before we deploy them to your host environment. And 46% of base images are well-based, while light-weighted images like Alpine is only 16%. Generally, slimmed-down base images can significantly reduce the attack surface. Now, let's see how we can prevent those threats. As we just saw, there are a lot of permissions granted, but not being actively used in many environments. We really need to limit who and what you grant access to. And we need to have a central place where we can audit all the identities which access your clusters. And we need to automate expiring and rotating credentials to minimize the blast radius. And you can also configure EKS cluster endpoint, which expose the EKS API server to be private. And by directly mapping that IAM role to Kubernetes service account, you can directly assign that IAM AWS identities to the pods instead of inheriting that identities from the worker node. The worker nodes and pod need to have different permission sets. And by blocking access to Amazon EC2 metadata from the pod, when the attackers gain access to pod, you can also reduce the blast radius. And with Kubernetes RBAC, you can control which user or role can access to which resource, what API calls they can make under a specific namespace. With network policy, you can control east-west traffic between applications, between services within the cluster. And by using a separate service account for each application, you can easily audit each application, and you can also set up a fine-grained access per each application. And when you create a pod without defining a service account, the pod will mount the default service account. And when the default service account has admin access, then it can be a very risky scenario. In order to practice your privilege escalations, first you need to identify the key actors and capabilities given to them. Let's actually see some examples. You may have developers who are the main actors who need to access to your container supply chain. They may need to access your repository to push their code. And when you have a lot of developers, you need to make sure which developer can push the code to which repository to make sure attackers cannot inject their malicious code into your repository. Once the code are pushed, then the build system which is the part of your CI/CD pipeline, will build that image and try to push that image to the image repository service, for example, ECR. And you can make sure the build system is authenticated with ECR to make sure they can push the code to ECR repo. And from the ECR repo, you can also control who can access to a certain repository, also to make sure the other attackers cannot inject the images. And once you build the image, and the CD process will try to continuously deploy the images to your EKS, the Kubernetes environment, the data plane host environment, then the CD process also needs to be authenticated to deploy the container to the host level. And you may have platform engineers who also need to access your API server to run kubectl commands for their daily jobs. And they also need to be authenticated to access to a certain Kubernetes API server. Let's also look at some of the other examples from the data plane. You may have the external users who could be your customers, who could be your internal customers who need to access your application. And you can expose your application through publicly through public-facing load balancer like ALB. And some of your applications in pod may need to access to other downstream AWS services, for example, RDS, S3, or CloudWatch. By assigning the IAM role to the service account to each application that I recommended in the previous section, you can control which pod can talk to which service. You can also further control down which resource they can access from each service. And also you can control what API calls they can make. And when you have a logging daemon set, some of your pods may need to have access to a certain path at the host level to aggregate those logs. And you may also have applications, they need to talk to each other within the same cluster. You can set up the ingress and egress of those services through a network policy. We also recommend to practice defense in depth to address different attack vectors. And we have a set of best practices to address all of those layers in this link. And we're going to share this link. But today I'm not going to cover all of those layers through the session, but I highly recommend to review the link that provides a set of best practices. And no matter how securely you protect your environment, you still need to have a way to detect threats in your Kubernetes environment. And instead of you manually reviewing all the logs to find out these malicious attempts, you may consider using some of managed services that can automatically detect threats. And GuardDuty, for example, use multiple data sources to provide EKS protection. It can capture access API through a CloudTrail to your API server. It can search, it can automatically detect threats from your audit logs of your Kubernetes control plane. And also it can support malware protection for your data nodes and also support container runtime protection. And VPC flow logs, DNF logs will be also kept supported to provide defense in depth. Let's first quickly review what GuardDuty can do with Kubernetes audit logs. Audit logs captures all the API calls against the API server of the Kubernetes. So it's important to have the view, have the insights on what's happening on your cluster through the audit logs. And GuardDuty can immediately begins to analyze them and monitor those activities. And that aligns 27 findings using the MITRE ATT&CK framework. Here are some examples. It can be like admin access to different service account, or it can be malicious access from certain IP, or it can be suspicious behavior like privileged container. And we also have a link that provides all the details of those findings. Runtime monitoring is a new feature we added last month. It provides additional container level context. It provides visibility into runtime activities such as file access, process execution, and network connections. When we see the example here, when there is a crypto mining related findings, which was detected by the VPC flow logs. It can provide the list of EC2 instances that are related with this finding, but it doesn't know the container context. But with runtime monitoring finding, you can see more entities, container-related contexts that are related with this finding. And we do have an actual demo to show you after this session. I also wanted to quickly introduce Detective, which is another managed service that helps you identify the root cause of the issues. By correlating those entities together, it provides a unified view of the interactions among those entities. For example, you can have the view of which user is associated, is involved with a certain finding, what IP address was used by the user, what IAM role are assumed by the user, and what other findings are associated with that IAM role, for example. And we also have a demo that will go deeper into this scenario. Now let's look at our incident response plan. It is really essential to continuously practice responding to those events before your service gets breached. We first need to set escalation chains, identifying people and process with required permission in advance before the event happens. And we need to define key events. Because there are so many events, we need to first identify which events we want to proactively monitor and want to be notified. And you need to have a reliable alerting system that can alert the right people. And because it's hard for you to detect all those threats at scale across a lot of clusters, you may consider using a managed service that can automatically identify threats. The next stage is to isolate the threats. You first need to make sure reducing the blast radius. One thing maybe we can do on the worker nodes that are affected would be coordinating those worker nodes to make sure no additional pods can be scheduled there. Maybe you can attach a denial network policy to pods so the pod cannot talk to other pods. We can also evaluate the credentials that are given to the worker node and pods. And we can also use security groups to isolate the node and pod for the south and north traffic outside of the cluster. And before terminating those resources, you may want to capture the evidence for future post-mortem. For that, you may need to capture volatile artifacts, and you may need to run Docker log-related scripts so you can additionally get the information and export those logs outside of the resource. The next part is to recover your service as quickly as possible to minimize the business impact. We recommend to use Git as a single source of truth to resynchronize the desired state from the Git instead of making a direct changes to your cluster. And you may consider using infrastructure as a code service you prefer to easily recurate your infrastructure. And when you have a persistent volume stateful set applications, you may also consider using some of backup and restore tools from Kubernetes. And we should practice documenting all the contributing root causes to make sure it doesn't happen again. And we should consider which part we can automate, which process we can automate. And for that, I prepared event bridge part, which is a serverless event bridge service that you can route event from multiple data sources. It can be AWS services or it can be SaaS applications as well. And you can route that event to event bus. And you can set up the rules to filter which events you want to route to the final destinations. And there are a lot of supported destinations here as well. One of the examples I wanted to share was the pipeline to receive notification automatically. EventBridge supports guard duty as a source, and by defining those guard duty related events through the EventBridge rules, EventBridge can capture those events, and whenever this listed event happens, then it can route that events to the destination you set up. And when you set up SNS as the destination, then depending on what subscribes your SNS, you can do a lot of follow-up actions. For example, sending an email to the right people who need to be notified for that specific event. And you can also send SMS, text messages, or you can send Slack because SNS support HTTPS also as the subscriber. Or you can send those events to queues to asynchronously process those events for like post-analysis later on. Or you can also trigger Lambda functions to automatically remediate some of the findings, depending on what finding it is. I will pass over to Sujans to actually show you how it works, how you can detect threats, and how you can investigate the root cause. Thank you so much.
Right. Thank you, Jens. Hey, everyone. My name is Sushant Mangalore. And so far today, you have seen all the different tactics that attackers can use to perform malicious activities inside your cluster. So now let's take a look at an example threat detection scenario on Amazon EKS. So I'm working here with an Amazon EKS cluster that I've pre-built, and it's running Kubernetes 125. And as you're aware that any activities that happen against your Kubernetes API server can be tracked by the cluster audit logs. But if you're in a situation where you have to quickly investigate some suspicious activity inside your cluster, you won't always have the luxury of looking at thousands of lines of logs to determine what happened. Time is of the essence, and you want to get to the root cause as soon as possible. So for that purpose, I am employing Guard Duty here. And Guard Duty offers EKS protection in two flavors, as Chance just mentioned. So we have the audit log monitoring, which looks at the audit logs of your cluster and reports any suspicious findings observed there. And we have the EKS runtime monitoring, which looks at runtime events inside your pods and hosts and reports any findings coming out of there. So the runtime monitoring makes use of an agent, and you can choose to manage this agent automatically. When you do that, any EKS cluster that you create inside your AWS account automatically gets the agent installed as a managed add-on, which makes it easy for updates and management. So I can show you here that this cluster already has coverage from the add-on. So this is protected by the runtime protection. So with all of this set up in place, let me switch over to the findings view. And as you can see here, I have a few findings here already, and these are all related to EKS. Now, normally you want to see this screen nice and clean with no findings. That means you're having a good day. But because this is a demonstration, I've created these synthetically for the purposes of our investigation. So let me click on one of these, and this is coming out of your API logs monitoring, or rather the cluster audit log monitoring. So here it suggests that system anonymous user was granted API permissions. Now, normally you wouldn't want your system anonymous user to have any API permissions because that means the user is allowed to bypass authentication from the Kubernetes API server. And it's rightly being reported as a high severity finding. So we need to investigate what's going on. And you get information here about the region where this occurred, the AWS account, the affected EKS cluster. What's interesting to me here is that this occurred, the subject involved here is a service account in the default namespace by the name admin. Now I know that I'm not really running any workloads with the admin service account, so it's possible that some kind of a malicious activity is occurring inside my cluster. I scroll down further and I see here that an API call was made, which is creating a cluster role binding. And if I expand the parameters here, I see that the system anonymous user was bound to the cluster role cluster admin. Now, the cluster admin role is the most permissive or a super user role inside your cluster, and you always want to be really careful about who you give this access to. Much less, you should never ever give this to the system anonymous user. So obviously, this is a situation where the attacker has been able to bind this role to the system anonymous user, and they're now an admin on the cluster, and they don't even have to authenticate to the API server. And this issue first occurred 14 days ago, so I've given the attacker quite a bit of a head start already. But I have information about their IP address and where they came from. So now it's up to me to determine what happened and take some remedial actions. Now I can take a remedial action at this point. So I can maybe apply network policies and some of the other things that Chance had mentioned as remedial actions. But until I get to the root cause, I can't be sure that this will not occur again. So if the attacker was able to do this once, they can possibly do this again. So in order to determine the root cause, I'm going to switch over to Amazon Detective. And Amazon Detective allows you to work backwards from guard duty findings and look at the entities involved in a particular finding to trace their actions and see how the finding may have manifested. So since I'm only dealing with one cluster here, let me jump into this. And once you land inside this page, you are going to see the different containers and pods running inside your cluster. And I recognize most of these. These are kube system pods. I see the guard duty agent for the runtime protection. Plus, I see this workload, which is an Nginx-based image that I'm running inside my cluster, and it's running in the default namespace. Now, I know that the service account in the default namespace was used in order to create the cluster role binding. So possibly there is something here which is related to this Nginx pod, but I can't be sure yet until I find out more details. And because the finding occurred 14 days ago, I need to change my view here to look back to a larger time frame. And now I see that finding, and I can start to work backwards from this. So jumping into this, I see here that these are the different entities that detective identified as being involved in this finding. So I get information here about the IP address, the AWS account, the cluster name, and the subject who was involved in the attack. Since I already know about this subject, what I'm interested in is what else the attacker may have done using this IP address. So I'm going to bring up the profile for this IP address to see what else I can find here. And I'm going to focus on the Kubernetes activity because I want to see what are some of the other API calls that may have been made using this IP address. So if I expand here, I know that my Nginx part is running with the reader account, rather reader service account. So first, let me see what are some of the API calls made with the reader permissions. So I see here that a list and a get call was made using the reader permissions. So looking at this in detail, I see that using the list call, first they were able to list the secrets from the default namespace. And in the subsequent get call, they were able to actually look at the token associated with the admin secret, which maps to my admin service account. So it's becoming clear to me what has happened now. This is no longer the official Nginx image. This is a malicious image that the attacker was able to inject into my environment, possibly by compromising my container supply chain. So this is an example of where the container, the Nginx image or the image container image was compromised, and now it's doing whatever the attacker wants it to do. And once they get the access to the admin secret token, they were able to impersonate admin and create the cluster role binding. Amazon Detective allows you to look at the breadcrumbs and trace the steps back to determine what may have caused this. Another thing to keep in mind here is that you just because your reader access, your Nginx pod needs reader access, doesn't mean that it should be able to read secrets and secret tokens. So maybe there's an opportunity to tighten down the screws on the RBAC policy for the service account as well. All right, so we were able to determine the root cause. So now we can go ahead and apply all the remediations. But we also need to find out what else the attacker has been up to here. So going back to my guard duty screen, I see here that there are a few runtime findings as well. So let's look at a couple of these. So the first one I see here is suggesting that the runc binary was modified from inside the container. Now, the runc binary is the lower level container runtime. It's used for creating containers, and it always runs with root privileges. So if somebody has access to this process, or if they're able to modify this, they can try to gain access to your host operating system. So now the attacker is already the administrator to your Kubernetes cluster. They're also trying to gain access to the host. Uh, some of the other information that's interesting here that comes with the runtime finding, you get information about the container runtime. You know here that the Nginx pod was used. So the image that they were able to compromise, they were able to piggyback on that. And now they're trying to take some control of your host as well. There's network related information. But what's most interesting to me here is this process lineage that is shown here. which shows that the shell process modified the runC binary. And I can look at the process lineage at multiple levels, that the shell process was spawned from the containerd shim, which is the parent process for a running container. And this was spawned from the systemd. So this can again be useful to trace the steps back to what the attacker may have done. All right. One other finding that I see here is that a new binary was executed. And this is showing me that a binary by the name cnrig was executed. And this was downloaded using the wget package. And the cnrig is the binary that was executed. So cnrig, if you do a quick internet search, you'll find that this is a very popular crypto mining software. So when you have a Kubernetes cluster and some infrastructure at your disposal, why not mine some crypto? So that's what the attacker has been up to. All right, so we have about 14 days that have passed since the attacker was first able to do all this, but you don't always want to be this late in finding out what has happened inside your cluster. You want to be able to find out about these things as soon as they happen. So just having something like guard duty in place is not sufficient. You also need to have a proper notification in place so that you are able to find out about these things as they happen. So as Chance mentioned, Amazon Event Bridge allows you to be notified about these kind of findings immediately. So let me switch over now to Amazon Event Bridge. And I can create a rule here. And I'm going to supply a name here. I'm going to call it guard duty rule. And in the next page, I can select the AWS service that I want to receive the event from. So I'm going to say that I want to receive events from guard duty, and I want to receive events for guard duty findings. This is going to match all guard duty findings, irrespective of whether they are EKS related or not. But if you want to only focus on EKS related findings, you can further add patterns here, which will filter the event down to only the EKS findings. But I'll keep things simple here and just look at all guard duty findings. And on the next page, I can select the AWS service that I want to target with this event. So I can choose to invoke a Lambda function, which can take some remedial actions for me. Or like Chance mentioned, I can set it to an SNS topic, which sends an email out to a distribution list, which my SRE team or my security team is monitoring. Cool. So that brings to the end my demonstration here. And I hope you found this information useful and you'll take the necessary steps in order to have threat detection and incident response set up on your cluster. Remember that the attacker only needs to be right once, but you need to be right all the time. So you need to ensure that you have security set up in depth and all the necessary monitoring in place. Thanks everybody for attending today.
Awesome. Great demo. Thank you so much. What'd you think of that one, Nathan?
I liked it. I like that idea of attacker only has to be right once, so better be on top of things. And it looked like there's a lot of visibility. There's a lot of auditability built in. I can audit everything that goes on. And that's exactly what I want to see in terms of security, posture, and features built into my runtime platform.
Mm-hmm.
Yeah, like just seeing where something got downloaded from and having that whole like chain of events just played out for me is amazing.
Mm-hmm.
Thank you very much for showing that to us today.
Yep. Thank you.
Awesome. All right. So next up, we are talking about OpenTelemetry, right?
Yeah. Another way to have visibility into what's going in your cluster. Generally, I think OpenTelemetry is less focused on the security side of things, but more how is my application doing?
Mm-hmm.
Is my application performing well? So we're going to see another way to inspect what's going on inside the cluster. Let's bring up our guests here. All right. And who's going to be presenting first? Is that you?
Yeah, that'll be me, Maya.
Okay. All right. Got you. All right. There we go. Why don't you all introduce yourselves and take it away?
All right, thank you, Nathan. Hello, everyone. My name is Imay Kumar Jagannathan. I'm a Principal Solution Architect at AWS, and with me I have Rodrigue.
Yeah. Hi, everyone. My name is Rodrigue. I'm a Specialist Solutions Architect, also focusing on observability.
All right. So our session is operating OpenTelemetry collector for scale and resiliency in container environments. Thanks everyone for joining our session today. That's our agenda. And after we cover the topics listed in the agenda at the end of the session, we'll show you a really interesting demo of one of our new projects that we've been working on that we launched a few months ago. It's called AWS Observability Accelerator. To get there, let's talk about some of the basic things. We'll level set on what OpenTelemetry itself is. OpenTelemetry is the second most popular CNCF project that's out there, and it aims to solve the problem of having too many agents and having vendor-specific agents used by our customers. And what it does is it sets standards on signal specification, the data model. It provides SDKs in different programming languages to collect your signals from all those different environments, and also provides a single binary that you can use to collect those signals that you're collecting from your environments and send them to any destination you want with just a simple configuration change. With this, you don't have to rely on a specific vendor-specific SDK and then spend a lot of time moving to another vendor if you're moving your observability tools and so on. This is the AWS distro for OpenTelemetry. So what is AWS distro for OpenTelemetry? It is basically a redistribution of the OpenTelemetry collector. So every single line of code that we write upstream goes to the upstream OpenTelemetry contrib repo or to the project. And from there on, AWS builds an OpenTelemetry collector, including the components that our customers are asking for and that we think are stable enough to support our customers' needs. And also the code base goes through our security review process and also the other testing process. So you can be sure of the collector doing exactly what it is expecting, what you expect it to do. And also customers using the AWS distro for OpenTelemetry collector, or in short, ADOT collector, can also raise AWS support tickets if they have any issues, or reach out to solution architects like us to design their telemetry collection or the signal collection environment. All right, so there are multiple deployment options that you can use to deploy the OpenTelemetry collector in your environment. So for the first one is obviously no collector at all. So there's literally no collector that you're using, and we'll see that in detail. The second one is the agent mode, or the distribution mode, or the distributed architecture. And the third one is the gateway, or the centralized architecture. In the no collector option, as you can see here, you have the application code, which is instrumented using the OpenTelemetry SDK, and you're sending your signals directly to the OpenTelemetry compatible destination. So with this, your application is directly responsible for sending the signals, such as metrics and traces and so on, to whatever destination that you want to send it to. It could be any of the OpenTelemetry compatible destinations that you can imagine. Here, the responsibility of collecting the signals about the application itself, or monitoring, the application is essentially doing a lot of work. It is, you're not separating concerns. So here the application is responsible, or the same process is responsible for batching, retrying, and so on, which is really not the most ideal situation that you want to be in. The agent mode, or the decentralized fashion, you're basically sending the data that you're collecting about the application to another process locally. In this case, it is the OpenTelemetry collector. And the collector is then responsible for sending those signals or the data to any destination that you configure or ask it to send it to. In this architecture diagram that you're seeing here, your application code is instrumented using the OpenTelemetry SDK. And it is sending traces locally on port 4318 to the ADOT collector, and the collector is then responsible for converting that to X-ray compatible format and sending that to X-ray service. And that will take care of, so with this, essentially you're separating the concerns. The collector will take care of sending the data to the X-ray, where the application is only focusing on doing its business logic that it's supposed to do. And here's the gateway, or the centralized mode. It's slightly different from the decentralized mode, as you can see here, where the collector that is actually receiving the metrics or traces from the application itself is not directly sending that to the destination, whereas it is sending the data to another collector in between, and then the collector, the central collector or the gateway collector, if you want to call it that way, is responsible for sending those signals to the centralized or to the destination, which is the X-ray here. So the advantage that you can see here is that you can have much more control over what data is being sent. And if you want to have any kind of security audit that you want to do in that central environment that you want to do, that it's a little bit easier to do rather than having to do that configuration in every single collector that is deployed in the workload environment. Now let's take a look at all the deployment architectures that you can use in Kubernetes and how you can collect signals from using the OpenTelemetry collector in a Kubernetes environment. To be honest, it actually applies to any environment, but in this architecture diagrams and all the terminologies, we'll primarily be using Kubernetes here. One option that you can use is obviously deploying the collector as a daemon set, and the daemon set, there will be multiple copies. There will be one node, there will be one copy per node, one copy of the collector per node in your EKS cluster if you take it. And these things apply even if you run the collector as a sidecar as well. So essentially, your collector is scraping, let's say you're collecting Prometheus metrics, your collector is scraping Prometheus metrics from the local host or the same node that it's running on, if it's running as a daemon set. So here, the advantage here is that the scaling is really simple. So you're simply distributing the node across all the, distributing the collector across all the nodes in the EKS cluster, and you're really not, you don't have to really worry about scaling down because it scales evenly, right? And also it could be easy for log support when OpenTelemetry gets log support in the future. The disadvantages here could be that there are too many copies of AR collector that could be in use. So you may be deploying more collectors than you actually need, and also the size of the collector that you're deploying and the sense of memory and CPU that are allocated to the collector is going to be to the maximum that you have seen in the workload. So if you see that if a particular node is densely populated and that's lots of pods in there, and if you're not carefully designing, you will end up sizing your OpenTelemetry collector pod to that CPU and memory, and that will end up being the copy of the collector that deploy all the nodes, where you actually may not actually need that much resource, that much capacity for the collector. So there will be disproportionate resource allocation as well. And configuring high availability can be a challenge here because you're relying on the pod that is running in the node in the form of a daemon set to collect the data from the same node. If the daemon set has any issues, if it is crashing or anything that happens, then you would have issues in knowing what is happening in that node. So there is no other party that is also collecting the data. So you're basically running without visibility into that particular node. So that could be one of the challenges there. The other architecture option that you have is running the OpenTelemetry collector as a deployment. So you can run multiple copies with this, multiple replicas with this, obviously. So it's much more advantageous. And here you have a single collector or more than one collector if you have multiple copies, multiple replicas, and they are responsible for scraping the metrics from different targets and receiving traces from different targets and so on, and sending them to the destination that you are configured them to send to. The advantage here is that the resource utilization is a bit more optimized compared to the daemon set or the sidecar approach. And scaling is also a little bit easier, so you can simply increase the number of replicas and you can automatically scale. And with that, you're also, like I mentioned before, the resource utilization is better because you are going to understand how much resources needed for the entire cluster, and you're only going to allocate that level of CPU and memory. So you're not over allocating and the CPU and memory being unutilized and so on. high availability is easier to set up as well. Take an example of a managed Prometheus service where you simply have to deploy multiple replicas of the collector, and you can add a common label called cluster and some unique label, and then unique label called replica, and the Prometheus service will automatically do a leader election and only accept metrics from a particular collector, right? So so setting up high availability like that is a lot easier here. And the challenge here could be load sharing setup. So when you have a deployment, unless you're more sophisticated, if you do unless you're more sophisticated, you might end up having a really large replica that is scraping a lot of targets. And if you want to distribute it, then you have to go with much more complex focused target scraping job configurations for different deployments that you want to deploy. So it can end up in a complicated situation depending on the workloads, the type of the workload, or the size of the cluster itself. Then you have the gateway or the centralized architecture. So here you can have your workloads where your OpenTelemetry collector is deployed, and we're just collecting all the signals from the workload itself and sending all the data to a centralized collector location. And from there, you're sending the data to the target. In this diagram that you're seeing, the collectors are scraping metrics from EKS, ECS, EC2, whatever environment, and they're sending all the data, all the metrics to a central EKS cluster, which has all the data collector deployed in the central location behind a load balancer. And that is in turn sending the data to the managed Prometheus service. Here, the advantage here is that one obvious advantage is that you can take decisions decision centrally. So you can swap out the destination anytime you want, and you don't have to worry about talking to or changing the configuration of the workload collectors, which are there deployed in different environments or anything. So they are only continuing to send the data to the central collector, and you can change the target anytime you want. You can upgrade because you're sitting behind a load balancer. You can upgrade the collectors anytime you want, and you can still have the data continuously being sent. And another big advantage is that you can operate the ADOT collector, the central one, on virtually any flexible environment. You're not forced to run the collector in the same environment that your workload itself is running on. So it can actually, it's quite decoupled from that situation. And the disadvantage here could be is that because there is this one central environment where you're running all the collectors, it is really, it could potentially cause a single point of failure. And you want to ensure that you have multiple copies running, you have load balance, and also you have authentication and security is tightened as well. So you don't want to end up in a situation where this ends up becoming a bottleneck for the metrics or signal collection process. Now we saw all the architecture patterns and deployment options that you can use. Now in the next section, we're going to look at all the different things that you can do to monitor and scale the OpenTelemetry collector. First, you want to monitor your collector by collecting metrics from itself. So the ADOT collector, the OpenTelemetry collector, actually exposes metrics about itself, and in the at the metrics endpoint, and you simply have to enable the telemetry in the service pipeline. And once you enable it, it by default exposes in port 8888. You will start seeing metrics about if you have a metrics pipeline configured, if you have a traces pipeline configured, you will start seeing metrics popping up in Prometheus exposition format for the pipeline that actually matters. So if you have metrics pipeline, then you will see a number of metrics, samples process, metrics sent, and so on. And you can also look at the logs that the OpenTelemetry collector will write into the environment as well, so they can debug and find out what is actually going on. If there is any, if there are any throttling issues on the destination, or if there is any out of order samples that are not being processed, and so on. All those details can be observed in the log files. Then the ADOT collector also has a health check endpoint that is a live in other words, liveness probe. You can simply enable that under the extensions. There is a health check option, and it is by default 13133. And it simply, when you hit that endpoint, it will simply return a 200 OK. And you can, with that, you can expect the, you can understand that the OpenTelemetry collector is actually live and healthy. You can use that endpoint to configure load balancer, traffic routing, for example. Then when you're operating at a large scale, you really want to set limits to prevent catastrophic failures. When we see customers get very excited and start using this architecture, sometimes it is normal to assume that your resources can be resources are infinite, but that's really not the case. If resources are finite in any environment or limited, so you want to ensure that that is kept in mind when you're designing the architecture. So don't expect the data collector to scale infinitely and handle any amount of load. So you want to make sure that you're gating the collector from being attacked by an unintended NLOps service attack, right? So you need to devise a target allow list policy, for example, if you're collecting Prometheus metrics, and only make the target sign up to be included in the metric collection process. You can also set limits in Prometheus environments. For example, you can limit the total body size of the scrape. So your OpenTelemetry collector is not ending up scraping way too much data and not being able to process on a very frequent basis. And you can set a limit on the number of labels to accept. So your application teams that are creating custom labels, custom metrics, are aware of how many labels that they can add, and that also brings discipline in the whole pipeline. Will allow you to stay out of extreme high cardinality situations and so on. And you can also limit the number of targets that it can scrape at any given point, and also total number of samples to accept in a single scrape. There are a lot of flexible options that you can look at. The Prometheus scrape configuration, we encourage customers to make use of those to prevent the collector from failing altogether. Then you can also set limits to prevent the memory from being the collector from getting exhausted because of lack of memory. The memory limiter processor allows you to do that. That allows you to limit how much memory the processor pipeline can use. And this should always be a little bit less than the total allocated memory in the pod. So to allow the collector to also do non-processor related activities such as scraping metrics or doing the exporter activities and so on, and also exposing its own health metrics and so on. So you want to make sure that this is configured so memory is not a concern. One that you want to be aware of, another one that you want to be aware of is the back pressure management. So it is easy to assume that, yeah, I have a gateway collector or the centralized collector, so now I can do all the processor tasks here. That is really that can theoretically work, but when you actually start to use, that can actually turn into a bottleneck. So you don't want to do all the processing in one location. You want to actually evenly distribute. So anything that you can process then and there when you're collecting the metrics in the workload environment, do it there so your workload is actually distributed. So something that is central, such as redacting private information or maybe filtering some specific data, or transforming, doing additional transformation after the initial transformation is done, those kind of things can be done in the central location. So ensure that you come up with a strategy where you can distribute the load across different layers of the collector. The OpenTelemetry collector also supports the OpAmp protocol, or the Open Agent Management Protocol. This protocol allows you to operate a OpenTelemetry collector as a controller of multiple collectors in a data plane. So when you do that, the control plane collector becomes acts as a server, and all the other clients, all the collectors act as a client. But the server can, in this case, manage the clients in terms of updating the configuration and upgrading the collector itself and so on. So that becomes really, or in other words, that gives you some more control flexibilities for you on how you want to operate the collector itself in a real world scenario. Having said that, I'm going to now switch to the AWS Observability Accelerator, and I'll let Rodrigo talk all about it.
Yes, thank you, Maya. So we built the Observability Accelerator to make use of the OpenTelemetry operator, the AWS distro for OpenTelemetry. So I went ahead and I cloned the project already. So if I go we have a couple of examples. I will start with that, and then we'll explain what it is. Right. So I will start with a Terraform apply. So basically, that's the step that you would do. We have a couple of examples that put everything together. And then this example will deploy observability with the AWS distro for OpenTelemetry, collect metrics, and provide dashboards. So here we'll see if we go back on our documentation site. So we have a documentation site here that explains the project, all the data that it is collecting and what you will get out of it. We have a couple of examples, like in the EKS side. So you can see the infrastructure monitoring. So here, for example, you will have all the steps to use the project and with an existing cluster, and then you can decide to create a new Amazon Managed Service or Prometheus workspace to collect Prometheus metrics, and then run the project, providing your API key. So you have all the steps documented here. So going back to this, so Terraform wants to create 57 resources for me. So I'm gonna say yes. We're not going to wait for all of that, but rather I have another environment where everything is already created. So at the end of the Terraform apply, you should have this output. So you will have a manage Prometheus workspace. So this is a container for Prometheus metrics. So you will have that created. You will have you will provide a managed Grafana workspace as well. We have examples how you can deploy Grafana from end to end, and you have a couple of dashboards here. So let's go and see the cluster dashboard. So this is one of the dashboard that we propose. So here I'm logged into manage Grafana workspace I have created for this project. So here you can see in the cluster, you can see cluster headlines, for example, the CPU, memory. So you will have data based on metrics, Prometheus metrics. For the CPU usage, you see the CPU code as per namespace. You can see, for example, in the Kube system, I have like 14 pods and workloads. You can have this information for memory, CPU. You have information on the network as well. So you have the visibility on the received bandwidth, transmitted bandwidth, and then you will get also configured alerts based on that. But first of all, let's jump into one of the namespaces. So I can drill down into a namespace. I can see all the CPU, memory, disk metrics for that. But if I can also drill down into the pods in there, so I can see individually all the pods that are running here. So I have an application. I've been trying to kill it. It's in Rust, but it's impossible to load the CPU. So it's like so I can see in detail, like there is one pod that is actually taking all the traffic and it's not even moving so much. So you can see all of those data. You can have the memory impact. You can see the impact of each pod here. And then all of that, you have that per cluster. So if you have multiple clusters, you can also visualize it for different clusters. So here you also have like bandwidth and all the networking information for that. So also what you will have is alerts. So we will create alerting rules for you based on Prometheus Alert Manager with Amazon Managed Service for Prometheus. So you will get all the alerts pre-configured for you. So you just have to route them to the destinations. If we go back to the dashboard, you will see you will see as well, like in the folder, we have several dashboards that are here. You can have visibility on the nodes as well. So this is a dashboard that will give you what is happening on the nodes of the EKS cluster. So you get the load average, CPU usage, memory, disk, all the important metrics you should look at. We have as well a kubelet-based dashboard, so you can see all the operations running on the cluster. So this is pretty detailed. Those information come from Amazon Managed Service with Prometheus. As part of the project, we also propose logs collection, so you can view the logs. So we collect logs with Fluentbit until we can do that with ADOT, but you get the logs into CloudWatch logs. So if I go into the Explorer dashboard view and then select CloudWatch, so let me pick up the correct region and then select CloudWatch logs. I can select one of I would take the logs of the collector, like a.collector Prometheus. So you get the logs in the log groups. So you get the EKS cluster and the namespace. So you will have one log group per namespace. And if I type this query, so essentially what I'm doing here, I will parse the a.collector logs to visualize the metrics that have been sent to manage Prometheus, and then I will graph it with CloudWatch logs inside. So if I do that, you can actually view the performance of the collector. So let me reduce the time frame here. So you can see on the logs all the metrics that have been collected and then the variation. So this is something you can add, for example, in a dashboard, and then to monitor the collector itself. All right, so I'm gonna stop here. And the project is open source, is online, and then we have all of those examples documented. I invite you to test it, and then communicate with us on the issue side or open feature for requests. Thank you.
Awesome. Good stuff.
Nice.
So
I remember when I first adopted OpenTelemetry, I was like, wow, now I don't have to run multiple agents. I don't have to run an agent for Datadog, an agent for Amazon CloudWatch, and an agent for this and that, and all these different tools. I can have one agent to rule them all. And it was a game changer for me.
Yeah, which, speaking of game changers, up next we have a session about eBPF, which, if you're familiar with OpenTelemetry and eBPF, they kind of go well together. It's kind of like a 1-2 punch for your telemetry and observability needs. So next up we have Janth and Squad to demo and show us all things eBPF. So please, y'all introduce yourselves and have at it.
Can you please add approve too?
Yeah, I'm bringing them in right now.
Thank you.
All right.
And I'm bringing up your slide deck there. All right, take it away.
Hello, everyone. I'm Approve. I'm joined by Giant. We are both part of EKS networking team. Our talk today is centered around the need to have real-time visibility into your compute and network infrastructure layers and how we can leverage eBPF for that particular use case. Before we transition to the observability part of the talk, let's look into some of the key considerations one needs to take into account with respect to compute and network infrastructure layers to build a secure and a reliable containerized application. So networking stack that enables reliable connectivity between the workloads running in your cluster and any external endpoints is paramount for your application's performance and reliability. And once you have that base networking stack, we need to have the ability to create a network isolation boundary, essentially configure a set of rules that allows who can talk to whom within your cluster, and pods that are running in your cluster with a set of external endpoints, right? And we'll touch on how EKS is working on to provide some native solutions that can help you configure your network isolation boundary around your applications running on an EKS cluster. And once we have this in place, we need the capability to monitor and gain real-time insights into both your compute layer and network layer in addition to your application stack, so that we can be proactive and act on that. And we'll talk about how we can leverage eBPF to gather the required telemetry insights. Right. So if you worked with any EKS cluster before, you know that it comes pre-packaged with a default CNI plugin called VPC CNI. When you install an application on your cluster, it's obviously not operating in silo. You would need network connectivity for that particular application or pod, and this is where CNI comes into play, right? CNI is responsible for setting up pod networking stack for your application. And unlike generic overlay-based plugins, VPC CNI natively integrates your pod into VPC networking stack, right? What do we mean by that? So a pod that is running on EKS cluster with VPC CNI, the CNI plugin, will get an IP from the VPC cyberspace, and that essentially makes your pod as a VPC endpoint or a resource, right? And that's hugely advantageous, especially if you're trying to interact with other VPC endpoints, and you don't need a NAT layer, and that's a big cost and operational advantage for customers. And the fact that it is natively integrated into VPC networking stack allows you to use the default VPC tool. For example, you can use a VPC reachability analyzer to debug pod connectivity within your cluster. In addition to providing the basic networking stack for your pod, CNI also supports a feature called security groups per pod, which allows you to add a unique security group per pod. And we use EC2's branch and trunk ANI functionality to support this natively within VPC CNI. It's an open source project. It is on GitHub. The link is shared at the bottom of the slide. Now, we just talked about the importance of having the option to create a network isolation boundary around your application and what VPC CNI currently supports with SGPP. While SGPP allows you to, or is very helpful to control the access between your pod running on your cluster and an AWS resource, it can get a bit cumbersome and complicated to use it for east-west traffic, which is in-cluster traffic, because pod IPs are ephemeral. As the pods scale up and down, we need another layer to keep these SGs updated, right? And that makes it complicated to use SGPP feature for creating network isolation boundary for your in-cluster traffic, right? So this is where network policy comes in, and Kubernetes by default comes up with a network policy resource that allows a user to specify the ingress and egress policies for your particular application. However, it doesn't ship with a default network policy plugin. And it's up to the user to bring either their own custom plugin or any third party that's out there, right? So we at EKS have been trying to integrate or bring in this default network policy functionality into VPC CNI. And there are multiple modes in which a policy can be enforced at a node level, and with IP tables and eBPF are two the most common approaches. With IP tables, you create an IP table rule, and the IP table rules will control the network flows into and out of the pod. And eBPF allows you to hook an eBPF program and use it for network filtering, right? And we decided to take the eBPF approach for the native solution. And while there are clear technical advantages with eBPF, customer feedback played a critical role in us taking the eBPF path. Right? What exactly is eBPF? Right? So eBPF essentially is a Linux kernel technology that allows you to run sandboxed applications at various subpoints in the kernel without having to actually recompile the kernel, or even or load a kernel module for that matter, right? So, and this ability allows us to dynamically extend the kernel functionality at runtime in a safe and efficient manner, without actually with actually a very minimal overhead to kernel's native performance and latency. It was originally, as the name implies, it was originally meant for filtering network traffic, but the fact that we can attach a custom hook or a custom program to various kernel hook points allows us to capture system call events, for example, and we'll show you during the later part of the talk on how we can use that to gain insights into the compute layer and the network infrastructure layers. A quick overview of end-to-end flow on how eBPF flows right from where you program and how it operates. So you to start with, you write a sample BPF program, has to be in C. You compile it, and our end goal is to load it and attach it to a particular kernel function, which based on your use case, right? And we have to be careful here, mainly because if the code is buggy, it can actually bring down the entire system because your program is now residing inside the kernel, right? And this is where the BPF verifier comes into play. It eliminates that risk by actually validating the BPF program before it gets loaded into the kernel. The kernel by default has default instrumentation capabilities, like you see some static tracing probes, trace points being the most famous or commonly used one. You have dynamic tracing probes such as K probes, U probes, or K-rate probes. K probes, for example, allow you to attach a custom BPF program to a particular kernel instruction, right? And when the kernel execution code flow lands at that particular instruction, the execution sidesteps into your BPF program. You get to do whatever you want there, and then it continues its normal flow. And U probes, essentially, as the name indicates, they're an equivalent to kernel probes for the applications that are running outside the kernel. And if you want to capture the return state of the instruction, you can use K-rate probes. Now, the whole point of all these tracing probes is to gather some information from the environment in which they're being executed, right? So now we have a BPF program. It's verified through a BPF verifier. It's loaded to a kernel hook point, and it's capturing some information. We need a mechanism now to stream this information from the kernel to user space, and that is where we have the perf buffers that kernel provides. So the BPF program can use the perf events to stream these events that they're collecting from the kernel space into a user space program, and you can have a user space program to listen on these perf events, and then you can act on them the way you wish to. You can configure some alarms, some monitoring on top of it, and that is where the observability aspect of it comes into play. There are BPF maps. They can be used to, as a way of communicating between, as a communication channel between your user space program and your BPF program that is running inside the kernel. Traditionally, using these probes involves in Linux kernel, right? It involves writing a custom program, compiling, and loading it as a kernel module, and that comes with its own set of risks, because now this is running inside the kernel, and if it's buggy, it can bring down the entire system, and that's not ideal for production workloads. And we just talked about how, in case of BPF, it has to pass through a verifier, and how that can mitigate this risk completely, and that makes it a compelling opportunity, right, for this particular use case. So in addition to that, BPF essentially piggybacks on these existing probes, and BPF developers essentially, made kernel modifications to execute your BPF program in place of a kernel module when the kernel execution lands at that particular instruction. And compared to the other native tracing technologies, BPF has a very minimal overhead, not only in terms of performance, but also latency, right? So how are we utilizing that, or how are we thinking about the implementation part of it? So I just talked about how we plan to enhance the VPC CNI to support the network policy functionality. will have a node agent that will be co-located as part of the CNI pod and will be responsible for policy enforcement at a node level. And we were just talking about how it is critical to gain visibility into what is happening at your compute layer and also at your network infrastructure layer. So we just needs to have a mechanism to stream these events from the kernel VPF group to a user space program, and we'll be able to upload them to an S3 endpoint or a CloudWatch endpoint. In addition to this, we will be supporting open source integrations such as with your Prometheus or Grafana or Innovatel plugins. So a high-level overview of our network policy architecture. We'll have a policy controller that will reside in the EKS control plane. And so EKS will own the lifecycle management of this particular component, and it is responsible for reconciling on any configured network policies. It will convert the pod selectors and the namespace selectors in the network policy to endpoint IPs. And it communicates this to the individual node agents that are running as part of the VPCNI pod using a custom CRD. And it's the job of the individual node agents to check if there is a local pod running on the node to which this particular policy applies. And if it finds one, it will attach an eBPF probe. It will pair it with an eBPF map, and it will populate the map with a set of endpoint IPs that the pod is allowed to communicate with. And as the pods scale up and scale down, and as IP addresses change, both the policy controller and the node agent will work together to keep the policy enforcement state up to date with the current state of the cluster. We will going to be supporting the native upstream network policy resource, and we talked about a bit about HTTP, and we get to use or we'll be supporting both of them at the same time: network policy for in-cluster traffic and and HTTP for creating a network boundary between your pod and any AWS resource. So Jayant will talk about how we plan to extend this node agent for observability use cases and how we plan to leverage eBPF for it. Go ahead, Jayant.
Hey, thanks, Apurv. So before jumping into observability, let's look into some of the common customer issues. On a weekly basis, we do see some of the common customer issues. One of the most common one is out of memory events. So maybe a pod on the compute resource is consuming a lot of memory. So this will cause some other pod to get impacted. So for instance, the AWS node pod, which Apurv just explained, which runs the CNI, might get ohm killed. And when the AWS node is getting ohm killed, at the time of the event, the customer or the user will not be aware of the event. Rather, they'll get to know when their workloads fail to get an IP address at a later point of the time. And when the event is happening, the necessary logs are not collected, or even the alert is not the customer is not alerted when the issue is happening. And the next is AWS or VPC has some constraints. So one of which is a DNS limit breaches, where per ENI there is 1K limit per second. So there is no visibility for the customer to know about these breaches, or if a operator is debugging these issues, they should be aware of this issue in the first place. And also because the DNS limit breaches, applications running will see some DNS failures, and that will impact the stability of the application. Similarly, any kernel limits, things like contract table exhaustion or PITS exhaustion. So these limits are not aware when the issue happens. Rather, the application's performance will be impacted. That is, no new flows will be created in the contract table, or no new processes will be created when the exhaustion happens. And this might not happen, always, or the issue might not occur as very often. It might happen maybe weeks down the lane or months down the lane as the process gets accumulated. And rather, when the issue is happening, it's not alerted, but we'll get to know maybe later point of the time, where we'll have to go through the node logs, identify the issues, and all of these issues will take multiple teams to be involved and to debug such issues. Similarly, at the instance level, things like, say, network bandwidth exhaustion, where each ENI will has a network bandwidth limitation, and now when an application is consuming the bandwidth, other apps running on the same compute resource will get impacted. And all of these issues will, as I previously mentioned, will need a lot of teams to be involved to identify the issue. Rather, this can be alerted with the necessary observability framework. So there are some third-party solutions available, which might not be aware of some of the native AWS or VPC specific limits, and so it would. So we have all heard from customers where they would like to see some native implementation, uh, uh, and how can we provide this observability within EKS? So as Apurv mentioned, we are thinking about using or envisioning the eBPF node agent to be leveraged for this observability using eBPF. So as Apurv just mentioned, with eBPF, we can get a rich amount of kernel data, where by attaching necessary probes, such as K probes, trace point probes, or any of the probing at some various kernel hook points. And and eBPF, as you all know, is event driven. So when the event is actually happening, the data can be collected from the kernel space. It can be streamed to the user space, and the user space, say in this case, the eBPF node agent can ideally get this information, add some Kubernetes metadata, because at the eBPF layer, we have information such as, say, IP or port, that is at the packet level. So for a Kubernetes user, adding a Kubernetes metadata over this layer and streaming it out to, say, some common collector. Say in the previous session we talked about OTel. So you can use OTel, or maybe directly stream to Prometheus, or any of the available solutions available outside can be leveraged. And secondly, we don't want the eBPF probes to be attached always. Rather, it has to be attached on need basis. So one of the ways that can be done is using a CRD in Kubernetes world, and also customers' intent as to what probes to be attached, or what function. Say, for instance, customer wants to monitor out of memory for AWS node. So in the CRD, this can ideally be provided where the customer's intent of what to monitor, and what level of filtering to be done. Like, say, for instance, if the filtering has to be done at the interface layer, or if the filtering based on the pod name namespace or deployment name namespace. So these things can be the intent of can be provided in the CRD, and this CRD can effectively be consumed by this eBPF node agent to attach the probes. Now let's go into some of the use cases which we discussed of some of the common customer issues. Say for out of memory events, ideally we can have a CRD, wherein the CRD can have, in this example, we are just taking deployment name and namespace, and the customer will provide their intent to monitor out of memory events for a particular deployment name and namespace. And now the eBPF node agent can go attach a kprobe for kill process kernel function, which will be executed each time when a PID is getting impacted by out of memory. Now, when this event is received by the eBPF node agent, the PID can be converted to get the container ID. From the container ID, we can get the pod name, namespace, deployment, a lot of Kubernetes metadata, and this filtering will be done by the node agent, which is running on each of the compute resources. And this metrics can be scraped by, say, OTel, or any other open source collector, or even directly write to CloudWatch. There you can set up alarms, and you can have an email generated when out of memory event is happening. So rather than knowing the issue happened later point of the time, you can know when the issue is happening at the time of the event, and necessary mitigation steps can be taken at the time of the event. And now about the VPC or the AWS constraints. So as we talked about for the DNS limits, so even here in the CRD, it can be mentioned to say capture or identify DNS breaches. where and you can specify say interface. In this case, we are taking E0 as an example, and whenever and a traffic classifier or the egress interface of E0 can be attached, and now the traffic classifier can capture all the packets specifically for .2 address, and any breaches happening, that is the 1K limit in per second, can be captured. And when the breach happens, event can be generated to CloudWatch, and this CloudWatch will have metrics per node, per EKS cluster. So ideally, when the breach is happening, customer can set up some alarms, and they'll know that on a particular instance there is a DNS breach happening. So instead of going through, so right now in the current approach, customer has to do a lot of capture a lot of TCP dumps, identify if the breach is happening, which involves a lot of manual work. Instead, with this setup, customer will know a breach is happening at the time of the event, and they can do some necessary mitigation steps on their compute resource. Similarly, about the kernel limits, we talked about PID and contract exhaustions. So here in the, if you are going through the same CRD approach, customer can specify to capture the kernel limits and specify some threshold, say 80% of the usage or 90% of the usage. And now for instance, for contract tables, you can attach a K-probe for hash insert, hash deletes, and the eBPF node agent can monitor the breaches. Similarly, for PIDs, a trace point probe can be attached for 4exec and 4exit to monitor the number of PID creations. And whenever a threshold is breached on per node for each of the EKS cluster, the node agent can export these metrics out to the external collector, and necessary alarms can be set up. And with all of these approaches, you can get the information when the issue is happening, rather than having it at a later point of the time where you'll have to go through the node logs, go through some historical data to identify the issue. So now, the way we are thinking about leveraging eBPF agent in future is just now. So recently, just now, Aprup talked about using eBPF agent for security enforcement. Now, if the eBPF agent can be leveraged to capture all these metrics from the kernel, and it can be scraped directly to some collectors. In this example, we are taking OpenTelemetry as one of the collectors. And as I previously mentioned, from the eBPF, you get all of the packet level information. But for a Kubernetes user, they would need to make more sense of the data, to add Kubernetes metadata over this layer. So we are envisioning to have an aggregator, which is a cluster level aggregator, which collects metrics from each of the node agent and adds Kubernetes metadata to it, and which can be streamed to either Prometheus or Grafana directly, or even maybe to CloudWatch. And alarms and monitoring can be set up, and aggregated logs with K8s metadata can be captured at the CloudWatch level. So with all this approach, you can get a rich kernel information for all of the constraints we talked about. So finally, the key takeaways from this talk is we spoke about importance of network policy and observability, and how we at EKS, we are trying to leverage eBPF to achieve both network policy enforcement and observability in future, and how having a native support in CNI for network policy using eBPF, how we are handling it at EKS, and how in future eBPF can be leveraged for metric collection in containerized workloads. So thanks for joining the talk. If you need any more information, you can reach me or Aprup on Kubernetes Slack channel, and we would love to hear from you about this. Thank you so much.
Well, thank you. Really appreciate your talk. Thank you so much. So one thing I kind of noticed is the need for ohm killer monitoring is always there. And I really appreciate how you explained that to people, because it really kind of sneaks up on folks and just surprises them sometimes in clusters. It's kind of wild.
It looked like there was a ton of extensibility there, and looking forward to seeing how this continues to develop going forward. Thanks a lot for the time you spent demoing that for us.
Thank you.
All right, see you around. All right, next up, we're talking cost optimization. and future-proofing your Kubernetes cluster for cost optimization. So how do you avoid making mistakes that'll lock you into a really large bill or go down a path where you're spending more money than you should? Let's learn. And I'm bringing in Raj and Roland and bringing up your presentation here. Why don't you fellows take it away and introduce yourselves and tell us more about what you're sharing with us today.
Move next door.
Hello, Raj, Roland.
Hey, Raj, Roland, you there?
Scabs again.
Hello. Let's see if we can get this cleaned up here. We'll get him back on stream in a second. Sound like he's warming up the pipes. Let's see here. Message him.
All the time.
Hello, Raj.
You get to bed.
All right, let's see. We gotta get somebody over in the room and get their attention. They don't realize it's their time to be on stream.
I'm working on it. Hang on.
All right. In the meantime, thanks so much for joining us for AWS on Air today. It's been a long day so far, and so much learning about Kubernetes and the possibilities of what you can do with container orchestration. This is AWS on Air concurrent with KubeCon. So especially if you're out in Amsterdam right now for KubeCon, thank you very much for joining us for this stream. We have a couple of surveys you might have seen pop up throughout the day. Please fill those out. My understanding is you have a chance to get a AWS credit if you do that. So follow us on twitch.tv/AWS on Air. Fill out the survey when it comes around, and we look forward to your continued feedback on the stream. All right, let's see if we're ready to bring in our guests. Hello, Raj.
Hello.
Hey, welcome to the stream.
Thank you.
All right, we know you got the energy. We dropped in on you a little bit and heard you humming a tune. So I know you're ready to go. You're ready to share some information.
Save people some money.
Hell yeah,
Giving it away.
Saving money. I'm all in for that, and you seem very happy about it. And I'm sure our guests and viewers will be very happy to learn how they can future-proof their Kubernetes cluster for cost optimization. Take it away.
All right. Welcome, everyone. My name is Roland Barcia. I am part of our worldwide specialist organization. I am the director for AppMod, which covers containers and serverless. We're excited to be here, and I'm with the famous Raj.
Hello, folks. My name is Raj Dipsa. I'm a principal solutions architect for containers and serverless at AWS. I do have an important message before we start. Please fire up your jams. You should be seeing the links on the chat right now. With that, pass it back to Roland.
And you don't want to miss those jams, so fire it up. All right, let's get going. So future-proofing your Kubernetes cluster for cost optimization. So you've heard throughout the day about what a great platform Amazon EKS is and what a dynamic platform Kubernetes is, and very scalable. And oftentimes people want to write applications that scale up to meet demand, meet performance, etc. But with that, oftentimes when you receive your bill, you realize, maybe I could do better. And we're going to try to give you some hints and techniques to do that. So since we're at KubeCon, we're broadcasting live from Amsterdam. We'll start with a CNCF survey. I kind of mentioned that 68% of organizations are increasing costs with Kubernetes, and that's going up year over year. And so how do we handle that? And so we're going to talk a little bit about different areas and different techniques that you can do in different parts of your environment to go through Kubernetes. And so, for example, we have the control plane. And the control plane, what's really cool about EKS is that's a fixed cost. It's a managed control plane. And so you fire up a cluster today, and we're always changing costs. It's about a little over $800 a year just to run the control plane. And that's really very low cost considering if you've managed your own control plane. We're going to get into workloads, which is really about where 70% of the costs lie. And so we're going to spend a little bit more time here. Going to try to make sure we give you time for the jam because we're going to have a challenge for you. And we're going to talk both at the pods and container level, as well as how we deal with things like nodes and different techniques for auto scaling. We're going to get into the sneaky category of networking costs. And we say sneaky because sometimes that cost is underestimated, and some best practices can really help reduce those costs as well. And also some costs around observability, both managing the observability stack itself and some of the metrics we use. So let's get going. And so this was a recent survey taken by Datadog, so customers that use Datadog for observability. About 49%, that's almost half, of containers use 30% of their requested CPU, less than. Same type of thing for memory, 45%, so almost half are really just underutilized. And that's an issue because when you're dealing with Kubernetes, when you request things, it's based on what you request, not often what you use. And we'll talk about that in a moment. Of course, you could, at AWS, really reduce costs. If you make a commitment, 1 to 3 years, you can use cost saving plans and reserved instances, get up to 72% savings. And so this is an obvious way to kind of reduce costs. But oftentimes when we work in the cloud, we work on demand. We want to scale up and down, not pay for things when we're using them, sometimes use a combination of reserved and on-demand instances. So we want to give you all the opportunities to save. So it all starts with containers, right? That's ultimately what we're deploying. Those containers in Kubernetes run in a pod. Those pods run in a node. Within those pods, you have other constructs that the pods depend on, like volumes. And so you really start with requesting memory. And so when you request memory or CPU, you're requesting an amount, and Kubernetes uses that to schedule it in the right node. It can schedule it on a very large node, and your container can use much more of that node. Of course, you want to have limits on that. And so that's why we have memory limits and CPU limits. If you run out of memory, you can get throttling, use CPU, or it just might not run your application, right? So these are things that you want to consider. But how do you know what sizes to put there? Sometimes when you're first writing your applications, you're not sure. Sometimes you scale up and you start using more. And so it all starts with what you can measure. And if you can't measure it, you can't manage it, as Peter Drucker once said. And so how do you do that? Well, you use different cost tools. One of the great tools that we're really proud of is KubeCost. We've done an integration, a managed add-on in partnership with KubeCost. And KubeCost really gives you some more visibility beyond the tools that we have in AWS, because KubeCost can look at Kubernetes constructs natively. Things like pods, namespaces, multiple clusters. It can give you a view of your costs, and it can also give you recommendations for savings. Those recommendations can be at a very fine-grained level, from your nodes to specific pods and applications. So for example, here we have a recommendation for savings at about $107.94. And you see here we have an Nginx deployment that really is calculating how much memory it's using. So in this case, we've requested 300 meg of data, but it's actually only using 10. Similarly with the RAM, right? So you could see here that instantly you see some savings. And so testing your applications, running KubeCost at the same time is a great way to get the right amount that you need. And so that's where it starts at containers. But what's next? Obviously the nodes and where those pods run. And with that, I'm going to turn it over to Raj. He's going to take us through some different techniques there.
Thank you, Roland. So Roland talked about how you can optimize the pods. Now, where do the pods run? On your nodes. you have a couple options to optimize your cost regarding EC2s. AWS offers Spot and AWS Graviton. Spot is the unused EC2 capacity that we provide to you with up to 90% discount over on-demand instances. And AWS Graviton processors are custom built by AWS with 64-bit ARM processor cores. You might be thinking, wow, that might be a lot of effort to use this. Not really. If you are already using a MacBook M1 or M2, you are actually using ARM processor. Graviton provides up to 40% better price performance over x86 64-bit instances. It powers various different instance families. One thing to keep in mind for using Graviton is you always want to build multi-architecture image. What it means is you can run your container either in Graviton as well as x86 instances. Amazon EKS provides full support for Graviton, as in we release EKS optimized AMIs for ARM64 with the same release cadence as x86. This is why AWS is the best place to run Kubernetes. Now, where do you integrate all these Spot and Graviton EC2 nodes? You have three options here. One is Cluster Autoscaler, second is Carpenter, third is the serverless way of running containers, which is Fargate. So let's start with the first one, Cluster Autoscaler. With Cluster Autoscaler, you can prioritize which node group to scale out first. In this example, on the left, we are creating two different node groups. The first one is managed on demand, which is spinning up T3.2x large. The second node group is managed that's reserved M5.x large. The assumption is you have bought reserved instances for this M5.extra large. So obviously you want to scale out the reserved instances and get maximum cost discount. On the right, we are using config map for Cluster Autoscaler. We have put the reserved instances, and it supports wildcard as denoted by asterisk, a higher priority as 50. So when the Cluster Autoscaler scales up your nodes, it is going to max out the reserved node group first, and then it is going to go after on demand. To utilize Spot and Graviton, you can create separate managed node group. You can mix with this priority expander, or you can use node selector, node affinity, etc. We'll come to that in a couple slides. In addition to that, you can also optimize Cluster Autoscaler. For example, if this is how your application is running, there are a lot of unused capacity. You can turn on scale down utilization threshold, and under that threshold, all the pods will be evicted from EC2 and put into other EC2 instances. And after scale down unneeded time, those unused EC2 instances will be terminated. Better utilization of worker nodes leading to reduced cost. How do you use Spot and Graviton in Carpenter? Carpenter doesn't use any autoscaling group, integrates directly with EC2 APIs. So here it is much simpler. In the Carpenter provisioner here, you can say carpenter.sh/capacity type in Spot, on demand. It is going to prioritize Spot instances. You can also specify carpenter.io/architecture in ARM64 as in Graviton. Now the beauty of Carpenter is anytime Carpenter spins up a node, it is going to add these labels. So in this case, if a ARM64 Spot instance comes up, it's going to add the label carpenter.sh/capacity type Spot, carpenter.io/architecture :ARM64. And you can use those labels to schedule your pods. On the right side, we are seeing a pod specification file where this pod must be scheduled in a node where the label is carpenter.sh/capacity type in Spot. How does Carpenter optimize the CPU and EC2 utilization? We saw for Cluster Autoscaler, you have to control a couple knobs. Carpenter makes it easier for you. You can simply set consolidation to true, and the pods will be bin packed. Carpenter gives you another additional feature. In addition to consolidation, it can also pick right EC2 instance type. For example, in this case, if the last pod bin packed into the second EC2 instance, which is M5.extra large, there will still be some underutilization. Carpenter can provision an M5.large node instead of M5.x large node and bin pack those, leading to reduced cost. You can also use namespace resource quota to allocate allowed compute to each namespace. Now you can also use this resource quota to limit number of API objects per namespace. Load balancers could be expensive, both for cost as well as IP address consumption. You can use a resource quota such as the one shown in the screen to restrict each namespace to have only 2 load balancers. Let's talk about Amazon EKS Fargate. To measure the request and limits for EKS Fargate, use CloudWatch Container Insights for Amazon EKS. And it will give you a matrix like this. On the right of your screen, you can see it's showing the CPU and memory utilization of Fargate, using which you can optimize those. KubeCost doesn't work with Fargate yet because Fargate doesn't support daemon set. Let's talk about network cost. Roland hinted on this. In case you are using analytics workload or chatty workload, this one can sneak up on you. This is a traditional EKS implementation to availability zone with EC2s, your pods running inside those EC2s with the application load balancer. Any traffic between the application load balancer to the pods does not incur any data transfer charge. Any traffic between the pod and database within the same AZ is also free of any data transfer charge. However, cross AZ pod to pod incur data transfer charge, as well as cross AZ pod to database. And then there is a egress charge from application load balancer to outside, but that is minimal compared to this internal cross AZ cost. So how do you minimize those costs? For high pod to pod data transfer workloads, you can restrict all the pods in the same AZ. Any nodes have the topology.kubernetes.io/zone label. You can use those labels to schedule those pod using node selector or node affinity. With cluster autoscaler, you can create manage node group in the same availability zone. With Carpenter on the provisioner, you can define specific availability zone in provisioner where the nodes must come up. You can also utilize topology aware hints, which went beta in Kubernetes version 1.23. How do you find data transfer charges? If your workload is running on Amazon EC2, you can use KubeCost. KubeCost shows network charges, or you can use custom solution. We have a couple blogs on that. With Fargate, detailed billing report now shows cost per pod with breakdown. Some other networking cost factors to keep in mind: Amazon ECR private registry, cross-region data transfer is charged. So please use built-in cross-region replication, limit images to essentials. Also use ECR S3 private endpoint instead of going through NAT gateway to avoid egress charges. NAT gateway, private link, transit gateway, they all incur charges. Use IP mode instead of instance mode for AWS load balancer controller to save any cross-availability zone hop. Remember, public and private clusters incur different networking charges, so determine the most efficient network path based on your requirement. And networking charges vary by AWS service. All right, now that we understand the networking pod node, I'm going to pass to Roland to talk about observability cost.
Yeah, want to make sure we give you time for the jam. So we're going to be very quick here. One is use managed Prometheus and Grafana for your observability stack. A lot of customers sometimes have a self-managed observability stack, which is workload, and they have to manage, maintain, upgrade those things. And we found that you can save an average of 30% versus self-managed solutions. So highly consider that. In addition to that, ADOT should be used with your applications as a way to pass metrics. If you use ADOT, you can use selective metrics and only send the metrics that you need. So filter wisely, and that'll save you costs as well. Logs. And so one of the things that we want to talk about with logs is, first of all, there's different types of logs. Security scans and logs are often a type of log that incurs cost. Views, newly launched Amazon GuardDuty integration with EKS and Amazon Detective. These things do not ingest or store data, so it's highly optimized in cost. And then you can integrate it with some of our event-driven architecture technology like EventBridge, use filtering rules and SNS in the background and do things asynchronously. So this is a nice way to actually save money by using these techniques. Lastly, when you forward your logs to CloudWatch, remember that logs by default are stored forever. So what you want to do is set, first of all, an expiration, and then utilize S3, and then you can use S3 tiering like Glacier to kind of save on cost there and only save the logs that you need to for a period of time. Lastly, in a regulated environment, if you use a hardened AMI, oftentimes the default is set to info. For example, if you're doing node audit logs, You could often set the log level down or remove them completely to error warning to save cost. Highly recommended. Similarly, like you did for metrics, with ADOT, you can do selective filtering. So if you remember in the previous logs, I believe a couple slides ago, you have the processor going on there. And so the processor could actually greatly save you time with filtering. And here's an example of how you set a filtering rule to just send important records and the minimum info required. And so with that, you have here a GitHub repo where you can see some of these examples. In summary, before we go to the jam, workloads, network, observability, all give you costs. There are other factors as well we haven't talked about, storage and other things that you want to consider. And for some examples, here are some resources you can use available to you as well. And with that, let's move over to the jam. Take it away, Raj.
Thank you, Roland.
Let's jam.
Let's jam. Okay. Cool. So you should have the jam up. This jam is going to cover what Roland talked about. There are some bad workloads running in the cluster. We are going to determine it, and then we are going to optimize it and save some money. So on the task one, it says, as a platform engineer, we are running a AKS cluster. First things first, we need to find how many nodes are running. To do that, we can simply go to open AWS console, and then we are going to go Cloud9. Let me type Cloud9. Here we go. Now, of course, you can go to console and cheat a little bit and find out the number of nodes, but we are all a veteran platform engineer. So what we are going to do is run commands. All right, let me open up the Cloud9 console. It takes a few seconds. All right, happy coding. Here we go. I'm going to make this a little bigger. There we go. There we go. Sorry about that. All right. To get the number of nodes, you simply type kubectl get nodes, and we should see 3 nodes running. So here we go. We go to task 1. We simply need to find out how many nodes are running. You can enter 3 here. Click submit answer. All right. We scored 23 points, which is pretty good. Click close. Now all the fun really begins. Task 2. So we have some workloads running, and we also have a KubeCost running. So let's check out KubeCost. And to go to KubeCost, KubeCost is exposed through load balancer. You're going to go to Cloud9, find out the kubectl, get svc, KubeCost. So for namespace KubeCost, all right, so we have this load balancer URL. So I'm going to copy this and open this here. This is the KubeCost for this cluster. Cost efficiency, 18%, pretty low. We are going to fix all that. We can save up to $177. To see the savings, you can go under savings. And this is the screenshot that Roland was sharing. You have multiple ways to save money. For this jam, we are going to go right size your container request. If I scroll down, scroll right, it is descending order by savings. So you could see this team 3/frontend:/Nginx is spending a lot of money. So how do you optimize it? So if I click it, it shows how much CPU is recommended and how much RAM is recommended. But first of all, for Jam 2, we need to say, what is the deployment name for this? So this is a little tricky. Team 3 is the namespace name, Nginx is the container name, and frontend is the deployment name. So if I go back to Cloud9, if I do kubectl get deployment -a, it should show all the deployment. So you could see team 3 is the namespace, and the name of the deployment is frontend. So let's do that in the jam.
I think the audience is beating you.
Oh, that's good. That's good. Okay. Frontend, submit answer.
Oh, 45.
45 points. Okay. All right. So let's go to task 3. So now we have to optimize it, right? So this is the last step. So we go to KubeCost, and then we see how much is recommended and how much RAM and CPU. So it recommends 31 millicore and 20 megabyte of RAM. So we go back to Cloud9. We have the deployment file here. So you can simply double click to open it up. And now we have to find the theme 3's deployment. So let's go to theme 3. Here we go. Front end, okay, CPU. We are going to put 31 millicore, and the RAM is 50, I believe. How much did we say? 20. Okay, even better. Okay.
Come on.
Okay, 20 megabytes. Here we go. You can press Control S to save, and then you can simply type.
Apply that bad boy.
Yep, kubectl apply -f deployments.yaml. Okay. Everything else should remain unchanged. Only thing that should change is deployment.app/frontend. So that's configured. So we have optimized our workload. So KubeCon takes around 15 minutes to reflect it. But if you have done it, you will have access to this jam till Friday, end of the day. You can come back and you should see some savings. Now, to get the points, before I forget, you have to make sure your pods are in running stages. So if I move this thing and do kubectl get pods -n team 3.
Always those front-end developers.
Always those front-end developers. No disrespect meant. We love front-end, we love back-end. Okay, now we go to Jam and click check my progress. Okay.
Let's see.
Woo! All right. So that is the Jam. And with that, whoever is coming to KubeCon, you can stop by our AWS cost booth. I know we have a lot of information packed to talk with us, see more demos. It's going to go April 20th, Thursday, from 10:30 European time to 1:45. With that, Roland.
Thanks.
All right.
All right.
All right, guys. With that, there should be a... all right, it's our Twitter and LinkedIn if you want to follow us.
Please do so. Thank you.
Great demo, very interactive. I love seeing the tools in action, and thank you for bringing that energy.
All right.
Yeah, and I mentioned this in Twitch chat, but like a more cost-optimized infrastructure is a more sustainable infrastructure at the same time. So you can kind of check two boxes with the same processes. And then people were curious also about like Carpenter and KubeCon together, which I thought, yeah, it's a great 1-2 combo, but I wonder what we could do there. It's got my brain going here a little bit.
Yeah, you can use Carpenter with KubeCon. Carpenter is the autoscaler. If you use Carpenter, because Carpenter has the consolidation feature as well as picking right EC2 instance type, you would see more cost optimization using Carpenter, easier to do than construction.
Yeah, and KubeCon gives you node level visibility costs as well, not just pods. So we use pods as an example.
Right.
You can use kind of the node, type of things as well in KubeCon, and that can help you with the right provisioner configuration for Carpenter.
Very nice. Well, thank you very much for delivering this session for us and showing us how to save money on Kubernetes. See you around at the next one.
Yeah.
All right. Cool. All right. And fill up the review. I assume you guys will put it on the chat.
Yep.
And see you guys later.
Take care.
Thank you.
Bye.
Thanks, y'all. All right. So next up, it's already over, Nathan. It's almost done. We have our last talk of the day.
Yeah.
Coming up, we're going to talk about running Kubernetes workloads at scale with Natasha and Robert. Scaling your workloads is not necessarily trivial, right? So Natasha and Robert are going to help us with that.
I love hearing about scale, especially the biggest scale possible.
Yeah.
We'll bring up your slides here. And,
Amazing.
We'll let y'all introduce yourselves. Take it away.
Thank you.
Thank you, everyone. So scaling your Kubernetes workloads is not only about the number of nodes, number of pods, or other Kubernetes objects, though this is super important, but it's also about how do I select the right sized compute for cost optimization and compute efficiency. And this is a continuous process as our workload evolves. And today we're going to be talking about different dimensions of scaling YAML and EKS and some best practices around this. My name is Robert Northard. I'm a container specialist at AWS, And today I'm talking with Natasha. Right, so over to you, Natasha.
Thank you. I'm Natasha Wright. I'm a container specialist here at AWS. And in the previous talk, you heard about different cost optimization techniques you can use when using a Kubernetes cluster. And we're going to be talking specifically about how to really keep some of those cost optimization techniques in mind when you need to run things at scale, as we often do. So before we jump into how you scale Kubernetes, we wanted to spend a minute exploring the different dimensions when it comes to scaling Kubernetes. First, you have your Kubernetes control plane or your API server. If you're an Amazon EKS user, AWS will run this for you and also manage the scaling of this component for you. We then have your Kubernetes data plane or your worker nodes. And really scaling here refers to any of the AWS resources that are required to run your workloads. So things like your EC2 instances or your storage volumes that you're using. We then have those cluster services, and these are things that you deploy to your cluster that provide some sort of capability for your applications, things like core DNS, for example. So when you're scaling your workloads, you also need to think about these components and how they're impacted when you scale. And finally, we have your workloads themselves. In this talk today, we're solely going to be focusing on scaling of the data plane and your workloads. So let's think about a Kubernetes cluster for a second. So imagine you have a cluster that looks a little bit like this picture we have on the screen. So you've got some compute instances stretched over 2 availability zones, and those are collected up into auto-scaling groups. And as you might notice from this diagram, we've got 5 auto-scaling groups in this particular picture, and each one depicts a different type of EC2 compute that you can use with AWS. On one hand of the diagram, we've got some pictures of different teams, and these are teams that are going to be consuming or deploying applications to your cluster. This could be different engineering teams, a platform team, and each of those teams are going to come with their own workload needs and requirements. One team might need a particular type of compute, one team might need a particular type of architecture, and every time a new team onboards to your platform, you're going to need to consider how you change the compute that makes up your platform. As you might notice, there's not an even number of EC2 instances in this diagram either. So this is probably a cluster at some point in time that has scaled. It's grown. We've added more compute to that data plane. So as you scale, there are a few questions you'll need to ask yourself. Things like, how do I patch at scale? How do I patch really quickly when I have 3,000 nodes? How do I ensure that I'm picking the right sized or the right EC2 instances for my workload? How do I maintain performance of my cluster? How do I make sure those core services that we mentioned in the previous slide, how do we make sure that they're scaling in line with our workload as well? So before we start thinking about some of those things, let's just consider our workload for a second. So let's imagine we've deployed a workload to our cluster. Now, when that workload first exists on our cluster, it's probably not going to be using much compute that we have in our cluster. So we've got a graph here that depicts average compute utilization over time. And you can see at the start, it's quite low. So we have lots of compute available. So our workloads kind of got room to breathe and grow. But actually, you might consider at this point in time that our cluster is actually over-provisioned. We have far more compute than our workload actually needs. Now, this has an impact on cost. If we've provisioned a lot of compute that we don't need, we're paying for compute that we're not using. As demand on our workload increases, or you can see the graph moving upwards, we're starting to use more and more of the compute we have available, which is great. We're now using more of what we've paid for. But at some point, we are going to hit a threshold when we might consider ourselves to be resource constrained. And really what we want at this point in time is that constraint to trigger some sort of scaling event or behavior which impacts our data plane. So our data plane will scale, giving us more compute in our cluster, which then drives that average compute utilization down. So now we can see in this particular image, we've got higher compute utilization, but it's flat, it's not spiky, but actually we've added more compute to our cluster here. And again, that has an impact on cost. We've now increased what we have in our cluster. it's really rare you'll get an average compute utilization that looks a little bit like this, where things are quite flat, things are quite consistent. We can plan when we'll have those spikes in our workload, and we can react appropriately by scaling up or scaling down, for example. More realistically, you'll probably have something that looks a little bit like this when we consider your workload over time, where you'll see these kind of peaks and dips in terms of the amount of compute utilization that your workload's using. Now, this has an impact in terms of how you scale. If you need to scale a lot, you need to consider how you're scaling, the impact that has on your cost, the impact that that has in terms of your workload and any requirements that your workload might have. Now, let's also keep in mind that this time period that we've depicted here on the screen, this could be 1 day, this could be 1 hour. The needs of your workload might change over an undefinable period of time. So we need to make sure that we are scaling appropriately. So how do we scale our clusters to maximize the amount that our cluster can do to ensure that when we want to go from, say, 1 pod to 10,000 pods, we can do so without impacting the availability and service that our workload provides our users? We recommend 2 approaches that we're going to talk about today. So the first is managed node groups with cluster autoscaler. So EKS managed node groups will automate the provisioning and lifecycle management of nodes in your cluster. If you create a node using a managed node group, it's automatically tagged for service discovery to your cluster. So you don't need to do any manual steps to register it with your API server. You can apply things like labels to these nodes as well, so that they're easily searchable and referenceable in your cluster. When you're using a managed node group, you can take advantage of things like different purchase options with AWS, so something like on demand or spot. And if you're using spot with managed node groups, we will automatically make configuration changes in the auto scaling group for you, so you can take advantage of spot best practice. So that's everything like automatic draining when we want to cordon off a node, graceful rebalancing, allocation strategies. All of these things are already baked in for you. And using managed node groups with cluster autoscaler is quite a common thing we see with customers that have lots of different compute requirements. We then have Carpenter, and Carpenter provisions nodes based on what your pod needs. It looks at what your workload and your pods need to run and provisions the right size EC2 instance to do that. It's not natively dependent on cluster autoscaler, so it can work independently of cluster autoscaler. And it can honor configurations that you might have with the diverse set of compute that you wish to use. So if you want to use particular type of instance families, particular architectures, or even particular purchase options, things like spot, you can do so with Carpenter, and you can do so using a single configuration. So now we're going to explore a little bit around how these 2 actually work. So in the previous talk, you saw some great configuration options that you can leverage to use Carpenter with your clusters. So now we're going to explore a little bit about how it really works and what that workflow looks like. So first of all, let's start with cluster autoscaler. So let's imagine you have a workload that's deployed to your cluster and demand on that workload has increased. Horizontal pod autoscaler is kicked in and increased the number of replicas. But you don't have enough compute in your cluster to run those pods. So those pods go from being pending to being unschedulable very, very quickly. At this point, the cluster autoscaler will recognize that it needs to add more compute to the cluster for you to run these pods. So when you're using managed node groups, cluster autoscaler will select the right managed node group to expand in order to add an additional node into your cluster. When you have only one managed node group, this is really easy for cluster autoscaler because it picks that managed node group and adds a new EC2 instance there. When you have more than one managed node group, it needs to use a concept of expanders in order to select which managed node group is the right one to expand. If your pod is unschedulable for a reason other than you've run out of compute, such as maybe the type of node that you need isn't available in your cluster, like a GPU instance, for example, the cluster autoscaler will look for the node group that provides a GPU instance to your cluster. And if there isn't one, you'd need to create that managed node group configuration to make sure that it's there. With Carpenter, the entry point is exactly the same. Horizontal pod autoscaler has done its thing and created some more replicas. These replicas have moved from pending to being unschedulable because there isn't enough compute capacity in your cluster. Carpenter will listen to events that happen on your cluster, so it will see this happening. At that point, what it does is it will bin pack all of the unschedulable pods, so all the CPU and the memory for those pods. It also takes into account any additional things you need to run on the node, like a daemon set, for example. What it does, once it has that collective request, it spins up an Amazon EC2 instance, which will satisfy the needs of all of that bin packed together. It can also satisfy any constraints that you've got. Say, for example, you don't want bare metal or GPU instances, or you want to make use of spot or on-demand instances. It can satisfy all of those constraints as well. So the workflow when you're using either one of these mechanisms is ever so slightly different. So HPA, we've started at this point again. The number of replicas needs to increase in our particular cluster, and you've got some pending pods. Now, we know that this will be marked as unschedulable because there isn't enough compute capacity in the cluster. Cluster autoscaler sees this, will invoke an autoscaling group that's associated with your managed node group, makes a call to the EC2 API and provisions you a new node. Now, with Carpenter, there's no cluster autoscaler and there's no autoscaling group. Carpenter will see that there are these pods that can't be scheduled and will make a call, and not to the EC2 API, but to the EC2 Fleet Instance API. Now, this is a synchronous call, so it's not going to be waiting in a queue for a response back. And as we mentioned on the previous slide, Carpenter will bin pack all of the pods that need to be scheduled, and it will make a request to the Fleet API. But it doesn't make a request for a single EC2 instance. It makes a request for a group of EC2 instances that will satisfy the needs of running all of those pods plus those overheads you might have, like those daemon sets. The Fleet API will then provision the EC2 instance. If that's not available for any reason, it will simply move to the next EC2 instance that's in the Carpenter request. If you're using on-demand instances, Carpenter will use the lowest price strategy. So it will always be looking for the cheapest EC2 instance to satisfy running those pods. If you're using Spot, for example, it will use a price capacity optimized strategy. So it will basically tell Fleet to find the EC2 instance that has the most capacity whilst considering the price. So if you're using either of these two mechanisms, you may end up with cluster or clusters that look a little bit like this. So on one side of the screen, we've got a cluster that's managed by cluster autoscaler and managed node groups. And in this instance, we have 3 managed node groups that each relate to a different type of EC2 compute instance. One thing to note from an operational perspective, this is 3 configurations that you'll need to look after and test as part of your upgrade process. If you have a new team or a new requirement for your cluster, you'll need to create a new managed node group configuration for any new requirements you have. So that's just something to keep in mind from an operational overhead perspective. Now with Carpenter, you see the picture looks very different. It's what we call groupless. So we're not grouping those EC2 instances into these node groups. There's a much more diverse set of EC2 instances that are making up your cluster, which means sometimes when you're running Carpenter, it can be difficult to draw the picture of the EC2 instances that are there. But you're going to have a much broader range of EC2 instances that are there. You won't be bound by those configurations for the managed node groups. So if you do have a new team onboarding or a new workload that has new requirements, you won't need to create another new configuration to handle that, which can be something to keep in mind when you're considering operational overheads. So that's an introduction to those 2 mechanisms. And now I'm going to hand over to Robert, who's going to walk through the best practices when using them.
Thank you, Natasha. So let's now talk about some of the best practices when scaling your data plane. We've picked some best practices from the Amazon EKS Best Practice Guide. We'll share this link with you to deep dive later. These best practices typically exist from the workload, pod, or node kind of context level, and we kind of recommend you leverage all of them when considering data plane scaling for your cluster. It's important when you talk about data plane scaling, we're scaling on the right metrics. Proportional metrics generally make good scaling metrics. You might consider using HPA to scale horizontally based on average CPU utilization, or KEDA to scale on things like the average queue depth. These are generally good metrics because as the workload varies over time, so does the metric value. And as scaling is a latent process, you need to use performance testing to work out what are your scaling thresholds. So what CPU threshold do I scale on? What queue depth would I scale on, for example? If we look at the graph on the left-hand side, no, on the right-hand side, memory might not be a good metric to scale on for some workloads, as it might maintain like a steady utilization over changes as the application changes over time, since it bootstraps. But generally, if you can anticipate demand, for example, you have a flash sale, plan accordingly, plan in advance. Maybe look at something like the cluster over provisioner in that case. If you can anticipate demand, maybe try and plan a bit more proactively in advance. And when we talk about scaling, as Tash mentioned, we're taking the aggregation of kind of the CPU and memory requests, and Carpenter and Cluster Autoscaler uses this. If we take a scenario where we've got two types of kind of resources, we've got non-compressible resources. When there's resource exhaustion for non-compressible resources, let's take memory, the process will be terminated. And it's generally recommended to set requests equals to limits for non-compressible resources. As an example, pods that have a memory limit that is much larger than the memory request can burst above that request. If several pods on the same node have that limit much higher than the request, and they all burst at the same time, you potentially get out of memory errors. And things like consolidation might make this more likely to occur. The next type of resources we have are compressible resources, so CPU. During contention, things just work more slowly. So when you're setting things like CPU limits, be very careful about what you set that limit to. Monitor. You might actually artificially be slowing down your system. Resources can also be reserved for things like the kubelet to improve worker node stability. And if you're using the EKS optimized AMIs, this is configured by default on startup based on the number of CPUs and total memory available for that EC2 instance. It's also important when scaling to think about and to achieve high availability to spread our workloads across different fault domains. And these fault domains could be things like availability zones, maybe hosts or different compute purchase options. If you don't, maybe when you scale your replicas, they might land all in one EC2 instance. So we recommend taking a look at kind of these different kind of topology zones here. There is no guarantee that the constraint remains satisfied when pods are removed. For example, scaling down the deployment may result in an imbalance between that pod distribution on that particular topology. And as Tash mentioned earlier, talking about spot instances, when using Amazon EC2, spot instances are spare compute capacity. You don't really want to artificially constrain your instance type selection. You want to diversify as across many instance types as possible and compute architectures. As Carpenter uses the price capacity optimized allocation strategy, this tries to balance price and the available based on the available spare capacity pools. And to maximize picking an instance type that has the least probability of a spot interruption, you're going to want to diversify across many EC2s as possible. So don't artificially constrain. If for managed node groups, on the left-hand side, we can do something called attribute-based instance selection, where you can say, hey, give me all of the EC2 instances that have 2 vCPUs and 2 GB outside memory. When using node groups, it's very important that each node in the node group has the same resource profile so that the cluster autoscaler can function. On Carpenter on the right-hand side, you just say, hey, these are my capacity types I'd like to use. These are my CPU architectures. Let Carpenter manage which EC2 instance to pick for me to that kind of fleet API. So the key messaging here is don't artificially constrain. Compute resources are finite.
And this is something we might see in the demo shortly.
Yep, definitely. And when we talk about kind of, as Tash mentioned, like scaling to lots of pods, we also need to think about our different teams, so our platform teams. You should consider setting things like pod disruption budgets to ensure workloads are gracefully terminated during voluntary disruptions. For example, node draining during upgrades or patching. And this helps platform teams kind of do more continuous operations so they're not blocked in kind of those application teams. Think of a multi-tenancy Kubernetes cluster. You want your applications teams to control the minimum number of replicas that are available. Managed node groups and Carpenter both honor pod disruption budgets as they use the eviction API to start draining and cordoning nodes on scale down or on upgrades, for example. In addition, sometimes during a deployment, a pod may be considered healthy, but actually it's not accessible by external services. Maybe an application load balancer, target registration might not have completed, but actually the pod is healthy from Kubernetes perspective. If you're using the AWS load balancer controller, you might consider pod readiness gates. And pod readiness gates can indicate that a pod is actually registered at ALB or the NLB, and target registration is complete, and it's healthy to receive traffic. So this can help a more zero downtime approach to scaling up in certain conditions. We spoke about diversifying across a lot of EC2 instances, but we also have to acknowledge that some workloads might be sensitive to different compute. They might be very sensitive to their compute. A workload requesting 500 milli CPUs will probably perform very differently on 4 cores than it would on 16. And you might want to avoid instance types that are burstable CPU instance types. So consider the above labels. Other labels that you can kind of constrain on are things like hypervisor, instance generation, maybe even instance network bandwidth if you're very particular for a networking perspective. And at the start of the presentation, we said picking the right size EC2 instance can be hard, but it's also a continuous process. So what mechanisms are there that can help us? So how do we use our resources more efficiently, but also maintain scalability, availability, and performance, but reduce our costs? Carpenter has a feature called consolidation, which works actively to reduce the cluster cost by identifying when nodes can be removed, or maybe 2 nodes can be joined into one. In this particular example, we had 3 nodes in our existing compute capacity, but Carpenter said, hey, actually, from a cost perspective, it made more sense to have this new optimized strategy here. So it's gone down to 2 nodes. And Carpenter does honor things like your topology spread constraints, pod anti-affinities, etc. So do have this in mind if you want to make sure that you're spreading across those fault domains. And when we talk about managing multiple node groups or lots and lots of nodes, we need to think, how do we patch at scale? If you're not specifying an Amazon machine image with Carpenter, Carpenter will use the latest version of the EKS optimized AMI for your particular version of Amazon EKS, and it'll automatically use that. You might consider setting a TTL seconds till expired when using Carpenter on the provisioner to basically say, hey, after this time has expired, delete my node. And if that node is still needed, Carpenter will then go and provision a new node, that latest version of the AMI. So thinking more of a continuous kind of update mechanism. We recommend treating infrastructure as immutable and thoroughly testing updates that are promoted through lower environments and the same way you promote applications through. But if you do need to patch instances with speed, maybe consider something like AWS Systems Manager Patch Manager for in place, or things like the Bottlerocket Node Updater or Flatcar Linux Update Operator, for example.
Really change the way we do some operations.
Yeah, so more of a continuous mechanism rather than a point in time for your teams. Awesome. So we're going to go into a demo now and show you. So I've created a cluster using Amazon EKS blueprints that was talked about earlier in the day. And I've installed Carpenter. And Carpenter runs on your data plane as 2 pods. You could either run it in a managed node group, or you might decide I want to run it on AWS Fargate serverless. Likewise, you can do with Core DNS. And I have 0 nodes that are managed by Carpenter at the moment. So I'm going to deploy a workload. And this workload has 3 pods. But I've been bad. I've not configured my Carpenter Visual Array optionally. I've artificially constrained what instance types I can use. I've not diversified different compute options. What Carpenter has done here, you can see that Carpenter has gone, hey, I've got 3 pods that are unschedulable, 3 pods here, and it says I need 3 machines to satisfy this constraint. It's discovered the AMI to use from the SSM property, so it's going to be using the latest EKS optimized AMI to pull that, and it's launching those instances. And you'll notice that it's using on demand, and in the top right-hand corner, it's about $200 a month. And this is the EKS node viewer if you want this visualization to play with, and you can find that on GitHub, and it will be shared there. So let's kind of see what's happened here. So let's look at my poorly configured provisioner. So I can use my provisioner resource, which is not namespace scoped, it's global. And I can have a look and see what I did. So after looking at what we spoke about earlier, let's enable consolidation. Let's help Carpenter make our lives a bit more easier there when it comes to selecting the continuous updates. We've also got limits. So a bit like in your scaling group, you can say, I want a maximum of 10 EC2 instances. With Carpenter, when you think about an application perspective, we don't think about the number of EC2s. We think about limits in terms of maximum CPUs in my cluster or maximum amount of memory. So I've set some just defaults here. We select the OS, and then we specify the capacity type. But my workload, it can handle interruptions. So I'm going to also I'm going to try and use some spot here. I'm going to choose AMD. And I can see I've artificially constrained the T3 large, a burstable. Actually, maybe there's a better choice. Let's let Carpenter pick a node for me. So what will happen is, I'm just looking at the logs for Carpenter now. Carpenter will proactively try to find, is there a better configuration at this point in time to actively reduce cost? And we'll kind of see what it's going to do in 1 second here. So you can see that it's deleted the launch template, and it's decided that, oh, actually, I'm going to launch a spot instance. And that spot instance is M61X large, 0 pods, and it's starting up. And it started to cordon using the eviction API, the old nodes. So basically, we're saying no new pods can go on these as they're now unschedulable. But one of the questions we ask is, why has it all gone onto one EC2 instance? Why? But I want to think about my fault domains. How do I spread my workload across?
Yeah, I want my workload across different availability zones.
Exactly. So let's go over to our pod, and we can see I've only specified one node selector for my Carpenter. But you can see it's reduced my cost to $82 a month. But I want to go across various pieces. How do I do this? So I have some YAML here that I'm going to use topology spread constraints. And I'm going to say, try and schedule across zones. But also, I don't want my pod scheduling, the same pod scheduling on the same host. So if I save that, I'll delete quickly the old one, like this, and so wait for it to terminate. As of course, the kube scheduler gets the first shot at scheduling. So there's existing compute there. So it would go on this one of us to do a kubectl apply straight away as the kube scheduler gets the first shot. So we'll just wait for Carpenter to expire that node. Cool. Awesome, so that's gone. And let's see what's going to happen now. Awesome, so what Carpenter should do is now, in theory, using this topology spread constraint, say, hey, I want 3 nodes, one in each availability zone that I'm aware about, and of course, one of those replicas on each node. Cool. So if we look at, we can see I've got one node in A, one node in C, and I've got a third node that's just popped up, and that's in B. So I now have my workload suitably spread across different availability zones.
And they're all spot instances
and
as
they're
well.
all spot instances as well, and it's gone down to $113 a month. And Raj and Rowan spoke earlier about, how do I pick? Cool. So back onto our slides now. So to summarize some of the key takeaways, work backwards from your compute requirements, and these compute requirements evolve over time. So really take advantage of the different scaling mechanisms that can help you provision the right size EC2 instances for your workload. That can do it in a continuous way. Scaling mechanisms that can also manage the lifecycle of your nodes, like capacity rebalance, you can manage node groups and spot. Scale with availability in mind. Think about different fault domains, whether that's availability zones, host names, or different compute purchase options. And choose the appropriate scaling metrics. And if you can anticipate demand, like a flash sale, scale in advance. If you can anticipate it, why not? And also really do consider when you set requests and limits for your resources, as this is kind of the core mechanism to data scaling, but also Carpenter consolidation. We don't want to we want to reduce those risks of out of memory terminations. And really, we'd like to thank you today, as the hero of our presentation is really the Amazon EKS Best Practice Guide. And you can deep dive into a lot more what we spoke about today there. And thank you for everyone that has contributed to that guide. And thank you for your time today.
Thank you.
Thank you, Rob and Sasha. I mean, I always love Carpenter demos just in general, because people ask really interesting questions like, when wouldn't I use Carpenter? And kind of my answer to that is, if you're already happy with what you got. So, but if you're using manage node groups and you're doing all the best practices, Carpenter is just a natural evolution, I feel like, in auto scaling in general and just right sizing clusters. When wouldn't you recommend folks use Carpenter? I mean, what are the use cases there? Few and far between, I imagine.
That's a really good question. I think we've definitely had conversations to date where people have said, I've heard about this Carpenter thing, I want to use it, tell me how. And they're already using Cluster Autoscaler. And for those particular customers, we've explored how their experience has been with Cluster Autoscaler so far. And in many cases, they don't want to, they don't need to use Carpenter. It just happens to be the new thing that they want to experiment with. We've seen some teams who are starting, say, new proof of concepts or experimenting, particularly like your innovation teams or your new application teams, like teams in an innovation garage or something like that. And they really want to move away from this traditional idea of my cluster is X many servers, and I need to patch X many servers, and I need to do this. And they're really embracing this idea that actually they can use something like Carpenter to really gain some of those operational quick wins, really, with things like the time to live on the nodes and using the latest AMIs there. And it's great for them because if they're experimenting, they may not necessarily know upfront exactly what their workload needs or exactly what their application needs. So we're seeing it having a real sweet spot with some of our customers there. In terms of customers where it may not make sense,
maybe if you've got one managed node group and small, but not a lot of nodes, and I think where we see kind of a lot of good impact is if you've got lots and lots of managed node groups, over time they're going to become inefficient. So we talk about Carpenter can help really reduce the number of node groups you're going to need to manage and patch individually. And I think that's where kind of a lot of the operational benefits can come in. But maybe if you've got a single managed node group and a smaller cluster that, I've right-sized, or I've got a cluster that requires some GPUs, or something very specific.
Yeah, we do see platforms that do want
we
a little bit
do
more
have another
control.
question coming in I want to ask before we run out of time. And that's from Sume. I believe they're asking about the behavior with spot instances. If a spot instance is going to be interrupted, does Carpenter proactively replace that instance before it goes down, or does it wait until after the instance has been terminated and then replace it?
Great. So Carpenter does look for these spot instance interruptions, and you can configure an event bridge and a queue to look for that. Carpenter, when it receives the interruption, it will immediately call in that node that's at risk of interruption, and it will start to provision a new Amazon EC2 instance, and that node will get trained. If you're using like managed node groups as well, and using spots, so going a bit further past this question, there's past the 2-minute interruption, managed node groups will also try to do a capacity rebalance event. Programmatically try to identify an EC2 that's an elevated risk of interruption prior to that 2 minutes. But no, Carpenter will be able to listen to those events and proactively encode and drain using. But you have those 2 minutes. So your workload needs to respond to those SIG terms and make sure it can gracefully shut down within those when it receives those requests.
That's awesome. So it sounds like it will, as long as you make sure that your application is also responsive to the events that come in that indicate.
Yeah, for sure.
Yeah.
Awesome. Folks, we are at the end of our day here, and we appreciate you tuning in, but we have a survey we'd like you to fill out first before you go. I've been told I don't get paid unless you do it. I'm joking. But I want to thank Wes. Wes, you've really gone above and beyond here. Thank you so much. Nathan, I really appreciate you having just your knowledge and presence and, on this stream. So thank you so much.
It was a good day. I appreciate hearing from everybody. It seemed like there were a few great themes today. A lot of stuff about security, a lot of stuff about observability, like how to know what's going on in your cluster, and a lot of stuff about cost optimization and sort of making sure your capacity matches with what you actually need. And then we had the great keynote from Nate Tabor. He confirmed that the team is also working on more features like this too. One-click upgrades.
Yeah.
They'll upgrade your node group as well as your control plane, as well as your add-ons. So all around, I heard EKS and Kubernetes is getting even better on AWS, and that makes me excited.
Yeah, I'm excited for EKS's future, for Kubernetes' future in general. I really see bright horizons coming in the future. It seems like everything's gelling together.
All right. Well, I brought up that survey feedback link one more time. Thank you so much, everyone, for joining us today. It was a marathon of information. And if you missed part of the stream and you'd like to watch it again, you can always refer back to our recording. You can usually find it as a video on our Twitch channel, as well as recorded segments will usually go onto our AWS on Air YouTube channel as well. So you can go back, and there's a 10-year roll as well to watch parts of the show that you may have missed.
Awesome. All right, folks. AWS Container Day EU 2023 is over. Thank you so much for attending. Really appreciate you.